It's wonderful to see you all, and a super warm welcome to all our international guests here. You've come to Stockholm in the best month of the year. And the Stockholmers are laughing maybe, but I really do think it is. It's if you go down to the old town, the medieval city, and the square and the Julmarknad, it's fantastic. In a few days' time, we have the Nobel celebrations and Nobel Week lights lighting up the city. It's absolutely wonderful. So warm welcome. I'm Owen Gaffney. I'll be the MC for the day and try to keep us all on track. I'd first like to thank all our co-conveners for what's going to be, I think, a remarkable day of conversations. We have Future Earth, Stockholm Resilience Centre, the Bolin Centre, of course, the Royal Swedish Academy of Sciences, Bayer Institute, Anthropocene Laboratory, and the Centre for Anthropocene History. So a big group of the sort of the intellectual institutes around Anthropocene thinking have come together for this. And why have we come together? Why now? Around this time last year, a few of us were realizing that 2025 is an important year. It's the 25th anniversary of Paul Crutzen's remarkable intervention at an international geosphere-biosphere conference. That has sparked this idea of the Anthropocene that really brought together a lot of the thinking that had been happening actually over many decades into a single concept. And now we see, 250,000 research papers at least using the term Anthropocene. That's one reason. The second reason is it's the 80th anniversary of the Trinity test, Hiroshima and Nagasaki, and this moment when humanity had the power, an extraordinary power, the power to destroy itself for the first time. And is it humanity? Is it, just a small group of very powerful people? And with these kinds of things we'll talk about today, the power dynamics within the Anthropocene. And the third reason is that last year there was a decision by the International Commission on Stratigraphy to reject the formalization of the Anthropocene. And I think this is one of the first major symposia of people from many disciplines to really think about that, talk about that decision and what it means. So they're the three reasons. But we don't want just to be looking back over the last 25 years. We want this to be very much forward-looking, a forward-looking symposium. What's the next 25 years, the next 80 years? What does that mean in the Anthropocene? So on that, I will now introduce the president of the Swedish Academy of Sciences, Sven Lidin, to give some opening words.
Well, thank you very much, and welcome everyone to the Bayer Hall for this timely and very important meeting. We fear change, and we fear change with a good cause. Change is uncomfortable and demanding. Change is difficult and disruptive. But change is also necessary and unavoidable. Change is not a choice. It will happen whether we like it or not. The choice we have is to whether we are to be the passengers of change or the drivers of change. Anthropocene is here. Humankind is to a greater extent than ever in charge of our own destiny. This is scary, but it's also hopeful. The image of Armageddon is no longer a giant volcanic eruption or a meteor hurtling towards Earth with us as bewildered spectators. Armageddon is a choice. It's left to us. Never before has the human race had so much power. Never before has the human race had so many choices. The frightening fact today is not that we are powerless, but rather all too powerful. And with power comes accountability. It could be argued that Anthropocene is but a word. The reality of how humankind is changing our planet would be no less real without it. But well-chosen words can be transformative. Their denotations and connotations open our minds to new ways of thinking. Conversely, the suppression of language is a core strategy of silencing dissent. New realities create the need for new words. Paradigm shifts are not only scientific, but linguistic. The International Geosphere-Biosphere Programme, IGBP, was based at the Royal Academy of Sciences from its foundation in 1987 until it morphed into Future Earth in 2015. IGBP was an outstanding example of the value of international scientific coordination. IGBP coordinated research on Earth system processes at a regional and global scale. It contributed to building the field of Earth system science, and at a now famous scientific committee meeting in the year 2000, the vice chair of IGBP, Nobel laureate Paul Crutzen, first used the term Anthropocene. Ambio, our Academy's journal of the human environment, has been an important outlet supporting this concept. We are gathering here primarily not to reflect on a changing planet, but to reflect on how science must change and evolve to respond to this new knowledge. To support society to internalize this profound new responsibility of ours. Today, on December 1st, the Academy publishes a report on the current state of thinking regarding Anthropocene for the Swedish publishing student, Vetenskapen säger, om Anthropocene. So very much welcome to the symposium. Thank you for being here. Thank you for being responsible.
Thank you. And now I'd like to invite up Lina Gordon, the Director at Stockholm Resilience Centre.
Thank you everyone for being here. I realized in preparing for this opening remarks that it is now almost 70 years ago that Paul Crutzen was recruited to Stockholm University. He was recruited to be a programming support for Bert Bolin in his efforts at the Department of Meteorology at Stockholm University. And it's quite remarkable that this group, the imprints they have had on the world in both sort of shaping the IPCC work on climate change and the concept of Anthropocene. The Stockholm Resilience Centre that I direct can in many ways be seen as sort of a child of the Anthropocene. The Anthropocene is not just a new concept, but also a new way of thinking, and it requires that we really integrate disciplines and different worldviews and different ways of thinking. So now, if we look ahead, 70 years from now, we will be just at the border of the 22nd century. And if I think about what I think are needed in order to deal with this new era, I think of two different things. The first is human ingenuity. I mean, there is no way that we can solve the massive challenges that we're facing without new innovations and new technologies. But the other thing is human care and respect. If the Anthropocene names a time where humanity's imprint on the earth became impossible to ignore, then this next era must be an age where we learn to reconnect. This is not an age defined by dominance, but relationships that recognize that the future of a livable planet for humanity is inseparable from the remarkable diversity of life on this planet. And I think this is something both to celebrate and understand better. And I hope that we can do today. Thank you very much.
Thank you, Lina. And now I'd like to invite up Wendy Broadgate, the Director of Future Earth.
Well, hi, everyone, and welcome on behalf of Future Earth. We're the world's biggest network of global sustainability scientists. We've been based at the Academy here for 10 years, walking in the feet of, following the roots of IGBP, as Sven kindly introduced. So through the IGBP, the concept of the Anthropocene was both born, but it was also incubated. IGBP held its science committee meeting in Cuernavaca, Mexico in the year 2000. And in the preparations for this meeting, I've been having some dialogues with the participants from Cuernavaca and uncovered some quite interesting discussions, anecdotes, and emails from the time. It's been said that I'm being presented with the accelerating trends in the Earth system. Paul Crutzen was rather frustrated and said, look, he stood up and said, we're no longer in the Holocene. We're now in the Anthropocene, where humans are the biggest driver of change on the planet. This needs to be defined with new language. Here's an email from March 2000, when Paul, following up from that meeting in Cuernavaca, he said, dear colleagues, during the recent IGBP meeting in Cuernavaca, I thought of the word Anthropocene to describe the human impact on the environment over the past 2 millennia or so. Encouraged and somewhat surprised by the positive reception by several of you, and with your advice, I'd like to submit a note to an appropriate journal to launch this expression. Comments are most welcome. This may become a fun discussion. His first note on this was published in the IGBP newsletter in May 2000. But finally, we would like to dedicate this symposium to the memory of Will Steffen. Will Steffen led IGBP through this period of synthesis, the first synthesis of IGBP, which led to the formation of, or the articulation and incubation of the Anthropocene concept. Will was an amazing scientist, a great communicator, and a fantastic collaborator. His talent for engaging diverse communities, testing and developing the concept of the Anthropocene triggered the wide adoption of the term as we know it today. It led to the development of new groundbreaking concepts such as the planetary boundaries, tipping points, and planetary stewardship. Very personally, he hired me. It's the reason that I am in Sweden today. I came to be his deputy in the year 2000. He was a great mentor and friend. So I'm excited to open this symposium to discuss the Anthropocene paradigm shift. We'll be taking stock of the last 25 years, but we'll also be looking ahead to the future. What will the next 25 years of research look like? What are the research challenges and opportunities? Where will the next concepts emerge from? How will international science cooperation look in this turbulent and divided world? And how can research connect with policy and society to support planetary stewardship? So without further ado, I'm delighted to introduce our keynote speaker, Professor Johan Rockström, from the Potsdam Institute of Climate Impact Research. Thanks, Johan.
Thanks, Wendy. Thanks, Sven and Lina, and great to be here with you at this really important juncture to take not only science, but humanity to the next level of stewardship of the planet. Because, in short summary, this is what the Anthropocene evidence has given us, that we are today, unfortunately, forced for the first time in academic, but also in human history, to ask the following question: are we at risk of destabilizing the entire system? Are we at risk of irreversibly pushing the planet on a drift away from livable conditions for the civilizational journey that we know it as modern humans on planet Earth? That's where we've come to. We are, in my mind, no longer in the Anthropocene. We're deep into the Anthropocene. We are, to quote my dear colleague and friend, yes, the late Will Steffen, hitting the ceiling of hardwired Earth system processes that regulates the stability, the resilience, and the life support on planet Earth. I want to just share you a few of the updates, how this brought us to the planetary boundary science that Katherine will be talking much more about, but also then give me a chance of sharing some of my perspectives of what is the Anthropocene really today and where are we heading into the future. Now, to start with, yes, it begins with Paul Crutzen in 2000, but who welcomes the humanity to the Anthropocene fundamentally? I would argue it's in 2011 when The Economist has the first big feature article on the Anthropocene welcoming humanity into this new epoch. This was actually triggered by a Nobel symposium at the Academy here, and I see Kalle, you're here with us, called Folke, which we hosted at the run-up to what became, in the end, the Sustainable Development Goals. So we have a very interesting Anthropocene science-driven policy impact at the time, which also led to this quite phenomenal reach out of establishing the Anthropocene as a general concept of the scale, the speed, and connectivity. As Wendy pointed out, the definition of the Anthropocene as us humans now being the dominating force of change on planet Earth, exceeding earthquakes, volcanic eruptions, solar radiative, natural variability, all of these still occurring, but now the anthropogenic pressure exceeds them all. We're completely intertwined. It doesn't matter where you live on planet Earth, we're all dependent on what the behavior is in other corners of the planet because it will hit back, the planet sending invoices back to the economy. Wendy was referring to this fun discussion that Paul Crutzen was going to trigger. Well, it actually led to a Nature paper in 2002, which was fundamental. And I just want to again emphasize the phenomenal work of the International Geosphere Biosphere Program here at the Academy, which was formed the basis for all the evidence that gave us the Anthropocene. And of course, it's based on the classics. The Great Acceleration graphs, published the first time, I think, in 2004 in the IGBP report, led by Will Stephan. This is the 2025 update. So we are now working continuously in updating these graphs. To the left-hand side, you have the socioeconomic hockey stick, and then you have the Earth system impacts in green. 1750 until today, on all the graphs, you see the evolution. Up until the mid-1950s, we have impacts, but they're linear. And then off we go in this exponential rise. We put in the high gear of the global industrial metabolism, and we start moving in this exponential rise. And today we are at the top of these curves, and we're starting to hit the ceiling of the pressure points. And the Earth system is starting to show its first signs of weakness. This paper is not published yet. It's coming out in 1 week or two. It's the Bill Ripple et al. Annual update of the state of the climate report, unfortunately concluding that all these curves continue rising. What you see here is methane, carbon dioxide, nitrogen oxide, all the curves that we're concerned about with regards to climate change. The one that concerns me most today is the one in the lower left-hand corner. I'll come back to this. This is the energy imbalance on planet Earth that is not only rising, it's rising faster than we had predicted. The classic to the right is also inspired by Will Stephan, inspired by IGBP and Anthropocene science, showing the extraordinary stability of the Holocene and the spike. You all remember Al Gore's winching up on his elevator, trying to follow the pathway to the 3.1 degrees Celsius of warming, the path we're heading towards. The path that we can today, based on Anthropocene science, conclude is a path to nothing but disaster. There's no scientific evidence that we can support the world as we know it outside of the Holocene in a world that exceeds even 2 degrees Celsius of warming. That's where science has come. Anthropocene science has really been a basis for us to be much more clear in our scientifically based messaging to the world. But here's the concern. The concern the Anthropocene is no longer just a pressure, it is starting to show signs of Earth resilience weakness. These are the curves we all talk about. Temperature on the left-hand side in the atmosphere. Then you have the sea surface temperature rise on the right-hand side. And the concern is that the last decade shows the first signs of accelerated rate of warming. These are not fully statistically verified. There's a whole debate on what's causing it. Is it forcing? Is it feedbacks? The most likely conclusion is that it's a mixture. It's a mixture of forcing based on not that we are accelerating the rate of emission of greenhouse gases, but that we're reducing, paradoxically, the Faustian bargain, to quote Jim Hansen, namely we're getting rid of air pollutants, which bumps up warming, but reducing human health impacts. But it's also feedbacks. It's cloud dynamics and albedo. it is very likely the impacts of carbon uptake capacity going down in terrestrial ecosystems on land, which is really worrying if we're starting to see the first signs of a planet which has a lowering buffering capacity to the stress that we're causing from anthropogenic greenhouse gas emissions. So this is a big topic, and therefore we need the science on the lines of evidence that determine the stability of the planet. And I take these in 3 lines of evidence: that we're no longer just in the Anthropocene, but we're deep into the Anthropocene, that the Holocene is the reference point for the planet we depend on, and the tipping points are hardwired in the system. Push the system too far, and it will irreversibly drift away from livable conditions. This is why we need a safe operating space for human development on Earth. The depth of the Anthropocene is a big topic. Let me just summarize it briefly with just one graph, which is the planetary boundary science that Katherine will be following up on in the talk after here. We've identified the 9 Earth system processes that regulate the stability, the resilience of the Earth system. We've even been able to quantify, after 15 years of science, based on the Anthropocene research, inspired by tipping point science, the safe operating space to keep the Earth system in an interglacial basin of attraction that can support us in a Holocene-like state. As you see, 7 of the 9 boundaries are outside of the safe operating space, which is a very strong piece of evidence that the Earth is losing resilience, that we don't only have a climate forcing caused by the transgression of the climate boundary, which is the anthropogenic greenhouse gas emissions, but we're also losing the buffering capacity by transgressing the biodiversity, the fresh water, the land, the biogeochemical cycles boundaries, and even the novel entities boundaries. The ocean acidification boundary now being the first one, we also conclude has been transgressed in 2025. So we're doing a double error. We are putting a forcing for anthropogenic climate change while also reducing the strength in the system. I think this is what the Anthropocene truly is about. Therefore, to put it a bit bluntly, I'm sorry, I don't care about this decision. That the subcommission on quaternary stratigraphy decides that it cannot formally transition the label from Holocene to Anthropocene doesn't really matter from an Earth system science perspective, I would argue. It's already out of the box. The concept is well established, it's guiding science, and it's actually a very, very robust definition of the state of humanity on planet Earth today. We'll come back to this. I think these are the pieces of evidence with regard to the depth of the Anthropocene that we need to look most closely into. To the left is Carina von Schuckmann's fantastic work on summarizing the global energy imbalance. Just a bit of a reminder there. We emit greenhouse gases at a level that is causing the whole system into a disequilibrium. But 90% of the heat is not in the atmosphere, it's in the ocean. The planet is just a remarkable biogeophysical buffering, like a big thermostat, buffering and reducing the heat impact. It's only 1% of the heat that remains in the atmosphere, causing the climate crisis and the soon 1.5 degrees Celsius of warming that we're also concerned about because it's causing the droughts, the floods, the fires, the heat waves, the human reinforced storms we all are concerned about. But it's just a small fraction of the energy imbalance that we've caused that is represented in the atmosphere. The second part of this is this remarkable effect of the terrestrial biosphere. The classic work by the Global Carbon Project, also initiated through the International Geosphere Biosphere Program. You see the hockey stick of emissions. Above the zero line here, in red are fossil fuel emissions, in orange are the degradation from ecosystems. But the Earth system has, over the last 150 years, this remarkable capacity of buffering. In dark green, the ocean, in light green, natural ecosystems on land, not managed ecosystems, not the agricultural system, just natural systems. So it's only the blue part here that has caused the warming so far. And just look at this graph. The more we stress the system, the more the Earth system in a resilient state has been helping us. The problem is, you may even see it when you look carefully at the graph, a flattening of the light green curve here. We're starting to see the first signs of boreal forest and temperate forest tipping over from sink to source. The Brazilian part of the Amazon is no longer a carbon sink. Can you imagine? Planet Earth's richest biome on land is to a significant portion no longer helping us. It is starting to show signs of self-amplifying. This is a system sending warnings to us that we're no longer in the Anthropocene, we're deeper into the Anthropocene than we had anticipated. Secondly, tipping points are hardwired. We've been mapping these. Actually, the first tipping point science paper came out in 2008. The first planetary boundary science paper came out in 2009. Not a coincidence. It's an evidence base that we've been building on to come to the point of the planetary boundary definition. Why? Because boundaries are set to avoid crossing tipping points. That's one line of evidence we're using. Here they are, the 16 tipping element system that regulates, as far as we understand today, the climate system. 6 of them are in the Arctic. Can you imagine? We're living here in Stockholm in the ground zero on planet Earth. You have the Greenland ice sheet, you have the boreal permafrost, all connected through the AMOC via the Amazon rainforest. 3 of them are down in Antarctica. You, of course, also have the tropical coral reef systems. At COP30 in Belém, we were forced to put out a science statement which shows that if we exceed 1.5 degrees Celsius of global mean surface temperature rise, we're likely to knock over planet Earth's 2 richest biomes, the Amazon basin and tropical coral reef systems, across irreversible thresholds, which would amplify warming but impact livelihoods for over 1 billion people. So this is serious and is happening in real time. Third and final, Holocene is unique. It is what enables human civilizations to develop. And we have the data for this. This is one segment, the last 20,000 years, how we leave the last ice age, minus 5 degrees Celsius of mean surface temperature on Earth. The 0 line here is the 14 degrees Celsius of pre-industrial mean temperature on Earth. Just look at the stability here. This is extraordinary. This is an interglacial 12,000 year period of 14 degrees Celsius plus minus 0.5 degrees Celsius. So when you run into climate skeptics talking about because of the 10th invading Denmark during the Little Ice Age in the early 17th century, or when you have Vikings sailing across the Atlantic in the warm medieval period, yes, these are natural variations that occurred within plus minus 0.5. Now we're heading towards a point, because of the great acceleration in the Anthropocene, that has taken us today to 1.4, and that we're heading towards 3.1 within 75 years. And when we look back paleoclimatically, we today have the evidence that the corridor of life that we depend on is a 14 plus minus 0.5. But if you take the whole quaternary, if you would wind it back 3 million years, as far as we know today, we never even exceeded 2 degrees Celsius of mean temperature on planet Earth, and a deep ice age is minus 5. And we've had this heartbeat of the planet through 100,000 year ice ages and short interglacials. And we've only existed as modern humans during 250,000 years here. So we've only been around for 2 ice ages, and then we came into this phenomenal stability in the Holocene. And what did we do? We went from living in caves as hunters and gatherers, and we went through the Neolithic Revolution. We established ourselves as farmers. We took the kickoff to the civilizational journey as we know it. This is proof of something quite remarkable, that the planet we depend on is the Holocene. The beauty of this is, of course, that gives us a reference point for measuring a safe operating space. The drama is that the Anthropocene is therefore a real threat to livability for humanity on Earth. So to close this, what is the Anthropocene then? Is it a trajectory or is it a new state? This was one of the beautiful debates we had, Katherine, with Will and colleagues. And I would still argue that the Anthropocene, luckily for us, remains a trajectory. We haven't burnt it. It's not yet a state. And just to walk that through, Will led this paper that we published in 2017, where we tried to test the hothouse Earth hypothesis. If we anthropogenically burn up to 1,000 petagram of carbon, equivalent to 2 degrees Celsius of warming, how would the Earth system respond? Is it still so resilient that it would keep us in an interglacial basin of attraction? Or would we start having Earth system feedbacks that would amplify warming and drift us away from stability? We concluded at that time that Earth system feedbacks could actually push the temperatures by roughly 0.5 degree Celsius, which could take us already, if we exceed 2 degrees Celsius, outside of this stabilized, beautiful little circle that we've been following over the past interglacials and move us out in the hothouse Earth trajectory. This was an hypothesis, and we're today working on this, putting it into Earth system models, and I'm just sharing with you here unpublished data from our ClimareX Earth system modeling work at the Potsdam Institute, showing that yes, there is a deep reason for concern. What you see here is that if we're able to veer around and return back to a safe operating space now, we could follow the green path that would take us back and stay within an interglacial equilibrium state, meaning the Anthropocene never becoming anything but a trajectory. But the red curve here, the middle one, is the one we're following. It is one with a very basic configuration of the models, no tipping points, no surprises, a climate sensitivity of 3 degrees Celsius, a doubling of carbon dioxide. But if we burn fossil fuels, that takes us up to the 3 degrees Celsius. The runs that we've done with a very mainstream model is that we do not return. We get stuck up until the year 3000, up at this unlivable state of 3 degrees Celsius of warming. And then finally, if we have underestimated climate sensitivity, if what I've showed you is a first sign of a planet losing resilience, if there are tipping points that we may be crossing along this journey, then climate sensitivity will be slightly higher. And here you have a 4 degrees Celsius of climate sensitivity level, which is not in any way, deviating out from the plausible, because the CMIP 6 runs showed climate sensitivity ranges from 2 to 6 degrees Celsius. We would get stuck up at 4 or 5 degrees Celsius of warming. And these are mainstream runs with no Earth system feedback surprises. So there is real reason for concern. My concern is particularly what you see to the left here, which is the Earth energy imbalance, which is starting to rise even further. We are today probably at more than 1.5 watts per square meter of heating in the pipeline, which means that even if we turned off emissions today, we would be exceeding 1.5, and we're heading, as we know, well into overshoot. To the right here, you see the first mapping of forcing feedbacks if these systems cross their thresholds. And the drama here is that the Planck feedback, which is the one that returns warm long-wave radiation to space, which is like the cooling feedback of the Earth system that enables us to avoid that the system simply goes off in an equilibrium state, is at risk of being outpaced by these number of positive feedbacks that are starting to add up. So even if permafrost and ocean solubility pump and snow cover, albedo changes, wildfires may be small in terms of what they individually contribute if we cross their thresholds, if you add them all up, it becomes a number of small creeks that becomes a river. And if those add up to exceed the Planck coefficient, then to quote Christoph Heinz, one of the leading oceanographers at the University of Bergen, that if positive feedbacks grow larger than the current expected negative cooling Planck feedback, then we have a runaway situation. I would argue that this is one of the big scientific questions for Anthropocene science. Are we at risk of coming to a point where anthropogenically triggered Earth system feedbacks, positive feedbacks, start adding up to a point, fires, permafrost, Amazon degradation, bark beetle outbreaks, fires in temperate forest, all of these small add-ups of feedbacks that leads to more amplifying warming, when they exceed the Planck cooling feedback, is that the point when Anthropocene shifts from trajectory to state? I would argue yes. I think that's the theory, that the moment Earth system feedbacks exceed the Planck coefficient, that would be physically and mathematically when the Anthropocene becomes a state. The Earth Commission is addressing this, and we are concluding from the Earth Commission work that we are still in the Holocene. We have this little window still open. We're just at the edge of the Holocene basin of attraction. And the big choice we have now, and that's where I agree in the introduction here by Sven, it's a choice. Failure is not inevitable. The choice is, can we veer away and have a safe future within a managed Anthropocene with the technologies and wisdom that Lina points out? Or will we start drifting and allowing ourselves to this self-amplified path that would take us towards unlivable conditions? The Earth Commission is broadening this to include the social sciences. As you may know, the safe operating space, when you add the significant harm levels, shrinks even further. The climate level goes from 1.5 degrees Celsius of safe boundary to 1 degree Celsius if you take human harm levels into consideration. I think this is something really important to consider. And then finally, to say that the Anthropocene science, if you take everything I've shared seriously, it translates also legally and governance-wise. We put out a paper quite recently suggesting, and I see Frank Biermann is here and colleagues that have been leading around the political science and earth system governance work that we probably need in the Anthropocene to redefine what we mean by global commons. They can no longer just be the systems outside of national jurisdictions that are owned by nobody and therefore are owned by all of us, Antarctica and the high seas and the outer space and the atmosphere. They probably have to include all the tipping element systems because we all depend on them collectively. If a tipping point system crosses a threshold, it will hit back on every one of us, irrespective of where we live. And that these systems are across the entire planet. They are all the biosphere systems we all not only depend on, but that we fundamentally have emotional relationships to, in the ocean, on land, in the cryosphere, across the entire marine system. This is what I think is inspiring with the Anthropocene as well. It forces us to think in terms of stewardship of the planet. We've therefore taken the science to a new level, to every year now do an update on planetary boundary science, and we conclude, just as a final verification of what I've been trying to say here, that yes, we're outside of the safe operating space. We're no longer in just an Anthropocene simple terms. We're starting to come deep into the Anthropocene, but we're still in this danger zone of uncertainty in yellow. We haven't yet crossed the red line into the high-risk zone of truly pushing the planet away from stability. The window seems to still be open to veer off, but boy, is it a deep transformation we have to do, and it has to go very, very fast. Therefore, it's fantastic to have this opportunity for the dialogue here to see how we can move this agenda forward, because it's fundamentally about habitability, stability, and resilience for humanity on Earth. Looking forward to the discussion. Thank you.
Thank you, Johan. Thanks so much. And we'll invite Johan back for the discussion at the end of session one. So we're going to start the first of the 4 sessions now. And this is on the trajectory of the Anthropocene, the Great Acceleration. And myself and Wendy will co-host it.
Yep. Yeah, so this just as thanks for your keynote, Johan, and thanks for the introductions. It doesn't really take much introducing here, but as Johan said, the Stefan et al. Book from 2004-2005 first presented the first Great Accelerations, and they were beginning to be developed at the Cuernavaca meeting, and hence was stimulated in the evolution of this Anthropocene concept. These have been updated over time with Will, Owen, myself, and others who are in the room. Did an update in 2015, and now by 2025 there are multiple updates underway. Johan presented one. Jan, who is here, has another underway. And
I was just going to, and then coming back to Johan's points on the Great Acceleration. I mean, just and we're his methane, for example. Back in the last update we did, we actually said in the paper, and other papers at the time were saying, oh, it looks like methane is plateauing. And it looks like a plateau. And we seem to have a fairly good understanding of the processes. And it turns out we were wrong. It then starts shooting up again. At that time as well, the public discourse, the political discourse, was around hiatus in temperature globally. And the scientific community was doing everything we could to convince people that this wasn't a hiatus. The models were reliable, and we'd expect a shooting up, and we've seen that, and here it is. And within the Great Accelerations, another thing, like the sea level rise wasn't in the original Great Accelerations or the updates, and now we're looking at should it be in the Great Acceleration? And this is where things start getting, the interactions become interesting. Oops, what have I done there? The interactions with sea level. So, we had a leveling off since the 1950s or so. And there's several explanations for that. But one of the reasons is the global dam construction. and another great acceleration trend, which actually then masked some of the rise and made it feel as if it's more of a linear trend. And now we've seen a doubling from 1993 up until 2023, a doubling in sea level rise, etc. So there's so many things we don't understand. So we're also in development of a paper on looking more deeply at the criteria, the selection criteria for the Great Acceleration and expanding that analysis out. And there's so much still to know on these interactions as we go deeper into the Anthropocene.
So without further ado, we will get on with this session. And I'd like to introduce Katherine Richardson. She's a professor in biological oceanography and a leader of Copenhagen University's Sustainability Science Center. Katherine is going to be telling us about planetary boundaries, guardrails for managing the human-Earth relationship.
There it is. And not least of which, Johan, for opening the party here today. I have 10 minutes to tell you about planetary boundaries. So, and a few other things about it. But the Anthropocene, actually, Earth system science really started with Brzezinski in 1926, but it had a slow and not very exciting life until about the time of the Anthropocene. And it's had a real great acceleration, as it were, in the last 25 years. And one of the things about Earth system science is that it recognizes that this planet isn't unique because it has a climate. Everybody talks about climate, but climate's not very special. Every planet in our solar system has it. Just the energy balance. We've been seeing all these wonderful pictures of it. What makes our planet unique is the fact that there's life. And Earth system science recognizes the fact that until very recently, the internal drivers of the state, the condition of the Earth system as a whole, Earth system science considers the Earth as a complex, partly self-regulating system. And the internal drivers, until very recently, were the geosphere, and I'm including not only the non-living parts of the planet, but also the energy balance there, and life, the biosphere. And interestingly, we call it the biosphere and not biodiversity in planetary boundaries. We started in 2009 calling it biodiversity, just like everybody else, and worrying about extinctions. And then in 2015, we said, oh, wait a minute. No, it's not just numbers of species. It's also a question of their function and what they're doing and this interaction that's happening here. Now, within the last 100, 150 years, well, first of all, this interaction here, of course, means that the biodiversity crisis must be just as important as the climate crisis. And that's one of the things the Planetary Boundaries is trying to communicate. But within the last 100 to 150 years, a new force has come along that could change the overall state of the Earth system. It doesn't do it on its own directly. It does it by operating either through the geosphere or the biosphere or both. And for me, this is what we call the Anthropocene. I'm just like Johan. I really don't care what the geologists decide to do. It doesn't matter. The Anthropocene is simply our acknowledgement of the fact we realize that we have the capacity to change the overall conditions on Earth. And of course, our impacts are becoming greater and greater, as Johan has been showing us. So for me, sustainability is just about making a management. Making management, we manage our relationship with the planet as a whole. Our ancestors learned very soon after they stopped their nomadic life and traded their nomadic existence for a fixed address, they learned very soon they were going to have to manage their relationship to the local environment because they were getting sick from polluted water, polluted with their own bodily products. They were running out of game, and so on. Then we realized when we were more, we needed to do regional management. What I believe we're seeing today with our recognition of the Anthropocene is that we need to manage at our relationship with the planet as a whole. And that is what the planetary boundaries are all about. Because if you're going to manage your relationship with the planet as a whole, you need some kind of guardrails. How much is too much? And I said that sustainability, if you say that sustainability is this management, then the environmental component of sustainability becomes making sure that our demand for the Earth's resources is within the supply. And so then we have to try and figure out what the supply is. That's what we try and do in the planetary boundaries. The social component is how are we going to share those limited resources with everybody that's here and all other living organisms. But of course, the planetary boundaries itself deals only with the environmental component, and then there are Earth commissions and all sorts of things that try and bring the people into it. So we found in 2023 that we were on the wrong side for 6 of the 9. Now the planetary health check says 7 of the 9. I think that's probably right. We wrote in this paper that it was so linked, if we just increase, it was right on the edge, and so if you increase the CO2 concentration in the atmosphere, you would cross the boundary. We increased the CO2 concentration in the atmosphere, and guess what? Now people are saying we've crossed the boundary. Now people say, well, there's several important things about this. One is, a lot of people look at it and they say, well, the boundary's in the green area here. Ugh, never mind. The boundary's in the green. They say, oh, well, we're on the wrong side and nothing really bad has happened. It can't really be. I like to think of boundaries being like your blood pressure. If it's over 120, over 80, it's no guarantee you're going to have a heart attack or a stroke, but it does increase the pressure. So we're on the wrong side. In the 1990s, we were either on the wrong side or very close to being on the wrong side. Paul always maintained we were on the wrong side. It's kind of hard to make the numbers work now, but close to being on the wrong side, at least for the depletion of the ozone layer. We're back in the right, in the safe operating space now. People say, why 9? Well, this is not, and it's really, really important to emphasize this, that the planetary boundaries is not an attempt to identify everything that's important in the Earth system. It's sort of like, again, if you think about blood pressure, when you go to the doctor and they do a blood test, they don't test for everything that's important in the body. They test for indicators that show what's the overall status of. So what we've tried to do is to get indicators that tell us about the health of the chances, the risk of changing the state of the Earth system. And I think you could have put these together in a different way. I don't think there's anything absolutely magical about it. But we're still talking about it, but our belief until now has been that we've really caught something that represents the really important things here. So as I say, I like to think of it as diagnostics or acupuncture. Where can you put needles in? Where can you? I mean, we say in planetary boundaries we've had 3 iterations: 2009, 2015, and 2023. 2015, our byline was guiding human development, humanity's development on a changing planet or a changing Earth. And I think to guide, this has to be a tool for decision makers. And I think we have to be really careful not to get it too complicated. Already dealing with 9 is tough. And if we're going to put more in, which it's fine if we can find things we haven't actually captured. But if we're going to put more in, I think we have to think about the user as well. This isn't an Earth system model. Finally, just to try, and I was asked to try and set this a little bit into perspective, I do think that, I used to think that all decision makers really want to base their decisions on science or knowledge. I've realized in the past couple of years there's at least one exception. But I still think most want to base their decisions on good science. And people say people don't listen to science, decision makers don't listen to, yes they do. But sometimes it takes a very, very long time. Galileo got imprisoned in 1633 for saying he thought Copernicus was right and the Earth was revolving around the sun and not the other way around. When did the Catholic Church say sorry? Well, they didn't actually say sorry. They said there might have been some mistakes in the Inquisition in 1989. So it takes a long time. Darwin's shock society. Those of us who've grown up with evolution and evolutionary theory like to think we'd jump on Darwin's train as soon as it left the station. It took a really long time, and if you live in Kansas, people still But I think most of us today accept the fact that we are an organism that have evolved just like all others. But I think we're in a similar sort of a transformation in society today, in that we're realizing that we are part of an ecosystem. And I think that transition started when we got pictures of the Earth from space. And even if you look in the Brundtland report, it says in the very introduction that those pictures may have the same effect on society as the Copernican revolution did. And I think it's no coincidence that Planetary Boundaries has grown up in this period when I believe we're beginning. We're all on a journey, and some people are farther along than others. And some people argue that Planetary Boundaries is leading. I'm not sure. Maybe it's actually mirroring the way we're beginning to think about our role and our need to steward or to manage our relationship with the planet. Thank you.
Thank you so much, Katherine. Fantastic. And we'll come back to questions at the end of the session. Our next speaker is Boom-Soon Park from Korea, from South Korea. And Boom-Soon Park is talking about historicizing the Great Acceleration, the Asian perspective. We've had several conversations over the last few months about Boom-Soon's work. He is KAIST Endowed Chair of Professor in the Graduate School of Science and Technology Policy at the Korea Advanced Institute of Science and Technology, founding director of the Center for Anthropocene Studies, which he leads research on the sort of Asian meanings of the Great Acceleration, controversies in stratigraphy, and historical studies of subterranean environments. And you're a member of the Anthropocene Working Group. So welcome to Stockholm, Boom-Soon Park.
Wow. Thank you, Owen, for your kind introduction. I'm truly pleased and honored to be here, and thanks for your invitation. I'm trained as a historian, history of science, so my talk is going to be dealing with science, but from the historian's perspective, it's going to be a little bit different, but there will be some data, but there is some stories. And I'm going to talk about Asian perspectives on Great Acceleration. In other words, I'd like to explore what it feels like living in Asia during the Great Acceleration. Why do I ask this question? Because Asia matters for understanding its trajectory, its complexity, and its social consequences. Let me say a few words about GA as a concept. It is well known that it was first proposed at a Dahlem workshop in 2005 as descriptive evidence of the Anthropocene. Of course, though not yet in a geological sense. In this photo, you can see John McNeil, Paul Christian, Will Stefan, and others. The wording is quite clear. There is a rapid acceleration of human impacts on the atmosphere. Yet the report also noted GA's complexity, that is to say, the possibility of both deceleration and non-linearities, such as tipping points. Thus, GA was never meant to resemble a mathematical formula, nor to suggest acceleration would continue indefinitely in the Anthropocene. What is important is that the GA was introduced as a metaphor, echoing Karl Polanyi's 1944 book, The Great Transformation. His key idea was that the self-regulating market system is not universal, but historically exceptional. The Great Transformation then referred to the transformation from the 19th century laissez-faire economic system, which collapsed with World War I in 1914, to measures taken by increased state interventions, such as Soviet social planning system and the New Deal in the United States. So Anthropocene scholars saw an interesting parallel between Polanyi's notion of embeddedness of economic systems in societies and the notion of embeddedness of Earth system in societies. After 1945, Polanyi saw the coming of another great transformation, which was symbolized by the mushroom, born from the forces responsible for our own origins. This quote is from his unpublished paper written in 1958. That there is an archive, and then the daughter and others collected them, and then published the paper book in later, 2014. Polanyi regarded this post-war situation as an outcome of Western culture since the Industrial Revolution, which had allowed science, technology, and economic organization to reinforce one another in unrestrained ways. He therefore stressed the moral responsibility of the West to discipline its own children. What about the East? To Polanyi, China, India, and Japan, and others were otherworldly, seemingly offering alternative socio-economic systems to the Western world. That is to say, he didn't really study the Asian countries, but he referred as a sort of alternative systems, economic system exists out there. The Polanyi's idea is partially true, as Asian countries quickly caught up with the West during the Great Acceleration, including the production of atomic bombs. As we all know, North Korea has more than several, for example. These are the two sets of the 2015 Stefan graphs. I have tried to draw similar graphs with the data available in Korea. This is what I have. Working with the researchers at the Center for Anthropocene Studies at KAIST, I have produced 20 graphs, leaving out 4 due to lack of data. Three missing data. 3 of the missing data graphs are water-related indicators such as ocean acidification, nitrogen to coastal zone, and water use. Looking more closely at the Earth system trend graphs, we can see that atmospheric data were collected only after around 2000. But if you sort of connecting the previous Stefan graphs, it's well matched. There is not entirely colliding, but there is some trends going together. And the shrimp aquaculture follows a GA pattern, though accelerating around 1990. Marine fish capture graph shows a sudden rise in the 1970s, but tapers off later. Forest loss increases over time, whereas domesticated land is decreasing. On the socio-economic trend side, we can see GA type changes emerging 1980, while fertilizer consumption and tourism data present more complicated patterns. If we look at the energy production from coal-fired power plants, we can see Japan, Korea, and China taking off at different times. However, when combined, the overall trend simply follows China. You know why? We all know that the primary geological marker of the Anthropocene, plutonium-239, provides a synchronic takeoff point, namely 1952. By contrast, secondary markers such as SCP, fly ash show regional variations depending on different stages of the industrialization. As far as SCP is concerned, we can see the great acceleration occurs a few decades later in Asia. Population graphs are also interesting. The rate of population growth has significantly declined, although total number continues to rise. The orange line represents the age group 15 to 64, and the blue line represents those 14 and under. Japan, Korea, and China show similar patterns, although the timing of declining differs. So, so far I have shown the Korean case of the Great Acceleration and some comparisons with China and Japan. What can you say is that although starting points of the acceleration may differ, they all show similar patterns. Furthermore, the shapes of GA graphs after the initial acceleration will be an interesting point for further studies, this complex part. Amitav Ghosh, in contrast, has made a powerful argument about Asia's centrality in the Anthropocene. Asia is crucial, he argues, not only in terms of its contribution to GA, but also in its role in adaptation to and mitigation of Anthropocene conditions. Thus, he calls for overcoming Eurocentric perspective. Ghosh's main point, this is the summary of his book, his main point is that we should turn our attention to disasters and their victims. I think this is an important point that should be included in the discourse of the Great Acceleration. I tried, but found it very difficult to produce meaningful graphs with disaster records, and please let me know if you know how to do that. Asia's centrality lies in the number of victims of the climate crisis, but also in its distinct way of contributing to the Anthropocene through relatively small expansion of individual ecological footprints, but a much larger expansion collectively. So, Ghosh also argues that Asia reveals that the planet can no longer afford the patterns of modern living anymore. It's sort of a revelation of the limits of the modernity. Although Ghosh's thesis is compelling, I feel it's still focused on input, output, cause and outcomes of the Great Acceleration. What about the processes? What about the social changes? For this, I draw on the work of Korean sociologist Kyung-Seop Chang, well known for his thesis on compressed modernity, proposed as a critique of dominant theories of modernity. I found it will be very interesting to imagine the acceleration of the great acceleration as a driver of compression in society. Compression that the people must endure and adapt to. He didn't say that, but I tried to connect the GA and the compressed modernity. According to Chang, compressed modernity creates conditions in which social cultural changes occur in an extremely condensed manner with respect to time and space. What's the result? As he puts it, a dynamic coexistence of mutually disparate historical and social elements. I can explain go on and on, but this is a better way of explaining it. The 2019 film Parasite by director Bong Joon-ho captures this aspect very well. Social strata are visible in people's dwelling. Vertical politics operates through these stratas, and the entire system is highly unstable. Here, on the left, is cuts from film, contrasting the modern style house, the house that has a lot of stairs from the basement to the first floor to the second floor and going up and down. The actors are doing this, probably you remember that. And on the bottom, the semi-basement flat, it's called the banjiha, where lower class people live because it's simply cheap. On the right is the part of Seoul where flood scene was filmed. It's a real. I'm very familiar with this kind of town structure. It seems to me that we can develop a GA as a lens through which to examine and compare the similar yet different ways modernity has emerged and developed in the second half of the 20th century. In Korea, for example, we see layered and competing manifestations of social forces under For example, Confucianism, militarism, developmentalism, neoliberalism, at least in Korea. It's very competing, and it's competing at the same time. So the sociologist Chang said that Korea has become a multiplex theater. You can go to the theater, you can choose whatever you want to see. If you want to see a traditional Confucian modernity, you got it. If you want to see a sort of a military developmentalist the modernity, you can get it. Neoliberal, yes. I mean, there are the menu. So that's why it's very dynamic and exciting. And I don't know, how can I say, this is an ideal place, but it's a very dizzying and then place. One of the, as I said it, one of the most visible outcomes is a dramatic change in the family structure and family relations. Because to survive in this kind of environment, people have to adjust and then have a team play, and then family becomes a team as a unit for survival. And then for that, the education becomes a paramount goal to go up in the social ladder, and then also to survive. So in conclusion, I would argue the acceleration and compression are two sides of the same coin, both leaving lingering marks on the earth and in the human mind. Thank you.
Thank you so much, Bumsun Park. I mean, and that's fascinating. I think there's more and more research on the psychology and neurology of the Great Acceleration, what it's doing to us as people, as a species, etc., with our Stone Age brains trying to cope with all of this. Our next speaker is Professor Sarah Gabbett, who is Professor of Paleobiology at the University of Leicester. Professor Gabbett is leading the paleobiology research, exploring how technofossils, particularly plastics and other mass-produced materials, are entering the geological record. And you published a book earlier this year with Jan Zalasevich, Discarded, How Technofossils Will Be Our Ultimate Legacy, by Oxford University Press. Welcome, Sarah.
Thank you. Okay, so humankind are manufacturing and introducing to the planet a whole blizzard of new materials and new objects at dizzying speeds. Things like ballpoint pens, the clothes we're wearing, silicon chips, all the way through to, roads and cities. And it was during the Great Acceleration that much of this material really took off in terms of its manufacture. So, for example, this was a period of time when concrete overtook bricks as a major building material, and we introduced to the planet a kind of new geological rock type. It was also the time that plastics were promoted over paper and other renewable materials. So what I'm going to do in this talk is to discuss and think about these new human materials in terms of short timescales. So I'm going to think about what's going to happen to these new materials and objects once they're released into the Earth system. What are they going to do to the Earth system? I'm also going to take a much longer perspective, and I'm going to think about how long these materials and objects are actually going to last and potentially become Anthropocene technofossils. So in 2020, there was a tipping point, a symbolic tipping point, where all human-made stuff outweighed in mass all dry, living biological matter at 1.1 trillion tonnes. So think about this. This is a huge change in basically stuff that's on the planet. And I'm a paleontologist, as Owen said, and I've spent quite a lot of my career thinking about what happens to biological materials once they're no longer in use. What are the transformations and processes that take, you know, a once living organism into the fossil record? And the biosphere is extremely good at recycling biological matter when it's no longer in use. And the consequence of this is actually that fossils that were once life are incredibly rare. We don't really get that many things preserved, even though I spent my career looking at them. And of course, this can't be said for human-made stuff. Okay, this stuff has been manufactured to resist degradation, corrosion, and biological recycling. And because of this, the introduction of all this new stuff, we have this kind of shift in our thinking about material processing on the planet, and also as well the kind of processes of fossilization. And okay, and why does this matter? Why does this matter to us today? Because basically we are currently living at a time when our consumers' waste is already very substantial in the amount that we've produced. We're literally living in, on, and surrounded by our waste. So we really need to start thinking about what's going to happen to it. So to take this talk forward, and because I've only got now a few minutes left, I'm going to focus on plastics, which really have become, if you like, a poster child of materials, that the damage that our new human-made stuff can actually do to the environment. So we have made 11 million tonnes of plastic, which is quite scary because most of it's very light. And by 2050, we're projected to be adding a billion tonnes onto this figure every single year. And these figures are extremely rough, but generally we can think of about 30% of the plastic is recycled or incinerated, so kind of keeps in the system or moves out of the system. And then the other 70% is effectively waste. So let's think about what happens to these plastics when they go into landfills or in the environment. So this is Dandora, Africa's largest dump site, which is in Nairobi. And I visited it a couple of times now to collect plastic samples. This actually redefined for me what a tough day at work is like, because I spent the day amongst all the litter pickers there. So Dandora is an open dump site. So all of the plastic, all of the materials there are basically being blasted by sunlight and various other degradation mechanisms. And for this reason, ideally, we want our landfills to be, our dump sites to be encapsulated. In the Western world, most of our landfills are encapsulated and buried. They're encapsulated, of course, by plastic, massive sheets of plastic, and they're buried. And we think that this is out of sight, out of mind, and this is all good. But in fact, many of our historic landfills and our landfills today are going to be eroded, something that's going to intensify with increasing sea levels, back into the sea. So this is one in the UK. The US has 50,000 landfills that are on coastal floodplains at risk of being eroded and exhumed back into the sea. So on a global scale, this is of a real eye-watering magnitude and really quite scary. And then we have plastics that are released into the environment directly. And these are the ones, of course, that have really sparked interest in by the media, by the public, and politicians. Working out what's going to happen to these materials, these plastics, on their kind of cradle to grave journey is extremely complicated. And we're really only just starting to get a picture of this. Plastics themselves are an incredibly varied kind of family of different compositions, and they behave chemically and physically very differently. As well, they have additives that are very diverse, things like phthalates, flame retardants, heavy metal pigments. All of these can leach out of plastics when they're exposed in the environment. And then, of course, the environments in which plastics travel, they're very mobile. The environments through which they travel from source to sink are also incredibly varied. So it's incredibly difficult to work out exactly what's going to happen, where are going to be the big concentrations of plastics in the future and now, and what's going to happen. But we are getting there. But underpinning all of this is a big question, and that is, how long is this plastic going to last? How long is it going to be circulating in the environment, leaching out its chemical toxic load and so on? And this is a question that actually we really don't know the answer to. 50-year-old plastic has been exhumed from landfills and found in the environment and chemically analysed, and it's basically the same as its virgin chemistry. In the lab, I've spent a lot of time exposing different types of plastics to various mechanisms that we know degrade them. I've blasted them with sunlight. I have put them in water. I've put them in tumblers to abrade them. And I've even taken them to the equivalent of 5 kilometres into the crust in terms of the temperature and the pressure. When you analyse their chemistry, it's barely budged. So this material is incredibly resistant to degradation. So how can we get a handle on how long plastic is actually going to last? Well, we can look to the fossil record and to biopolymers. So some organisms manufacture polymers that are extremely similar to synthetic polymers. And this is one of them. This is this is on the right, a green microscopic algae, and it makes in its cell walls a chemical called alginam, which is a biopolymer, and it's almost chemically indistinguishable from polyethylene. Okay, so that's the modern one. We find exactly the same species in rocks 48 million years ago. We analysed their cell walls, and they also have exactly the same biopolymer, alginam. So this suggests that these synthetic polymers can also last under the right conditions, not just thousands of years or 10,000 years, but actually millions of years. And this is really a sobering thought, considering all of the plastic that we've already made that's out there, and also all of the plastic that we're going to add to it. Actually, plastic has probably only just started its geological odyssey of being transported, being buried, being exhumed, and so on, and cycling round and round, just like particles do in the sedimentary cycle. So just to finish on, all this is quite depressing, and there are things that we can do about it, right? I mean, we're all here, so we're doing something about it. We can think about all the stuff. Do we need another, mobile phone, pair of shoes, and so on? I think we also really do need to start thinking not just about plastic, but about other materials that we're manufacturing, thinking about their long-term fate. How long are these materials going to be with us in the Earth system and polluting our environment? And then finally, I guess there are things that we can do that kind of go beyond policy and technology, and are kind of more community-based and grassroots. So, shockingly, I'm ashamed to say, these are images from the city of Leicester, where I live, after a recent flood. This is the main river that goes through the city. And what's happened is that all of the bed load that was down, that you couldn't see, has kind of been, washed up and caught on the riverbanks and the vegetation, and it's absolutely shocking. I work with a local community charity, and we take groups of offenders and people who are involved in crime, and also kids who have been excluded from school, out into the city on the riverbanks, and we basically clean this stuff up. And so this is one of the tributaries of the River Soar, all of that stuff there, we dragged out of that small river channel. It's really shocking. And here are the guys working, and this is what happens afterwards. And I guess this has really changed my mind. This is really hopeful stuff, because when you're working with people, I can see their change in the sense of hope that they get, the sense of agency. Against this tide of bad news, people can do something about this. So I think this kind of grassroots action is also really good at a kind of completely different level. Oh, and I shall leave you. This is a fossil I made in my lab, but this is a classic fossil, I think, of the Anthropocene, being formed right now in a river plain somewhere around the world. Thank you.
Thank you very much, Sarah. Well, sobering, but with a flavour of optimism. Thanks. So the final talk for this session this morning is from Lila Warszawski. She's a researcher at Potsdam Institute for Climate Impact Research, and she's going to talk to us about has the Anthropocene reached a saturation point. Over to you, Lila.
Thank you for having me. Thank you for the invitation. So today I'd like to share some thoughts about how we can define and detect when the Anthropocene may have moved from a trajectory, as Johan has already been talking about this morning, to really, which is also so beautifully characterized by the great acceleration curves, to really a new state of the Earth system. I'm presenting these ideas not as a tried and tested framework, but really to provoke conversation. So I'm very much looking forward to your questions and comments and criticism, and just as a sort of a footnote, this is work in progress. So, as I was expecting, you have seen these curves a few times already this morning, but the reason I want to show them to you again is I have a slightly different lens when I look at them. I see these as pressures on the Earth system, but I don't yet see them as a response of the Earth system. And what I'm interested in today is, let me go back one. I've lost mine. So when we entered the Anthropocene around the middle of the century, if we believe that happened, most of the core systems and functions of the Earth system were within the safe operating system, safe operating space of the planetary boundaries, as Katherine already spoke about. And this we can interpret as indicating that we were living on a resilient planet that could weather the storm of variability, whether human or naturally caused. And I want to explore this morning the hypothesis that as the Anthropocene pressures increased and the time the natural systems spent being exposed to these pressures also increased, that the resilience of these systems was being eroded. The question that we've been asking ourselves, and sorry, I just have to take a step back. This work is not just my own. This is in conjunction with Johan Rockström, and actually started with conversations with Will Stefan, and he wasn't able to see the end of this work, but this is very much the fruit of his labour. So continuing on, again, the question that that group of people have been asking ourselves is, at what point the pressure of the Anthropocene has saturated the resilience or buffering capacity of natural systems such that they can no longer function as they have before? I'm not the first to think about these questions, and there are significant efforts, not least by colleagues here in this room and in Stockholm, to monitor and map regime shifts and resilience loss in social ecological systems across geographies and in great detail. These efforts have been predominantly focused on scales of regional interest, and our aim has been to look for signs of altered system function on scales representative of the entire Earth system. So what would it mean for the Anthropocene to go from a trajectory to a state? Well, I'll break it down to a few questions. First of all, can we find evidence that the resilience of large-scale biological and physical systems has been saturated? Can we detect change points in important representative variables which point to a shift in how systems respond to anthropogenic drivers? And finally, which characteristics affect the timing of these shifts? Now, to be a little bit more concrete, we've broken the systems that we've been looking at down into three groups, which you've heard about already this morning. So climate and ocean-related systems, systems which could be slotted into the biosphere and the cryosphere, so everything relating to ice. And the pressures or the drivers we're talking about are, of course, the great acceleration curves, but in a more prosaic way, we're talking about warming, we're talking about increased CO2 concentration, other greenhouse gases, changes in precipitation patterns, and more generally changes to the hydrological cycle, so availability of fresh water predominantly, changes to the land system, whether it be deforestation or to vegetation cover, nutrient overloading from overuse of fertilizers, air pollution, and I'm sure if I surveyed the room, we'd come up with a list of 10 more pressures that we could be talking about. So on a methodological level, we've tried to keep it quite simple. So experts in the audience will know that there's a fairly mature and rich scientific toolkit for detecting resilience loss and critical transitions in time series, be it critical slowing down, speeding up, fractal dimension. These methods have the advantage that there's a theoretical framework for interpreting when these things happen. However, they all require relatively long and highly resolved time series. So instead, in this exercise, we've chosen to look for structural changes in trends, which simply means when do we have a statistically significant indicator that the slope of the curves has changed from one value to another. So in the top panel here, you'll see this is an idealized time series, and we're adopting a method called the running slope difference t-test, or the RSD t-test. And in the bottom panel, you'll see where the red dots are, this algorithm detects changes in the trend, and I hope you'll agree that if you did this by eye, you would come up with fairly similar positions, but I can assure you that it's a little bit more sensitive than the naked eye. I'm now going to take you through some examples both from the climate and ocean, from the biosphere and from the cryosphere. We have looked at many more data series that I have time to show you today, but here are some examples. So starting with something which is very close to the climate system, we're looking at heat waves, and in particular the variable we are interested here is the annual average of the daily fraction of the Earth's surface which was experiencing a heat wave. The drivers behind this, of course, are warming, but you will have other factors like the built environment leading to an urban heat island effect, but of course that affects a very small amount of the Earth's surface. What I hope you agree you see even by eye is that starting in 1950 and going right through to around 1980, that this curve is fairly flat. There's not much happening. The system, sort of in this, out of our perspective, is still resilient to the pressures being exerted. Around 1980, so more precisely 1979, you see a sudden increase or a change in the trend here from flat to increasing. The question we've asked ourselves is, what are the sources of resilience here? Why was the system not responding immediately to the pressure? Well, of course, there's things like canopy cover and shading, the vegetation that is present on the Earth's surface and in any particular position, and the albedo effect. So how much of the radiation coming in is being directly reflected back into the atmosphere, out of the atmosphere. Another example now from the ocean. Here we're looking at ocean heat content change. Once again, a fairly flat curve, this time until around 1990, and then you see a shift to a higher rate of change. Once again, the driver here, of course, is the increasing heat energy in the atmosphere, which is then being translated into the ocean. Which kind of sources of resilience do we have? Well, heat storage in deep ocean layers. So through circulation, the heat's being transferred down into the deep layers of the ocean, which is hindering the upper layer of the ocean. So here, 1,000 meters is heating up straight away. Yet another example now from the cryosphere, we're looking at melting of the Greenland ice sheet. Again, you'll hear me, I'm sounding a bit like a broken record, but we have a fairly flat curve, nothing much is happening. And then around the year 2000, we see a sharp drop off. So once again, our interpretation here is that we had a resilient system which was able to sort of buffer the pressure of the Anthropocene, and at some point it could no longer do this, and the way that it's functioning or responding to this pressure is changing. Okay, I'll see how many more examples I've got time for here. Glacial melt, you see something very similar, but I'm going to skip on to now to an example from, well, both the ocean and the biosphere. Here we're looking at ocean dead zones, so areas where oxygen has been depleted from the ocean. And once again, you see actually we've got a proxy here called normalized ocean oxygen inventory. that has a slightly increasing trend until around the middle of the 1980s, and then you see a very significant change in the trend from increasing to decreasing. What could be the sources of resilience here? Why is the system responding in a delayed way? Well, the ocean itself has the ability to absorb the drivers, so nitrogen and phosphorus resulting from fertilizer use, and also stable marine populations of plankton, fish, and other marine systems are also able to sort of buffer the pressure of this change in nutrient level. But as our sort of hypothesis here goes, at some point this buffering capacity has been exhausted or saturated. I'm going to move on because of time. So of course we've looked at more data sets, as I said, than I've had time to show you here, but at the same time I want to be very explicit about the fact that our search for appropriate data sets has been driven predominantly by data availability and in no way represents a comprehensive ensemble of Earth system data. And nevertheless, we've made an attempt to put the data sets we've found and analysed into a classification scheme for Anthropocene trend shifts. And I'd like to take a moment to walk you through this. So we've considered 2 dimensions. The first of which is simply the significance of the trend shift that we've detected, starting on the left-hand side with no trend shift at all, and going through to the right-hand side where there's a high significance of the trend shift. The systems with the asterisks next to them are systems that we haven't analysed ourselves, but have found evidence within sort of the scientific literature of similar trend shifts that we've been looking for. The second dimension relates to the extent to which the system responds directly to the Anthropocene pressure, whether the system includes some kind of resilience mechanisms to weather the external pressure without exhibiting noticeable change, i.e. where the system is highly resilient. Now, the naive expectation here going into this work would be that those systems that respond most directly to the Anthropocene pressure should exhibit a trend shift earlier than those that have been classified as a true system response or as being resilient. This is my final slide. This is, I would almost say, please don't take photos of it. This is very much a work in progress. But what I've done here is I've taken those systems where we have detected a trend shift with a high significance. I've broken them down into those 3 groups. So the 3 rows I had before. So the direct response to the Anthropocene pressure, some kind of mixture of a direct response and a system or resilient response. And finally, in red, I've shown those systems we've classified as being a true system response. So sort of being a big black box of different mechanisms where we expect the pressure won't be directly translated into into an impact. And what we were expecting to see as I stated before, is that those systems which are a direct response to the Anthropocene pressure should shift earlier. So the blue points should shift earlier, the green points somewhere in the middle, and the red points towards the end. I would say I have a very incomplete set of data here. So I'm not expecting to see much here, but I wanted to show you that as a way to show you how we're thinking about this. Of course, any mathematical algorithm looking for a trend shift needs a certain amount of data before and after the shift to be able to know if something has really happened. And that sort of explains the dearth of points somewhere sort of beyond 2000 or 2005. So there's this work started about 5 years ago. I've kind of put it down and put it in the cupboard for a while. I'd be very interested to know which data sets I can add to this work now. And should this progress, and should we start seeing sort of really a separation of these different kinds of system responses, then we can start to think about how do we talk about this deep Anthropocene compared to this initial Anthropocene. And I'd like to sort of coin a few new phrases which probably can be debated hotly, but I would say that I would call this period of time after the initial, sort of the beginning of the Anthropocene as the resilient Anthropocene, where many of the natural biological and physical systems were able to sort of go along as before. And I would say that at some point, perhaps in the 1970s, that we've really entered the saturating Anthropocene. If that ever becomes the saturated Anthropocene, I can't say. And maybe this is very related to sort of the conversations about planetary boundaries and various other things that have been discussed this morning. I'm going to leave it there, and I look forward to our conversation.
Thanks, Lila, and I'd like you to come over here and join the conversation. We're a bit over time. Just on the tables there. I'd like to invite Johan back to and Katherine and Boomsloon Park, and we're going to have a few minutes, and Sarah, of course, for some questions. But we don't have a huge amount of time because we're a bit over time for coffee. But we'll go for a few minutes. And maybe the first thing I'd ask, well, thank you all so much for, I mean, it was a great overview in many different ways. But Katherine, you were talking about time and this time between the science and the policy. And everybody was talking about time. We don't have very much time. You know, when we talk about tipping points, the knowledge that we had back in 2007, 2008 was that we'd cross tipping points maybe in 2100. Now, it's happening now, right now, this generation. How do we address this?
Well, first of all, I think we have to appreciate that that travel, this journey that we're all on, isn't linear. And if you look at the 2015 Planetary Boundaries paper, after it had been out for 8 years, it had been downloaded 274,000 times. The paper from 2023 has now been downloaded 730,000 times. So what that tells me is that there's take up here, that it's, you know, we're talking social tipping points as well. So I think we need to be focusing on what is it that can stimulate and push social tipping points. And that's why we're here, and that's why most of us use 70 plus hours a week on this sort of stuff.
Just a quick addition to this, because I think you're putting your finger, Owen, on something really important. So at COP13 Berlin, we felt forced to put out a science statement there that we made public, reminding everyone that if we exceed 1.5 degrees Celsius, we're likely going to push both the Amazon basin and the tropical coral reef systems across the threshold if we permanently stay above 1.5. That is quite shocking news because it's based on the latest science. It's referencing very clearly the IPCC AR6 work, and we're there right now because we are very likely going to breach 1.5 within the next 5 to 10 years. So this is, as you say, well, this is no longer something way in the future. It's right now. And it will fundamentally have impacts on people at billion number scale, but also directly on the resilience of the Earth system. So this is a change, I would argue, in the evidence base we have, a very significant one.
And don't forget that the Global Tipping Points report says they can't put their hands on the heart and say that the AMOC hasn't already tipped. And, you know, that's got Iceland to go in and say it's a national security threat. So there are things happening, but we need to get that knowledge out there.
So I would like to turn to the audience, and we don't have a lot of time, but I see we have a question over here. Please identify yourself. You can just speak.
My name is Alexander Damianos. I'm from the University of Kent. And my question, thank you first of all for all your credible talks. My question is a very simple one. Do you think scientists are now more sovereign than legal and policy actors? And what I mean is that my sense is that from the presentations I've seen today, is that it's not just, we know so much, but take such little action. And it seems like scientists are now the ones who are trying to not only provide technical advice to policymakers, but actually steer how that science is interpreted and acted on. And I just wondered what you think of that. What we see from lawyers and policy actors is inaction, in other words, and scientists are filling that space. I wonder what you have to say about that.
Who would like to address that question?
Well, I can't really speak to, I can just speak in my own context, and that is that you're right in the sense that, so the people in the city of Leicester could see this rubbish and just how appalling it is, and nothing was happening. And it's because there are so many different agencies that have to, there's the Environment Agency and the City Council. Oh, anyway, there's all these kind of bodies that don't do stuff. And so actually, yeah, I just thought something needed to be done. So that's a very small local answer to your question. I can't really speak to the bigger picture, though.
I like to think that you're right, that scientists are filling the gap, and people like Johan certainly are trying very hard to fill the gap. But whether us jumping into the gap is enough to make something happen is still an open question, I think.
Johan, do you want to-
Yeah, no, I think one has to be a bit careful in how to position science at this very critical juncture. Because on the one hand, you're right, I'm in no doubt that science needs to step up and need to be more active in influencing both behaviors but also policy and business. And I think we're doing a better job at it as well. But there's a very careful line there which we should not step over. We should not become activists, because then we risk having a feedback loop where we erode our integrity and our credibility.
Yeah.
So there's a very, very fine line there. And I would actually argue that scientists today are acting on the deep concern coming from the evidence we're standing on. So I've never seen what I experienced in Belém just 2 weeks ago. I've never experienced anything close to that. I mean, I can show you pictures here with Professor Thelma Krug, Professor Carlos Nobre, big scientists from Global South, from everywhere in the world, standing as if it was a rock star paparazzi gathering with microphones, stepping up under their nose in 50s of them, because people wanted to get the scientific verdict. And what's the story on 1.5? And are we heading towards unmanageable futures? So I think it's a question also of just stubbornly staying on the path that the Anthropocene evidence is useful information, and just continuing that work. But I agree, it's a very turbulent world we live in, so you can wonder whether that really is sufficient. But I don't think we should step out of our integral, independent academic roles, because that I think would take us into a point of eroding our credibility and impact. So it's a fine line.
Well, I can add to responses. And your question is about how much scientists can intervene and speak for the situations that we are facing. And if we are already deep into the Anthropocene, then whether scientists, on the basis of evidence, should speak up. And I think it's very closely having to do with what kind of political culture or democratic traditions that would allow you to speak without fear. I mean, or without concerns about sort of national competitiveness and then other things. And what's happening in Korea is very interesting. In one sense, we are breaching 1.5 point. And then one journalist said, "What's happening?" And then he make an argument that we need AI. And then AI needs data centers. And the data centers need energy. We have to go for nuclear. We have to go for others. I mean, it's easily link some of our concerns and then some of the energy demand going up. And then there is some kind of the logic that links. On the other hand, in China, I'm not a China specialist, but it's close enough to know something. and what's being practiced there is a so-called ecological civilization. It's kind of a new civilization they are pursuing, different from. And then wind turbine and the solar panels, and then on the desert, and then there is a serious effort to develop alternative energies and going on, and then scientists, especially climate scientists and others, all employed in the campaign for that. And so you don't have to speak out of your conscience. It's a state, the government push, and then you're just riding on that. So there is a lot of the differences between the countries in Asia, also Asia and the West.
Thank you. And we have some talks on that later today. Dalian Chen will be speaking about ecological civilization. But in the interest of time, I know that there are more burning questions out there, but there's also coffee out there. So I'd like to thank all of the speakers this morning.
So please welcome in everybody to take your seats as we are starting the second session here this morning in this wonderful Anthropocene conference. And you see the title of it over there. I'm Sverker Sörlin, together with Sabine Höhle, who's sitting up here in front. We will lead you through this session with the help of some wonderful speakers. We're going to start by some introductory reflections and comments. So I'll start and Sabina will follow. We are in the Anthropocene. We don't know exactly how far, clearly. So we'll draw quite a bit on the previous session. It's to follow up on what is the Great Acceleration. It took a few years after 2000 and the first publications that we heard about in the previous session until scholars in the humanities and social sciences became fully aware that this concept was something also for them or for us. By the time of the massive linked crises in the latter part of the 2000s, with the rise of the climate issue, the Stern Report, the Al Gore and the IPCC Nobel Peace Prize, it became obvious that something was going on with the human planetary relationship that went beyond the usual confines of old environmental pollution, things like that. This was reinforced by the reignited thinking of planetary boundaries. And this idea required a sense of a massively growing scale of impact, we could call it, and faster rates of change than those that were previously conceived. So this became a new, I think, also a new historical framework that was called the Great Acceleration. The exceptional rates of change in the Earth system are propelled by human societies when they transform into modernizing, science-based and fossil-driven economies. So that's our current predicament. The Earth system itself, we could think in those terms, is now becoming, and is already becoming, a historical category, a relevant and urgent object also of humanity's inquiry. Becoming historical, what does that mean? It means being necessarily linked through processes in both present, past, and future, so to speak, at the same time. Not only was this human planetary temporality built into the planetary boundaries concept, which, by the way, is also, I think, conceived of as a kind of a time machine. If you look at the changes across crossing boundaries is happening in time. So not only was this built into the planetary boundaries concept, it was also being received and worked upon by scholars in the humanities. And one of the most significant publications in that whole line of work was in that same year, 2009, Dipesh Chakrabarty's article, The Climate of History, where Dipesh, who was a Chicago-based historian, argued for a wider planetary and species version of writing history. So that's another impact that this line of thought has brought. It's changing the human sciences as well. Now, this is not more than 15 years ago, and we've seen how a lot of work, really, along these lines has emerged and evolved. Examples of how this is playing out beyond the academic circles are how climate policy debates are pursued with concepts such as carbon budgets or net zero and similar concepts. We heard other concepts this morning. They all imply new kinds of temporalities, new claims on the future, where the time scales of the Earth system are intrinsically linked, but only rarely aligned with temporalities of societal agency and decision making. And that last point was touched upon a little bit in the final conversation here before the break. So this new importance of time and emergency on multiple scales implies a gradual shift of existential mode in modern societies. As French historian François Hartog, among others, has argued, we have had until recently 2 centuries, we could say since the French Revolution, of openness to the future as progress and prospect, with of course many setbacks and of course the constant risk of decline, but always with a strong sense of linearity and progression. Now, post-1989 and post the appearance of planetary boundaries and Anthropocene thinking, the Anthropocene has become a rising dimension of what we may call a fundamental questioning of our times, and times in the plural, and of temporalities, which is our social perceptions of time. We are already in the midst of much more lively historical and time-making debates that are on the scale of previous major ruptures, such as the arrival of modernity several hundred years ago. And the Anthropocene is a key feature of all this. In this new uncertainty and predicament, the function, if not the mission, of humanity can increasingly be seen as one of counteracting the prospects of a dire, dangerous Anthropocene. We heard a little bit about this morning. We might say even a humanity counteracting itself, so to speak, fighting some of its or our inner impulses. This is very hard and very important to think about. And this, we believe, has already brought a profound change in how we think about human history and about the humanities at large. New issues and topics are arising, new approaches taken, and new questions asked. So before we open up the floor, we just give you a sample of the items here, which this session will touch on to open up this enormously rich work coming out of contemporary humanities and social sciences. The first, we'll address just a few. Human agency, to start with, is key, of course, and how it extends with money and technology. Is human agency, we could ask, overestimated as a category, or is it underestimated? What sort of thing is it actually? Is it fundamentally problematic? The second is elements and the elemental. We live, we might say, in the midst of the rage of the elements. Extreme weather, things like that is growing and growing, being whipped up around the world, and the transportation of materials that exceeds natural processes. Is there a need to augment the understanding of history to include also the agential elements as parts and proxies of the planetary spheres, the biosphere, the hydrosphere, the lithosphere, the cryosphere? Should we look more carefully, so to say, at an elemental history as the history of an augmented anthropogenic? And Sabine will follow up with a few more before we go into the speakers.
Hello everyone, and I apologize for my voice. It's actually terrible. I hope it will carry anyway to you all. So another item or another issue we want to address in this session is temporalities, spatialities, and scales. We need to reflect on the pluralities and the tensions related to time and space in the social relations to the Earth system, from the local to the planetary scale. As Helge said, the futures that modernity once opened with its promises of progress seem increasingly closed. Just last month at COP30, overshoot turned into an accepted, even a programmatic concept. And that means taking a huge loan on the futures to come, or even the futures we envision to come. We've already, in a way, narrowed down. And that makes common, much older concepts, like the sustainability concept. It makes that really look very old, because sustainability is still, in a way, an idea from a very linear world, if you think of it. We have as an issue also in the title, morality. I would perhaps prefer to talk about something like integrity. Why is caution and constraint not valued more highly, and why is it rewarded so little? So I have to think about how our economic and social systems are being valued and also continued, the role of capitalism as a style of thought, and also a practical system of how we household in the emergence of the Anthropocene. Should we continue this into our futures? Why is accumulation linked to success and power? And will there be ways to escape that vicious circle? So sometimes my impression is that we still sort of adhere to or live in the Brotherton diagram of the 1980s, NASA's diagram that conceptualized the Earth system and somehow contained human agency in that little separate box, right? Instead of thinking of how our Earth system is really infused by everything that we wish and decide to do or not do. So the last item we have on our list is wisdom. And that is a big word. And it asks the question whether we can conceive of knowledge-making processes in our academic professions and the role of all fields of knowledges to make a meaningful and effective contribution. This is also what our Center for Anthropocene History at KTH is really trying to do. So develop a field of humanities, Anthropocene research, historical research that makes a difference in this world through the perspectives that we can bring. So we have a wonderful panel of 4 speakers this morning, trying to bring these approaches from the Anthropocene humanities together, connect Anthropocene science and scholarship with issues of policy in creative ways, and ask what the humanities might have to offer in such a turn of responsible knowledge making. It's Helge Jordheim from Oslo University, Jan Salasiewicz from the University of Leicester, and then we have Fabienne Will from Munich, the Deutsches Museum, and last but not least, Jean-Baptiste Fressoz from CNRS in Paris. And I welcome to the stage our first speaker, Helge Jordheim, and here he sits, a professor of cultural history at the University of Oslo, where he is, since this year, also the director of the Center for Global Sustainability. Right? He's widely known through his work on time and temporalities. This is at least how I know.
That's all right.
And so it's about how we experience time and how we make sense of the past and our present and the future, or futures in the plural. So what would be better suited to understand Anthropocenic time as inviting an expert on time and temporalities? And so here's Helge with the title, An Anthropocene of Multiple Times, Resonances with Past Times. The floor is yours.
Thank you so much. Thank you for having me. Yes, I have. I'm since the last 5 months. I've been the director of a new Center for Global Sustainability at the University of Oslo, which means I am sort of traveling around talking about the concept that, according to Sabine, belongs to a former world, which is a very interesting, for a time scholar, very interesting experience, right? Now, always that feeling that people, that response that people give you, oh, now, well, this is a bit late. You're late to the party talking about this sustainability, aren't you? So this feeling of coming late to the party is not what I'm going to talk about now, but it's interesting. And it goes to the point that Owen was making earlier, right? That we're all talking about time in different ways. And I'm just going to amplify that by actually talking about time for the next 10 minutes. And I'm also going to show you that colorful diagrams is not an invention of the last 10 years. It's been around since this is 1782. I'll come back to that. But just the obvious claim here is that the Anthropocene is about time. It's about how we experience time, how we manage time, and it's an obvious claim. Clearly, the most basic level, the Anthropocene, is a name for a temporal interval on the geological timescale. An epoch, and as a period, as a means of periodization, it has a beginning. There's been some discussions of where that beginning should be placed, and it also comes by the same logic of periodization with the idea of an end. And as we're discussing in this session, and we'll continue to discuss, I think the Anthropocene also addresses history in the modern disciplinary sense, and thus historical time, as Sven was talking about, which traditionally at least has been adapted to and defined by human experience and human agency, both at an individual and a collective level. However, as has become abundantly clear, historical time can exist only at the interface with other kinds of time: geological, biological, chemical, meteorological, the times of species extinction, CO2 accumulation, etc. So in this sense, as the Deepa Chakrabarty has argued also, the Anthropocene paradigm shift can also be seen as a return to an earlier form of historiography, a historia naturalis, a natural history, which is often taken to end around 1900 when it was supplanted by the modern disciplines of geology, biology, chemistry, and indeed human history. So before approximately 1800, there was also other ways to think about time in less singularizing, more heterogeneous ways. This is one example of that. This is Friedrich Karl Fulda's map or synchronistic time of all the times in the world from 1782. There's even a sort of a time for natural catastrophes, which is the white you say on the far right for you over there. And I think there's something to learn from this way of thinking about time, right? And it has to do with the diagrams you were looking at earlier. Also, another way to sort of illustrate the multiple temporalities of natural history is, now I'm going to do, yes, is of course the Curiosity Cabinet, the so-called Wunderkammer. This is with a collection of things from all across the scope of natural history. This is Ole Worm's, the frontispiece of his exhibition or the book about his exhibition of his Wunderkammer from 1655. Now, as all these examples make abundantly clear, I think, times, that is, scales, duration, rhythms, and speeds of change are linked to forms of knowledge. Times of geology are different from the times of human history on the level of scale, but also on the level of standards, measuring practices and instruments, markers, etc. Times are, as Leibniz already knew, embedded and embodied in things and their relations. The times of rocks, minerals, and strata are never external to these things, but depend intimately on their inherent transformational rhythms. The same can be said about materials and life forms. So in other words, we live in multiple times. Newtonian time, often falsely identified with clock time, does not adequately describe the world. Rather, it's a selective and a reductive way to make sense of it, to study it, to navigate it, to discipline and take control of it. This singular, homogeneous, linear version of time was also taken over into the emergent discipline of history, giving rise to the historical timeline onto which all kinds of events and lives can be placed, including, as you can see here, a long line of male geniuses. Now, Newton's rival, Gottfried Leibniz, knew this, so did Johann Gottfried Herder, the late 18th century theologian, philosopher, and godfather of German historicism. So in 1799, he launched an attack on his former teacher, Immanuel Kant, who was in many ways a Newtonian, in which he made a suggestion what a theory of multiple times based in natural history could look like. I'm going to read it to you. In reality, every mutable thing has its own inherent standard of time. This exists even if nothing else is there. No two things in the world have the same standard of time. My pulse, my step, or the flight of my thoughts is not a temporal standard for others. The flow of a river, the growth of a tree is not a temporal standard for all rivers, trees, and plants. Lifetimes of elephants and the most ephemeral are very different from each other. And how different aren't the temporal standards on all planets? In other words, there are, one can say it earnestly and courageously, Herder adds, in the universe at any time innumerable different times. So in my view, then, Herder's insight ought to inform our discussions about the Anthropocene, reminding us that any claim we make has to contend with a multitude of different times, their connections, their disconnections, their alignments, and their misalignments. So the group of us have been trying to kick off a debate about these questions that are going to come out in a book that will be in bookstores in a couple of months, I hope, on lifetimes. Now, that times are multiple is, as all of you know, not a very surprising insight. Rather something we experience every day in our bodies, in our institutions, in the discourses, collectives, and ecologies we're part of, analog or digital. The value of this in itself quite trivial insight, I would claim, which we can associate with Leibniz, Herder, Einstein, Bergson, various others, consists in the analytical purchases it offers on the world, as a place where things are coming in and out of sync, where synchronizing and desynchronizing processes are always taking place, both on an ontological and a non-epistemological, pragmatic, even on a political level, as we were discussing in the earlier in the discussion in the last session. From this follows, I would claim that the history of time is in its essence a history of synchronization within or between life forms, technologies, and practices, identifying moments when these come in and out of sync, when particular practices of synchronization come to contest, dominate over, and even supplant others. So in short, what I suggest to you here is to understand the Anthropocene as a moment in the history of synchronization, or rather, a rather decisive one at that. So this idea, and this is sort of the last part of my little talk here, can be understood in two different ways, I think. So, at the level of ontology, the Anthropocene names the moment when different life forms and time scales come out of sync with each other. The rhythms and speeds of human activity have come out of sync with the life rhythms of other species, or indeed, even more generally, with processes in the Earth system. This out of sync condition is referred to in different ways. The Great Acceleration, as we just heard, the Sixth Extinction, or more colloquially, climate emergency, nature crisis, etc. So, and at present, and we have other diagrams for this, right? All our most well-rehearsed forms and tools of synchronization are mobilized to make sense and deal with this condition. The clock, like here in the 10,000-year clock over here, buried in the sands of Nevada to help us with long-term thinking. We use calendars to plan yearly, annual meetings, or to measure CO2 accumulation in the atmosphere. All this, we should say, with mixed success. On the level of epistemology or pragmatics, or even politics, if you like, the Anthropocene, the concept, the idea, the numerous scientific practices can itself be thought of as a synchronizer, a tool, an instrument, a form used to synchronize and thus align our approaches to an out-of-sync world. To develop this idea, I like to use a passage from a book by the German sociologist Niklas Luhmann, known mostly for his theory of modernization as differentiation. And he writes, "Synchronization ties the medium of time to forms and tries to find suitable forms. But there's no super-synchronization which could bring order to the act of synchronization itself. This was once the role of the concept of destiny." So you've seen today, and I've given some more of them, many examples how time has been tied to different forms for purposes of synchronization, such as the clock, the calendar, the timeline, but also how these forms have proven not necessarily suitable, to use Luhmann's word, to synchronize us with the planetary event of climate emergency. In other words, we need to find other suitable forms. Or to be more precise, we need to ask if the Anthropocene, the concept, and a set of scientific practices that come with it is such a suitable form. So that brings us to Luhmann's second claim and my last point, that there's no super synchronization, which could bring order to all the acts of synchronization itself. The last form that was able to achieve this, according to Luhmann, was the pre-modern concept of destiny. And here I think I disagree with Luhmann. I think modernity also had, or even have, these super synchronizers. And I think the strongest candidate is the concept of progress. That synchronized this idea of progressive linear time that synchronized all other processes in politics, technology, science, etc. For the last decade, however, a new super synchronizer, have been emerging, I think, the concept of crisis, recently expanded to the idea of polycrisis. So the question I just want to leave you with is whether the Anthropocene can be understood not just as a suitable form to synchronize us with the various times of climate emergency and nature crisis, but also as a super synchronizer, bringing order to all other acts of synchronization in the disciplines, in politics, as well as in the social world. That was my 5 cents in 8 minutes, I think. Thank you.
Thank you, Helge, for kicking us off here with quite a challenge, I think, to think of the Anthropocene as sort of bringing us out of sync with natural times, but also as a great synchronizing machine in a way. We follow suit with our next speaker, Jan Salasiewicz, who is a geologist and paleontologist, now Emeritus Professor at the University of Leicester in the UK. And I mean, who does not know you? I think everyone knows you here. Still, Jan deserves, of course, an introduction because he is so well known through his work and his leadership in the Anthropocene Working Group. Unwavering working towards continuing the Anthropocene discussion even after the formal decision against the Anthropocene was taken. So what makes him so valuable for our discussion today, this morning in this session, I think, is that you are so widely interested in cross-disciplinary and interdisciplinary discussion and insights towards the need for collaboration. So Jan is a real collaborator to understand and to convey what is at stake, what is actually at stake here. So I think this is why we wanted to have you in this session, even though you would have fitted all other sessions equally well. So Jan is going to talk about the Anthropocene as an elemental challenge, right? It's an epochal definition, but it's also an elemental challenge in more than one way, at least two. The elemental as fundamental, and the elemental, I think, as Sverker introduced, the elemental as the tiniest and largest parts of our universe that Jan will address. And thank you.
Thank you very much, Sabine, and well, thank you also. I'm very grateful for the chance to come here, meet you all, and discuss all these problems with you. I was slightly at a loss with the title suggested of bringing in the elemental into the Anthropocene. So what I've tried to do is think as a geologist, as really a very old-fashioned type of field geologist, which is what I've been most of my life, and to say what is really different about the Anthropocene from the point of view of an old-fashioned geologist who's used to Earth history and is rather ignorant about human history, but is increasingly realizing that the two are coming together of that. So these are just a few examples of where I think the planet really is changing in a way that is quite different. And that at the moment I have not included climate change because that has been talked about so eloquently, already this morning that I couldn't bring that in. And also because climate change has also happened in the past, sometimes drastically. So we have, if you like, analogues for that. But there are a few ways, I think, in which the Earth is changing, which I can't think of an example in geology. So let us try on. And one is again, if we talk of elemental, we can convert that into mineralogical, which is the fundamental building blocks of the planet and what surround us at the surface and how that fundamental composition happens to be changing in that. And so this is the concept of mineral diversity. And the background, again, as a geologist, we deal with minerals making up rocks, every hour of every day of the week when we're working. And the baseline is about a little over 5,000, about 5,200 now, I think, named, classified, defined types of mineral that have been recognized and formalized, indeed, by the International Mineralogical Association of that. So those also have a history. And again, it's a history that's been worked out. It's a 5 billion year, more than 5 billion year history that's been worked out by the mineralogist Bob Hazen and his colleagues. And you start, let's see, can I use that? Works, wonderful technology. Before the Earth, you had very few minerals, about a dozen coming out of supernova explosions, carbides and diamond and things like that. And then you begin to build a solar system, and then you get a few hundred, the kind of things you find in meteorites. And then you build a planet, and the planet stretches out the chemistry. So you get new minerals, you get plate tectonics and metamorphism and things like that. And then life comes in and not very much happens until life decides to excrete oxygen into the atmosphere, when you get a whole raft of hydroxides and hydroxides coming in, to roughly double the number of minerals at the surface. And then not very much, not very much at all for the rest of the 2.5 billion years. And some years ago, in the kind of the early days of Anthropocene experimentation, with a few colleagues, we decided, well, what if humans added to that thing? And we took Bob Hazen's history, and at the very end of it, we tried to read around a bit and took the, we thought maybe another few thousand minerals on there, and that's the idea. And they'll be around for a bit, and then they'll decay away. And then Bob Hazen, thank heavens, came and did the job properly for us. He of that, and that is really the graph that he produced. So all of Earth's mineralogy is really a horizontal line at the bottom. And what we've done since then is to increase the number of crystalline inorganic compounds, that is minerals in every but formal sense, at the Earth's surface by orders of magnitude. So now more than 300,000. Most of those have been made since 1950. So when the diagram was made originally a few years ago, it was 180,000. It's now been almost doubled. And that is what our material scientists can do in factories and laboratories around the world. Now, they include the whole raft of these, but metals are a nice example, because native metals are not very common, on Earth to a geologist. Gold is one of them, copper sometimes, iron very, very rarely, mainly as meteorites on that. But a lot of these things we've taken out and, again, produced in large amounts. So we now have a metal-rich surface to the planet, which is something quite new on there. And the amounts of some of these are aluminium, for instance, almost unknown in nature. Microgram amounts just here and there. Enough now made to coat the whole of the USA, and an increasingly large part of Canada in standard kitchen aluminium foil. Whether that is a good idea or not, I will leave. But the amount of iron, again, native iron, is vanishingly rare. But iron produced by humans is now, again, several times that. Enough for one steel ball bearing about this size for every square meter of the earth, land and sea. So geologically, this is really quite a change. And commented on by Peter Heaney, once Bob Hazen had done all this work, saying that mineralogists might celebrate this huge burst of diversity, probably unique certainly to the solar system, probably unique to the galaxy, maybe unique to the universe, to the cosmos, if that, to counter the desolation of the Anthropocene in every other regard. Biodiversity and technodiversity. Again, this mixes Earth and human history. The things the Earth makes, the things that humans make. And again, throughout my career, there have been various estimates of how many living species there are on Earth, biological species. And it kind of goes up and down. It depends whether you include microbes or not. But if you just take normal macroscopic life form, probably 8, 9, 10, 11 million, something like that. Now, if you take techno-species, individual types of objects created by us, then the number is, again, orders of magnitude greater than biological diversity. Amazon sells almost 500 million different types of object on there. I couldn't guess at the final number, but it must be over 1 billion kinds of individual kinds of repeatedly made objects of the same kind. Again, I can't think of any planetary of this kind of change. Speed. And again, I think speed will be talked about here. Again, I approach speed from my background as a geologist and paleontologist. How fast do things work as we judge them from the history of the Earth in strata versus today? And I take, again, this is part of my life. This is on this side here, this creature here is a fossil graptolite. It's about 400 million years old. It's a kind of plankton. This thing is its modern relative here. And the thing about this is it's an animal architect. It's not a skeleton you see there, but it is a built construction, collectively built by the little creatures, like a fossilized spider's web or termite's nest, if you like. Nonetheless, they're biological species that evolve. And they evolve at normal biological rates. This is a couple of examples of the fastest rates of evolution I know in graptolites. And they're quite extraordinary. So you go through a number of species, quite different, in 500,000 years, there or thereabouts, as far as we can judge. And that is probably the fastest rate of morphological evolution I know, of that scale and range in a fossil species. Possibly because these things were animal architects, and these are built structures and not skeletons. Now, compare that, for instance, with another kind of biologically built structure, where we're getting comparable amounts of morphological change of morphospecies or technospecies, which have developed just over a few decades, in half my lifetime. I still haven't got used to the damn things in there. And of course, if we take, the fact that we now having this meeting, as partly to celebrate when Paul Crutzen first announced the idea of the Anthropocene, the beginning of this millennium, how far the world has moved on in terms of rate of change. CO2 has gone up by more than 50 ppm, temperature by the best part of a degree, number of cars tripled and all that kind of thing. And down here, right at the very bottom, the ratio of biomass to technomass, and Sarah mentioned this, this has doubled. So if we take the growth of anthropogenic mass, as worked out by, oops, beg your pardon. Oops, wrong one. Wrong one. Ah, there we are. In there, when Paul Crutzen gave came out with his announcement, it was about here. We're now about here. So again, just geologically, this is quite extraordinary, and we are breaking through into some new kind of planet, in many kinds of ways, and these ways are probably not half as important as those that have been, or even attempted as that, but they're, again, symptoms, of what is going on around us at this kind of level. Okay, thank you very much again for your patience with geology.
Thank you very much, John, for this wonderful presentation. We'll turn next to Fabienne Will, who I've seen here around somewhere. Where are you? Over there. Who is an historian of science working at the Deutsches Museum in Munich and at the Munich Science Communication Lab, a collaboration between several strong Munich institutions and the two universities to lift science in the public discourse. Fabienne wrote an impressive PhD thesis on the work of the Anthropocene Working Group that she followed in participant observation, exploring how this new concept unfolded between the disciplines, both in collaboration and contestation. And we should also tell the audience here that last week you were appointed to a new professorship of global history at the University of Applied Science in Munich, so congratulations on that. And here you will speak on the Anthropocene and its impact on scientific practice beyond disciplinary boundaries. Please.
Yeah, thank you very much for this kind introduction. I'm super happy to be here today, and I will structure my 10 minutes along 3 theses today. First, the diagnosis of the Anthropocene entails an epistemic challenge and fundamentally questions established knowledge practices. Second, interdisciplinarity is a key requirement in the Anthropocene and is itself becoming a knowledge practice. And third, Anthropocenic time, materials and agency hold the potential to establish interscalar thinking in scientific practice. If you take a look at the Anthropocene, the debate it sparked, and how it evolved from a meta perspective today, you can more than surmise how powerful the concept is and how relevant it has become for society as well as for science as such. How could a geological concept have such a rapid and widespread impact? From my perspective, there were 2 key factors involved here. First, the anthropos in the Anthropocene. As all of you here probably know, there have been many discussions about the term Anthropocene, and in the broader debate, it has become kind of common practice to underline the perspective one has taken with an alternative term. And all in all, this highlights mainly the richness of the concept and clearly shows its power. And the second factor is the question of when the Anthropocene began. In the Anthropocene, geological deep time and human time, historical time, merge, which has triggered uncertainty, irritation, and even resistance on both sides. In addition to the factor that caused irritation within geology, that's about a very short period of time, with a future-oriented aspect in it, there arose also a feeling among some in the humanities that their basis for legitimacy was being undermined. Geological history and human history have been treated separately in the past 200, 250 years, but this is no longer tenable in the Anthropocene and leads to a clash not only between different conceptions of temporality, but also between different disciplinary scientific practices of dividing time. So in the Anthropocene, established content-related disciplinary and categorical boundaries are blurring in a way that has been unprecedented since the differentiation of disciplines in the 19th century. This has challenged individual disciplines and continues to challenge them to leave their disciplinary comfort zones and enter an interdisciplinary negotiation process on knowledge production and evidence practices, which in turn impacts established scientific practices. And I think the AWG has set a very good example early on in the debate on how to deal with this challenge. It's rare for one scientific concept to have such a wide-reaching impact and to challenge established scientific practices that have been valid over decades, if not centuries, in so many different disciplines. Take geology. Some of the long-established practices of knowledge production seem outdated. For example, that geological deep time ends in the deep past and cannot be thought into the future, that humans are not part of the field of geology. Many of you present here today recognized from the very beginning that the idea of the Anthropocene needs to be thought about more openly and in a different way. In the broader geological community, however, there has been and still is significant resistance to the ongoing changes in scientific practice. Nevertheless, I see big potential for this opening process to continue to intensify over the coming decades. Because with the Anthropocene, a process of opening has taken place with regard to methodology, content, and disciplines involved. And again, the AWG is kind of the best example of how fruitful this can be. And interdisciplinarity is the key word here. It is deeply influencing scientific practice and itself even becoming a scientific practice, if you will, as interdisciplinary arguments are used to reinforce disciplinary arguments. And even Stanley Finney has undergone a development, if you will, from clearly rejecting interdisciplinarity to practicing it. You can see that here by using it as an argument for recognizing the Anthropocene as an event instead of an epoch. Here, what he's doing is that he's bringing together historical and geological time. So he's practicing basically what he's arguing against, and what I hope already did back in 2007, and I hope was set up with the goal to bring geology and history together. The established concept of time is not only challenged in geology, but also in history. We've already heard that. Historians are facing the challenge to think beyond established traditional historical temporalities when it comes to a genuine engagement with the Anthropocene. Common reactions have long been that humanities' intervention in Earth system processes began much earlier than in the 1950s, which is true. And parallel to the discourse on periodization in geology, the beginning of the Anthropocene was also discussed in the humanities and social sciences. And interestingly, despite different arguments, the proposals were more or less similar, which impressively shows that geology and history converge in the Anthropocene. And the one big challenge in the dialogue between the disciplines that popped up from time to time again, and is also today popping up again, is the lack of understanding for the effect-centered approach of geology, which seems to be diametrically opposed to the cause and process-oriented perspective of humanities and social science disciplines. This has resulted in numerous counterarguments. But there are also examples from historiography that are truly fruitful. Those that genuinely seek dialogue, engage with the changed conception of temporality, and write Anthropocene history also along some geoscientific aspects of the concept. And today there's a kind of trend towards the planetary, which is getting more intense, so to say. Deepa Chakrabarty was one of the very early promoters of planetary history. Currently, there's taking place a seminar on planetary history at the Historical Institute in London, and I and two colleagues, we organized, for example, a conference on planetary waters in October. Another point is that the analysis of the Anthropocene opens up new archives for humanities and social sciences. Markers, for example, technofossils, we've just heard about that, take that as an example. Human invention, human time, and geological deep time materialize in those kinds of objects and are suitable as interscalar narrative tools. And this specific example is closely linked to a third change in scientific practice in the humanities and social sciences, which ultimately also in this case represents, as in the case of time, the opposite trend to that in geology. I'm talking about agency. In geology, agency opens up towards humans. In the humanities, the focus is shifting away from humans as the central actors and even more strongly than before towards animals, plants, but also substances and chemical elements. And this goes very much against the argument that the Anthropocene comes along with a too anthropocentric focus. So all in all, the Anthropocene entails the big potential to link different scales and bring up new narratives. Humanity shapes the planet and is in turn shaped by Earth system changes that are visible in geological signatures, which in turn have been shaped by humans. And this dual interaction and the resulting blurring of boundaries between nature and culture are in a sense the hallmark of the Anthropocene. The already visible changes in scientific practice triggered by the Anthropocene show that we need maybe a kind of reunificational moment of disciplines, like a bit of what we had before the differentiation of disciplines in the 19th century. And if we look at the concept and the debate it sparked from a meta perspective again, asking how it influenced scientific practice more generally, we can see processes of opening up on many different levels. This may suggest destabilization or fuel fears of destabilization for the respective disciplines, but can ultimately have or contribute also to re-stabilization. So to conclude, the Anthropocene as a paradigm shift, yes, I think the potential is there. Despite the rejection for the time being, to speak with Libby Robin, the genie's out of the bottle, and it is there to stay. And the continuing institutionalization is one indicator of this. In the humanities, it becomes institutionalized more and more. Take the MPI for Geoanthropology in Jena, the Vienna Chair for Anthropocene History, or here in Stockholm, the new Center for Anthropocene History. And if we look at the history of geology, we see something that allows us to face the future optimistically with regard to the formalization of the Anthropocene. The history of geology includes numerous methodological disputes that have been ongoing for decades, if not centuries. Think of the debate over Neptunism versus Plutonism at the end of the 18th century, or the controversial debate about the Holocene. It's not unusual for such technical debates to drag on. And today, less than 2 decades have passed since the AWG was established in 2009, and it is hardly surprising that its proposed periodization did not gain majority support at the first attempt. For stratigraphy, it is not only the question of recognizing a new epoch that is under discussion, but also the basic methodological framework of the discipline. So let's move forward, see what the future brings, and on this way embrace the potential for interdisciplinary cooperation and interscalar thinking that comes along with the analysis of the Anthropocene. Thank you.
Thank you, Fabienne. If you could just stay a few minutes, because we need to set up the screen and stage for our online speaker, who is number 4, and that's Baptiste Fressoz. Thank you for giving us such a positive outlook, if not for the Earth itself and us on it, but then for collaboration. Much appreciated. So we started with Helge, a cultural historian, and then had Jan follow as a geologist. And you, in a way, brought them together and said that we're on the way to converge. Helge, a cultural historian, and then had Jan follow as a geologist. I hear myself. And together on the way to converge. Helge, a cultural historian, and then had Jan follow as a geologist. Who do you think needs to move more? Aren't there fault lines? So I was immediately thinking, this cannot be true. It's too good to be true. Where's the fault lines in your story? Who has to move more?
I think that's not, I cannot give a general answer to that because it very much depends on individuals and
Yeah, please.
how much they are open to move.
Yeah, because there's also a lot
Enter
of
the dialogue.
traditionality in our subjects, and historians aren't the best
No,
ones to
not at
make
all.
a move anywhere.
Not at all. That's true.
So I was thinking,
But I mean,
this
we are
is a huge-
historians.
Yeah, well,
And
it's a
we
huge
kind of-
challenge
yeah, it's a
still
challenge. It's still
to make that move towards convergence and to think, as you said, interscale and interscalar ways, both in time and space. So that is not trivial. And but of course, I'm very willing to buy your story wholesale. We'll see. So thank you, Fabienne.
Thank you.
We have our fourth speaker online with us, and hope that he can hear us now.
Yes.
Jean-Baptiste, very welcome. Jean-Baptiste Fressoz, he's a historian of science, willing to technology. Oh, sorry, it's a bit of a, like everyone's talking at once, it seems. Historian of science and technology at the CNRS in Paris. And to a very wide audience, I think, he became known through the book, The Shock of the Anthropocene. Many of you will know it. Authored with Christophe Neu, came out in 2016. And then there is a more recent book titled More and More and More, an all-consuming history of energy. And that is about the energy transition myth. Energy systems, Jean-Baptiste shows, have not changed consecutively, but cumulatively, feeding the ever more insatiable hunger for energy in the great acceleration. So, welcome, Jean-Baptiste, to this session. I understand that you've also been listening to what the other speakers are presented.
Yes.
And here we have a very provocative, I think, statement from Jean-Baptiste that is titled The Accumulocene, another Anthropocene variety that is now out there in this huge diversity of Anthropocene terms. The Accumulocene, a symbiotic history of energy and materials in the Anthropocene. The floor is yours, Jean-Baptiste.
Okay, thank you so much for the invitation, and thank you for having me online. 10 years ago, at the signature of the Paris Agreement at the COP 21, Laurent Fabius, who is the person in the middle, the French Foreign Affairs Minister, said, basically, we are the first generation to understand the problem, and we are the last generation to do something about it. And I think there is a very problematic historical compression of time when we talk about climate change and the environmental issues in general. Indeed, if we want to limit the rise of temperature to 2 degrees Celsius, we have to do a kind of massive shift in the material basis of our civilization. We have to get out of fossil fuels in a mere 2 or 3 decades. And it is this idea of energy transition which became so prevalent and so obvious from the early 2000s onwards as the solution for the climate crisis. We are facing a planetary crisis. We have to do an energy transition. And I was really interested as an historian of technology and historian of energy, how history was used to talk about the future of energy. Very prominent people like John Kerry, for instance, the US envoy for climate change, used history to talk about the future of energy. For instance, when he said, what we have to do is a new industrial revolution, as if there was something analogous in history to what we have to do now facing climate change. And we also have this very wrong history of energy, sometimes appearing under the pen of the best experts. If you take the last IPCC Group 3 report, you got some very problematic mentions of history of energy. For instance, when they say that energy transitions can occur faster than in the past. As you all know in this room, for the moment, past energy transitions are somewhat mysterious. I mean, we have never burned as much coal as today, never burned as much gas and oil as today. Today, wood energy is the double of nuclear energy. So we are living with old sources of energy. If experts talk about past energy transitions, it's because they project on the history of energies models and ways of reasoning which were developed for the history of technology. This is a figure from the last IPCC Group 3 report. For them, an energy transition is a technological shift. It is just the diffusion of innovation, of green technologies. We have to replace old fashioned technologies with new technologies, with new green tech, with solar panels, electric cars, etc., etc. The problem is that this understanding of the energy transition does not fit the material history. I mean, there is a very simple historical point that I think we have in mind, and that in this room most of the people will know about, is that we are consuming more and more of everything. What I just said about the cumulative dimension of energy is true for every raw material. During the 20th century, we are consuming a wider variety of materials, and each material is consumed in greater quantity. There is a massive difference between history of technology and history of raw materials. Technologies do become obsolete sometimes, but raw materials are never obsolete. I'll just give you one example. At the beginning of the 20th century, most of the people would use petroleum lamps to produce light, kerosene lamps. And of course, then came electrification, and electricity made kerosene lamps obsolete. Nevertheless, during the 20th century, we are burning more and more oil to produce light. And today, just the headlights of the automobiles burn more oil than the whole economy, the whole world economy did in the early 20th century, when most of the people were using kerosene lamps to produce light. So you can have massive technological shifts, enormous innovation, revolutionary technologies, but the history of materials is much more boring. I mean, what I think is important to understand that it is that in the Anthropocene, the Earth is evolving much faster than the material world, than the material constitution of our economies. The history of the material world is boring, basically. We are just consuming more and more of everything at different speed, but basically it's just a history of accumulation. It is also a history of symbiosis. And I think this is really an important point. We have a far too stagist understanding of the history of energies. For example, for the history of industrial revolution, many of my colleagues talk about it as a kind of energy transition, a shift from wood to coal. And this is clearly wrong. For one simple reason is that you need a lot of wood, a lot of timber to extract coal, to the point that a country like Great Britain in the 20th century used more wood to extract coal for pit props than the country burned in the mid-18th century. So, and because it is construction timber, actually it necessitates a much bigger area of forest. So all this idea of the Industrial Revolution as a shift, as an energy transition is just clearly wrong. And the case of Britain is just one particular case, but all important industrialized countries used more and more wood during the 20th century until the 1960s, 1970s to extract coal. So wood is not secondary in the energy system of rich countries in the 20th century. It is absolutely central. Without abundant wood, abundant timber, there would have been almost no steam, no steel, no railroad, etc., etc. And the same goes with oil and coal and oil. The idea that there is a transition from coal to oil is obviously wrong. For one simple reason, to make a car, you need a lot of coal. Ford company would need like 7 tons of coal to make a car in the 1930s. In Britain, during the interwar period, for each ton of oil burnt in Britain, 2.5 tons of coal was required to produce all the steel infrastructure that made the burning of oil possible. And once you got oil, every raw materials become cheaper. Coal is becoming cheaper, so it's more widely used, and also wood is becoming cheaper. I will just give you 2 examples to show you how this stagist understanding of the history of energy, where you got a stage of wood and then the stage of coal and then the stage of oil is deeply wrong. One example is one big plantation of eucalyptus, which is possessed by a company called Vallourec, who is one of the big producer of steel tubes for oil extraction. Each year, Vallourec burns far more wood to produce charcoal, to produce steel that is used to extract oil than any European countries during the 19th century. So here you've got wood, which is used to make steel, which is used to produce oil, which is then used to extract wood. So all this idea of stages narrative is clearly problematic. Another good example is the case of Drax power plant in Great Britain. Drax power plant was a coal power plant, then it was converted to biomass around the year 2000, and each year Drax burns 4 times more wood than Britain burned in the 18th century. So, after 2 centuries of energy transition, Britain used at least 4 times more wood to produce energy than it did before doing all these energy transitions. So, once you tell the history of energy like this, as the history of the symbiotic expansion of everything, how come that this idea of energy transition became so consensual? First of all, we have to notice that it is a fairly recent phenomenon. For most of the 20th century, experts never talked about energy transition. They would rather see the future of energy as a bigger present. And then atomic scientists started to talk about energy transition. To my knowledge, the first person to employ this phrase is Harrison Brown. He's an atomic scientist from the Manhattan Project. And energy transition actually came from nuclear physics. It's a change of an electron around its nucleus. And Harrison Brown recycled this phrase to talk about the future of energy. At the beginning, energy transition was really a kind of long-term futurology. It would be a process that would last for several centuries because it would be caused by the growing scarcity of fossil fuels. There would be an energy transition because there would be no more fossil fuels and atomic power would reign supreme. But then this strange futurology was taken up by everybody during the energy crisis, especially by a US president called Jimmy Carter, who talked about energy transition in front of TV. It is at this time that a new vision of energy dynamics emerged, where energy dynamics was considered in relative shares. You trace the share of wood, the share of coal, the share of oil in the energy mix, and then you can show a kind of systemic evolution. But of course, it's one way to represent the dynamic of energy. Normally it was like that people would talk about dynamics of energy. It's at that time that this vision of a systematic change started to emerge, that also we started to use computers to imagine the future of energy. And this idea of energy transition came right on time for the oil companies confronted for the first time to the climate crisis. At the beginning, the fossil fuel industry was not climato-skeptics, but they were transitionists. Exxon would explain that, of course, there is climate change in the early 1980s, but we will do an energy transition. We will contain the problem with an energy transition. The idea of energy transition was also taken up by many different experts, especially economists, people like William Nordhaus, who got the Nobel Prize, who explained that there is a problem with climate change, but it is better to do the energy transition later, when we'll have the proper technologies to do the energy transitions around the year 2000. It's in papers from 1975. And then the idea of energy transition was also very, very useful for governments when the issue of climate change started to become important after 1988 in particular, and before the conference of Rio in 1992. In the archives of the US administration, it is quite clear that the idea of energy transition was seen as a kind of delaying tactics. Robert Weinstein, who was head of IPCC Group 3 and climato-skeptics, and was also a negotiator for the US at the Rio conference in 92, really took his orders from John Sununu, who was George Bush chief of staff. And basically, the strategy was, okay, we're not going to commit to emission targets. We're not going to pay if there are damages. We're going to play the technology card. This is really the phrase they use, play the technology card. And it's true that mitigation experts have played the technology card. If you take the all 6 IPCC Group 3 report, most of the discussion is about high tech. It's about fancy technologies. It's about technological change. It's about innovation. It's about green technologies. And it's also now a lot about carbon capture and storage with the kind of new backstop technology. And carbon capture and storage was really pushed by the IPCC Group 3 from the mid-2000 onwards. Of course, when you look at not net zero scenarios, but energy forecasting from the most expert institution like the International Energy Agency, well, they don't see any energy transition coming. And it shouldn't be a surprise, because energy transition is a radically strange notion, a radically heterodoxical future. And I would say that from an historian perspective, what really fascinates me is that it really used a false history, an imagined history, and it projects it onto a future that remains very mysterious. Thank you for your attention.
Well, we should get everyone on stage.
We should get all the speakers on stage, and we should have Jean-Baptiste present in the room as well.
But where are the others?
So Fabienne, please, and John,
Jan,
and
Helge.
Helge, come up here.
How much time do we have?
Question. I think we
Very good. Go ahead.
Yeah.
We have a few minutes left. Yeah, indeed.
Yeah, I think we have about maybe 15 minutes.
Yeah,
or so.
exactly. 15. Yeah, it seems.
To go, and thanks all for your eminent talks. And I would like, as a first question, to invite you to reflect on what we sort of contrast this session with what we heard before the break. We had a range of curves showing basically the same kind of message. And what I see in these curves is that if we sort of pushed our interest a little bit over to what brings that change, what is actually happening in societies and economies, a little bit like Jean-Baptiste now addressed very well. What is in your view needed to actually change this trend, to actually bend the curve, as they say? And what sort of knowledge making do we need for that?
What a good question.
It's the super big question. I'd like to lift it before lunch, at least.
Okay. Well, I mean, it does need. I mean, you know, the classic thing. You need to talk between disciplines, which is difficult because when I try and talk between disciplines, I find myself from being a geology professor to being somebody about 10 and a quarter years old, talking about something he doesn't know about very much at all. And I think that is, it's wonderful, but it's also quite difficult, and we're learning all the time on the thing. And if I'm to make a quick improvisation, let's say, on linking these things, all of the things, the 600 million kinds of things made by Amazon, which are part of this, the more and more and more of things that Jean-Baptiste just talked about, that has been produced by a whole set of engineers, financiers, the whole infrastructure, of knowledge, of money, of manufacture, of production, of sales, of dealing with that, of advertising in that. And so that is what links, if you like, the human process with the geological consequences. And I count the geological consequences as all of that stuff that's thrown out, mostly after it's finished with, and as Sarah has shown, will hang around for a long time. So to begin to talk seriously with, the manufacturers, the producers, the people who regulate all of that, it sounds to me like a long and complicated but quite necessary process if we're to get the heart of what is actually going on in this.
So is then synchronization an important tool in bringing all these actors out? Is there something that they didn't ever think about that has to do with clashes of temporalities?
Yeah, clearly. I think it's key, and it's also key in the moment we're at that you were. He's gone. The guy who was talking about politics earlier. Sort of how do you bring this kind of knowledge into political life so we can act upon it? How does it become actionable? I mean, and that's sort of the key part of synchronization for me, is to synchronize knowledge in a way that it makes it actionable, that makes it convincing, that makes it something that is both convincing and something that can give us sort of prompts for action. So, and I think to get to that moment, to get sort of to shape that moment as an act of synchronization, maybe the most important right now. And then the other thing, of course, is to figure out whether AI in this is a red herring or not, if we're going to spend time on it, or if we're just going to, because it just seems, at least in my environment, there's so much attention going into questions of how AI is going to take us out of this or further into this, and it takes so much energy and intellectual energies. We have to figure out what we're going to do about it, in a sense.
I hope we didn't lose Harry.
Still here.
Oh, still, okay, very good. I was just going to ask you, do we have to resort to destiny? Perhaps.
No. The destiny thing we'll leave to the pre-modernists. I think we're not going into sort of a religious idiom here. I don't think that would. But I do think there's sort of a way to synchronize scientific knowledge to make it and to make alliances politically that can make it actionable in this moment. I think is sort of where we're at, and I mean. There are all these attempts. The COP in Bellum is the last attempt to do this, but the question is what kind of forms? What are the suitable forms to do that kind of synchronization that also are politically actionable and viable?
I suppose you will be stepping in with the Globe Institute to contribute to this. I will, lastly, my third and last question is a string of questions is to Jean-Baptiste actually, because given what you just told us here, very, very important, as is your book. Are you a pessimist about the possibility of change, or how would you otherwise speak for change?
I don't see myself as pessimistic. I mean, I don't have this temperament. But no, I think we have to have a serious discussion about what we can really do with technology. I mean, if it's just about bending the curve, I think solar panels can bend the curve of coal consumption, for instance. But of course, the difficulty is to get near to net zero, which is a far, far more difficult task. And it is really what is needed to really stop or slow dramatically global warming. And I think we should stop dreaming about decarbonizing everything. It's a very naive technological vision of things. And we have to talk about the usefulness of CO2 emissions. Some CO2 emissions are going to be there, and some are vital, and other are more luxurious or not that important or not that useful. And we have to really talk about these issues of redistribution of climate justice in a much serious way.
Thank you. I think what came out of Fabienne's talk very well is that despite the variety of the terms that qualify the Anthropocene that you started out with, it's still the Anthropos in the center. And it seemed to me, like your question was, that we have a very good grip on all the sort of the factual side of things, right? The dire facts of the Anthropocene trajectory or state, whatever. But we don't have leverage to counter what Jean-Baptiste was talking about at the end, the more and more and more of our social and economic systems. And so how do we address this? This is really to bend the curves. I was thinking that it's at the end of the day, the object of the humanities, that is the human, that is at the heart of what we need to tackle in some way.
Yeah, and I think another very important point besides bringing it into politics is to bring it into the public. Because I mean, all of us here, we know about the trajectory, about the state of the Earth and of our habitat, so to speak. But there's still so many people outside who just don't know, or it's so abstract to them, this big dimension. I'm working in a museum right now, and there was the first exhibition on the Anthropocene back in 2014, and I'm currently curating an exhibition on planetary health, and that's exactly this big challenge to get this planetary, big, abstract concept into parts that are digestible for the public and that are that they can really feel it or can connect to it. And I think that's also a very big challenge in trying to bend the curves.
Yeah, we are humans seeking meaning, even in elections.
So we have some questions.
Please, yes, Anders Wikman, yes.
Thank you very much for your
introductions, very interesting. I think there is an elephant in the room. Economists. Conventional economics is, in my opinion, the main problem, because natural resources, including energy, is not part of the model. It's looked upon as external factors. And maybe that was okay 150 years ago when the economy, when the model was developed, because at that time nature was abundant, we were quite few people on the planet. But today, to have the same model, to me, is absolutely ludicrous. So please, what do we do about economists?
Who can help Anders here? Please, step forward. Jean-Baptiste.
Yeah, no, I mean, economists have played indeed a very problematic role in the climate knowledge. I mean, recently the last Nobel Prize was given by Philippe Aghion, who still talk about, there are green technologies that emit absolutely zero CO2. And the trick is just we have to innovate to accelerate the use of these green technologies. The idea of backstop technology, which was put forward by William Nordhaus, at the beginning, it was just a notion like the breeder reactor in the 1970s that would help the US solve the energy crisis. And then this idea of backstop technology was taken up by all sorts of neoclassical economists to talk about climate change. And it starts with this hypothesis. There is a backstop technology, which is a zero-emitting technology, which is available at a certain price. And then, of course, all the models is about, how can we make this technology appear quicker? So there is a whole rise of neo-Schumpeterian thinking around climate change, which is deeply problematic, which is based on this idea of technological substitution, and which does not fit the facts of the material growth of everything, despite all the innovations.
Anybody else?
Well, I think there's another factor here. If I can slightly decenter the anthropos a little from that, I think another useful concept here is that of the technosphere. The technosphere as looked at by Peter Haff, who was an AWG member, and the idea, I think, was found useful by a lot of us because he takes the whole of technology, everything that we do and make together, together with the humans and human institutions within it, and driving it and also being supported by it and constrained by it as a system akin to the biosphere, with its own dynamics and its own set. And I think that also provides another way of looking at the constraints. We're humans and we think we can do everything, but we can't. We're constrained by the structures which surround us and build us and which we take part in. And I think the technosphere gives us a good idea of those constraints, including on economists, and the people, let's say, who would support and use those economists, which relate to power structures in society, the people, the winners and the losers, the people who benefit from the system and the people who lose from it. They have different capacities to change the system. So I think, to look more broadly at these connections, I think might be useful, at least interesting.
Interesting, absolutely. The techno mass outweighing the biomass. That's in itself quite a...
It's telling.
It's very
That's
telling,
really
alongside
telling.
with the enormous decline in fauna,
Yes.
wild fauna. I think these are disturbing facts, and if people could know more about this. So please, Katherine.
Yeah, if the Anthropocene is really the recognition or the acknowledgement that we're influenced, we can change the conditions on Earth, and what we're trying to develop is a sort of a management of our relationship to the planet, then it seems to me we're in for the first time that humanity is in a position where you can't just innovate and see where it takes us. Oh, I made a tractor, let's see where we go. And we have to be innovating against a vision, and how do we get there? And so I'm interested, maybe it's to Jean-Baptiste, but I'm interested in historians in general. How much can we use the past when we weren't under those constraints as an analog for saying, where are we going now?
Yeah, it's an important point. Sorry. Just one very quick answer. Basically, the idea that it is the first time we try to limit our consumption of fossil fuels It is true that for climate reasons, it's the first time we try to do that, but fossil fuels have always been an important cost of production. And industrialists have been extremely successful in reducing their consumption at being efficient. I'll just give you an example. During and after the First World War, in the factories, people got rid of the old-fashioned steam engines and they replaced them with electric motors. When they did that, they divided by a factor between 10 and 15 the carbon intensity of industrial force in the factories. Today, with solar panels, we divide by 10 the carbon intensity of electricity production compared to a gas power plant. So we have been here before. So when you look at journals, technical journals in the 20th century, most of the advertisements are about more efficient motors, more efficient tools. So there is really a very long story of gains in efficiency. But of course, you all know about the Jevons paradox. It exists. I mean, it is really probably the biggest invention by any economist of the 19th century. The rebound effect is extremely powerful. And there is a symbiotic effect on top of that, which makes that materials and energies are connected each other.
Yeah, it's a really good question. I like the way you put it. It goes back to the question of thinking technology in terms of progress, right? That there's a step, that these are moments of progress that bring us forward, right? And they're not really responding. They're sort of internal processes within sciences, step by step, or some steps are bigger than others, but still there's not an idea that these are responses either to future needs or to present needs, except in a very incremental way. So I guess to think science true, I mean, CCS is such a great example of that same logical process that doesn't seem to apply anymore in that way, but we like it to apply. And like economy, there's a very different time frame that needs to be thought out to think of technology in a different way and how we can respond to a very different future scenario. I think that doesn't have that progress, that doesn't sort of give room for that idea of progress anymore.
Well, I'm stepping out here as the great synchronizer, reminding us that there will be stomachs operating inside a particular temporality, and they require their feed. So we should thank the speakers' fantastic contributions.
Great. What a fantastic bunch of talks we've listened to so far today. This has been an amazing experience so far. My name's Alasdair Skelton, and together with Jan, I'm going to chair this third session where we're going to look at the Anthropocene as a scientific paradigm shift. We're taking perspectives from geology. You're looking at two geologists, and there's more coming, Earth systems and science history. I'm not good at these kind of long intro things, so I'm not going to give one because I'm just a geologist. And I already know how much we like geologists at the moment. So I'm not going to do any. And what's really good news for me is that Jan's already been introduced, so I don't have to try and pronounce his last name, which is beyond me. So Jan's going to kick this session off with an update from the Anthropocene working group. And the one thing that was not said in the previous introduction is Jan is a part of the Anthropocene working group, which kind of needs a background for what Jan's going to take us through. Jan, the floor is yours.
Okay, thank you very much, Alasdair. So if we, this will be just it's a brief update, so not a talk as such, just news in passing on what we're doing on the Anthropocene working group. And it's a new, informal, independent, still evolving sense of that. So where's the technology? So as you know, the Anthropocene working group was not if you like, anything volunteered. It was a task given to a group of us by the chair of the Quaternary Subcommission of the International Commission on Stratigraphy, after a paper had come out in 2008 by geologists saying that a formal Anthropocene might be worth considering. It didn't go much further than that. And as a result of that, there came an invitation, to form this group of people, which gradually evolved. I think I was asked to be chair. I had no idea what to do at the first, except invite potentially, useful people here. I think two things. One, it was the only working group which probably had a minority of geologists on it. At least half the people were other than geologists. Amongst those were Paul Crutzen and Will Stefan, who extraordinarily, with wonderful generosity, which I remember to the day, they did not feel at all possessive about this idea that they had developed and used for 10 years, but that they simply got together with us to try and make this word official. What happened then was simply a lot of work which was done after the AWG was the ultimate cottage garden industry in any kind of science, I think. For most of its course, it had no funding whatsoever. People simply gave of their time as they could and as they wished to at the time to get involved in projects in that. And as a basis for that, mainly by email and mainly late at night, it just gathered information towards establishing whether the Anthropocene, which clearly made Earth system science sense, planetary sense, whether that made geological sense as identifiable strata as well or not. And so a whole pile of evidence was gathered, mainly as meta-analyses towards that. And towards the end of the process, around about 2015, I would guess, or so, we'd realized that, yes, this thing did make sense. It was an epoch in every sense, geologically an epoch, and should be formalized. As a result of that, Colin Waters, who's here now, was then chair of the AWG, and coordinated, with Simon Turner, the then secretary, this amazing task of during COVID times, of putting together thousands of bits of individual data from 12 different sites around the world to try and find, the golden spike, the level within strata that would define the beginning of the Anthropocene. So there's that's the front page of the proposal that's written, never yet published. That is on its way. Colin will shortly explain the details of it, and Francine even more. That was the general idea, that the timetable would be changed. The Holocene would stop in the mid-20th century, in 1952. The Anthropocene would then take over from that as an epoch of time different from and in comparison to the Holocene. And then, as you all know, that idea was very quickly rejected, by a rather complicated voting process in the Quaternion Subcommission, and then agreed and ratified by the ICS and the IUGS above that. So the Anthropocene is still a de facto epoch. It has it. It looks like an epoch. It feels like, sounds like, tastes like, even smells like an epoch if you go to the right site. But it's not formally an epoch. So what do we do? Well, it's clearly it hasn't gone away. We're all here as evidence of that. So, first of all, we're no longer a part. After the announcement of the rejection, we became, if you like, disenfranchised, whatever, from the ICS. We simply carried on, as an independent body of that, and we're still in the process of evolving into this new independent state. In full realization that we're now in a very different kind of situation now. we're now just one of many bodies, and one of the smaller ones, and within of a whole set of other institutions, centres. This is only a selection of them that have the Anthropocene at its core and are doing, all the main and most important work on it. So the thing is, within this kind of landscape, what can we sensibly do? Because we're still, we had brief funding for 3 years, and wonderfully, we had funding to actually do the work on the GSSB that Colin and Francine will describe. But we're back to our state of being driven by, I think, whatever collective spirit and we still have from those times. So it's still that kind of organization. Again, aware of the fact that the Anthropocene has developed into a whole set of raft of different areas and disciplines where it is as or more important as it is in geology. So, what do we do? So very briefly, one idea we have is to simply try and use whatever experience and connections we've developed to help link and help the work of the other Anthropocene institutes, bodies, individual workers, whoever might be interested, to the best of our ability. So there is a certain use there. We certainly there's no sense in which we a sense of ownership or competition. We're just happy to be part of this growing enterprise. One is, when it was started, it was a very specific body with a very specific mandate, to follow the geological statutes, as it were, so it had a very specific task, as well as trying to be more widely understanding of what it was we were trying to define. So I think this broadening of interest is an ongoing part of the AWG. And also, we hope a broadening of membership. We're still a cottage garden industry, we still have no money. We would like to stay, I think, like that, because it gives a certain freedom and a certain flexibility that we think is still useful. But we are adapting internally. For instance, there's now, after Colin was chair, I then became chair again. Now, recently, Mark Williams has agreed to be a vice chair, so we can share that role. The secretary's role will also be split. There'll be a website starting soon, a quarterly newsletter starting soon, which is Libby Robin has offered to put together. So there'll be a bit more activity and a bit more visibility, we hope. So that will, if you like, be the basis for whatever projects we do. One remaining project, of course, is still the formalization, because while that is, as Johan said, in many respects it doesn't matter, but in some it does, partly because the Anthropocene's meaning has been stretched so widely in so many areas that it makes sense to try and at least define it clearly and precisely in one sense, so it can be used even quantitatively as well as qualitatively in that. So that effort will go on, and then we're still interested in the whole area. So if you're interested in becoming part of this, we're just about at the stage where we can begin to open up, expand, and begin to do that. So thanks for your patience with this bureaucratic stuff. Now, hand over to Colin, who, like me, is a career geologist, with the same reflexes as a career geologist. But he had, again, I have to say, in the most difficult time of COVID, he was given the most difficult task, of him and Simon Turner, of coordinating this huge exercise, of spending wisely 800,000 euros, which we got for 3 years, and to put it all together in the end. It was, I can't think of many other people who could have put it together like that. So, Colin, explain what happened in that process.
Thank you. Thank you again for the invitation to speak to you today. So I'm not going to talk about a justification of the Anthropocene. I think we've had quite a few people talking about that already. And in 8 minutes, it's impossible to try and justify why we felt that the Anthropocene was a justifiable epoch of geological time. I'm going to take one topic only, which is, why did we pick 1952? It seems a bit of an arbitrary date to select. I'm going to look at the evidence from 12 sites. So these are 12 sites that came forward in 2020 as potential reference sites for the Anthropocene. And they, amongst themselves, came up with about 100 different proxies for recognising the Anthropocene. And I can't deal with all of those in 8 minutes either. So I'm going to select 7, which is the nuclear fallout signals, that's plutonium, radiocarbon, and cesium-137. Burning of fossil fuels, so that's looking at stable carbon isotopes, and fuel ash particles, they're called spheroidal carbonaceous particles. And also nitrogen enrichment and looking at stable nitrogen isotopes. And then finally looking at biotic change. As Jan mentioned, we submitted the proposal in 31st of October 2023, and it was rejected in March 2024, at which point we thought it was important that you and others had the opportunity to see the full submission. So if you go to Archive and look at these 3 files, this is how we submitted it. There's an executive summary, which is available at file 6853. Part 1 was really the logistics of why we felt the Anthropocene was recognisable and as a rank of epoch. I'm not going to talk about that today. Part 2 is actually looking at the description of the definition, our definition of the Anthropocene, which was specifically at one location, Crawford Lake. And Francine, who's on next, will be talking specifically, I guess, about her site in Ontario, but also supported by a number of auxiliary sites as well. And what I'm going to do now is summarise that information. And hopefully, there's, at the bottom of the list, there's this paper which we submitted into Nature Reviews Earth and Environment, which is going to have the figures that you're seeing today included. So, 12 sites. If you, for each of the squares, you'll see that there's a location name, the core name, because most of these are actually in borehole cores, thickness of the Anthropocene in centimetres, and then the age range of the core itself. So in many cases, it actually extends well into the Holocene. And for each of the 12 sites, I've colour-coded it here so that in blue, in pale blue here, we're looking at lakes. 3 in particular, Crawford Lake in Canada was selected as our GSSP, the reference point, the key stratotype section. But also there's the Xihailongguan Ma Lake in China, which was selected as one of our auxiliary sites, and also Searsville Lake in California. The one speleothem we have, which is shown in red here, is from Ernesto Cave in Italy. We had 2 marine successions, one from not very far from here, East Gotland Basin in the Baltic Sea, and also then Beppu Bay in Japan, which was also selected as one of our auxiliary sites. We had 1 peat section at Snieżka peatland in Poland, which again was selected as one of our SABs, auxiliary stratotypes. 1 urban deposit, Karlsplatz in Vienna, which was the one that wasn't in a core. It's actually a section which is now unfortunately buried underneath a museum. 2 coral sections, the North Flinders Reef in Australia. Oops. So North Flinders Reef and also the Flower Garden Banks Reef in the Gulf of Mexico. And then we have 1 ice core, which is the Palmer Ice in Antarctica, and then the San Francisco Estuarine succession. I should just point out as well, actually, the range of thicknesses are quite spectacular between Ernesto Cave at 0.4 centimetres thick for the Anthropocene versus Palmer, which is 34.9 metres. So going through the signals, our primary marker, the one that we thought was the one that should define the base of the Anthropocene, is that of plutonium. All but the Ernesto cave site was studied for the plutonium signal, and you see that there's a very robust increase in the amount of plutonium in pretty much most of the sections. The change point analysis median value is 1952.9, which by coincidence is also when the first thermonuclear device detonation, which is the Ivy Mike on the 1st of November 1952. So it does look as if this thermonuclear detonation inspires a very globally reaching, almost isochronous boundary, which is what we selected as our base of the Anthropocene. There's a consistent peak around about 1963 between the sites. Some of them aren't quite as good. So San Francisco, you can see that there's a degree of local reworking has meant that there's a persistent signal without a spike. Also, some of them have very low values, such as the reefs, coral reefs, and also the ice core. Supporting the plutonium is other bomb spike markers. And we have, if you look at the cesium-137, which is getting shown in red, it can form a very prominent spike, very similar to plutonium. It's quite complementary in that it's a 1952 onset, 1963 peak. We can see that not all the sites show this, so there's certainly evidence of upward mobility of the cesium. In the European locations, so East Scotland and Snieżka, actually more specifically show what looks like the Chernobyl signal rather than the 1950s bomb spike. So there's a degree of mobility to cesium, which makes it less suitable than the plutonium. Also radiocarbon, which is shown in blue. There is a consistent pattern of an increase in signals, but it's about 1959, so it's quite a bit later. And the justification for that is radiocarbon is naturally occurring as well, and it's taken up until about 1955 for the atmospheric signals to change significantly to be able to see them. And Snieżka is quite good in that, being a peat, its signal comes directly from the atmosphere. So that change is happening around about 1955. But if you look at some of the other markers, such as in Ernesto, the coral reefs as well, there's a tendency for that change to happen much later, because there's a degree of time for the atmosphere to equilibrate with the bodies of water, particularly oceans. And so that signal is that much later. So it's probably less useful to use something like radiocarbon because there's that time lag to it of about a decade. Stable carbon isotopes, what we expected to see was some negative shift in signals related to the Seuss effect. So burning fossil fuels creates a higher percentage of the carbon-12 signal. So this is something we did see in several of the sites. So there's this deflection to negative values, but not always in 1950. And in the case of the East Scotland, it actually is a more positive shift because of the this is a phytoplankton uptake of specifically carbon-13, makes it shift the opposite way. But there's a sort of broad marker around 1952, but not consistent. Fly ash, another product of burning fossil fuels, it's about 50 microns across. You can see the picture down here. It's a very distinctively pitted particulate produced from the high temperature burning of fossil fuels in thermal power stations. And that has a fairly consistent pattern to it, though it's not quite as isochronous. So though we've got a median figure of 1948 for its onset, you can see that places like Searsville, it's that bit earlier, it's 1930s, and Beppu Bay, it's 1960s. But again, there's a clear signal related to the Anthropocene here. Stable nitrogen isotopes, what we expected to see was a shift to more negative values. However, that seems to have happened over prolonged periods of time in some of the samples. Some of them have happened around about 1950, some of them much later. Some of the signals are actually going to more positive values, probably because there's more of an influence from sewage and wastewater and animal waste, rather than from artificial fertilizers and fossil fuel, which gives you the negative shift. And then finally, biotic markers. There's only a few of the sites that actually have biotic markers within them. And what we found is that there's this obviously distinction between all the sites. There's no way that you're going to correlate particular markers between these individual locations. But what we did recognize that there were certainly markers which represent either first appearances or last appearances of species, or increases in abundance of species. And you could map those out between the different locations and use them as specific local stratigraphies. Some of them related to things like nitrification happening around about 1950, or in the case of Searsville, it's actually introduction of non-native species, in this case an ostracod. So just to summarize, the AUWG proposal includes 12 sites. They covered 5 continents and 8 different environments, so truly a global analysis. We found that there was a near isochronous upturn in plutonium isotopes in 1952 across many of the sites. So this represented our optimal, our primary marker for the start of the Anthropocene. The radiocarbon upturn has a slight lag and it's slight diachronous and has a less pronounced peak, so maybe it's not so suitable as the plutonium. Similarly, the cesium-137 upturn and peak can replicate the plutonium-1, but is much more mobile. And of course, it's a half-life of only 30 years, so it won't have a persistent record in the geological record. Stable carbon isotopes can show a mid-20th century shift, but it's not a consistent signal. The SCPs show a decadal scale upturn around about 1950, but a variable peak and there's a diachronicity of a couple of decades. Whereas the nitrogen isotopes show no consistent shift around the mid-20th century. And then biotic changes are diachronous, but can produce a functional local biostratigraphy, at which point I just want to acknowledge all the members. I know Jan showed the slide of all the members of the working group. So to acknowledge their involvement in the production of the report and in the research we've carried out over 15 years or so, and also to thank Haus der Kulturendewelt in Berlin, who provided this funding in 2020 to 2022, which made most of this research possible. So thank you.
Thanks very much, Colin. And now, joining us, I hope, from on the screen.
1 minute.
1 minute, okay. So will be Francine McCarthy, again, an Anthropocene working group member who led the research, on one of the sites Colin mentioned, on Crowley Lake, and developed her work. Francine had started working in using this extraordinary lake record, these annual archives, to look at older human history through the Holocene, going back 1,000 years and more. And then when this work turned up, she, with great enthusiasm and efficiency, developed this work into the last 70 years or so to develop the story of the Anthropocene as told in this small Canadian lake. So hopefully she'll be joining us in just a second. Though I have to say, one of my regrets about the process is that in the classical geological way, stratigraphic way of definition, there always has to be one winner amongst the candidates of the site, and that is the golden spike, the GSSP, and the marker. And there's often fierce competition about that for all kinds of reasons. Whereas in the way that the work was done on the Anthropocene, it's really all 12 sites and more besides were equally important in actually showing what was happening around the world in geological terms to build up the whole global picture. So while by tradition, and by some functionality, there has to be one site, and Francine will describe this one rather wonderful site. The other 11 sites are also wonderful in their many ways, and just as revealing. And I think one of the jobs of the AWG, I'm still waiting for Francine there, is simply to develop this work. When you think of most of geology and most geological periods, there are now hundreds or thousands of examples of histories around the world through a particular site. Whereas in the Anthropocene, we're just starting. It's just the beginning, to develop this picture. So Francine, are we?
She's not on. We're going to need a couple of more minutes.
No, okay. Yes, well, I think we can use this time. If anybody has questions for either Colin about the States or even myself about AWG. Colin, would you like to come forward? Yeah.
Yeah, I'm not a geologist at all, but I was just curious, is it significant that there's no site in Africa?
It was, the funding was announced just before Christmas 2019, and basically we had to start doing the work almost immediately. So what we had to do was find a number of teams to come forward, prepared to do the work. So we had to have some degree of knowledge that it wouldn't be wasted money, so that people were doing the research already, and it was likely to come up with positive information. And so we didn't need teams which were already established and could react quickly and also then contribute. Our goal was never to look at one marker, it was trying to do as many different proxies as possible. So it tended to involve those institutes that had that broad range of expertise and could do that work. And it didn't matter how much we tried. South America, it was South America and Africa. We had no sites for there. Not because they're not suitable, it was just that at the time, in that very short duration, we couldn't get anyone in to do the work. If we asked the question now and said, if we'd fund this next year, could we get teams to do it? We probably could.
Okay, now can you see my screen?
Yeah.
Oh my goodness, this is good. All right. Oh, you've heard my intro, so I'm not going to say it. Okay, so as Colin just told you, we used a number of different proxies at 12 different sites, and they all recorded very clearly the effects of the Great Acceleration. And with that midpoint of about 1952.9 years, it all makes perfect sense. So it's not just the site at Crawford Lake, but all of the sites that we looked at showed a very, very similar signal. And the spheroidal carbonaceous particles were not just studied by us. They had previously been studied, particularly in lakes around the world, and they all show a very similar pattern. And it's a little bit of a good news story because you can see the decline in spheroidal carbonaceous particles as Clean Air Acts were enacted around the world. So it does show that we can affect the changes that we have made. But of course, the key thing is that all of these things continue to increase, and there's a little bit of a blip during the COVID lockdown year, but other than that, we see a continuous acceleration in key things like CO2 emissions and the concentrations of greenhouse gases in our atmosphere. And one of the things that I find really interesting that's not talked about very much is the impacts of nitrogen fixing and the production of artificial fertilizers, which contributed to the #1 issue, which is human population growth. So it's good that people are not experiencing famine, don't get me wrong, but the issue is very, very, very expensive to the environment in many ways. And one of the things that I didn't know until I started researching this is that the process itself is currently fed by methane. And of course, methane is an even more intense and efficient greenhouse gas than CO2, even though it has a much shorter residence time. So they're looking at ways to lessen that, and which is good. But yes, so we see these effects not just in Crawford Lake, and this is a summary of the effects that we see in Crawford Lake with the spheroidal carbonaceous particles in the center. And we have effects that we see in terms of concentrations of metals, and we see the impacts on the biota, as Colin said in a previous presentation. And the key thing is that at Crawford Lake, we see very, very clearly the impact of Ivy Mike. And as we saw in all of the sites, as Colin showed you, and because the record at Crawford Lake is It's varved, annually resolved, and like a barcode, we can identify each varve individually. The record is very, very clear. And on the left, you can see the record of plutonium plotted against the amount of phosphorus applied as fertilizer. On the bottom left, you can see it in relation to concrete and plastic, so novel, well, relatively novel products of very much the latter part of the 20th century and today. And all of these things, of course, have an impact on the global system, which is the definition of the Anthropocene as opposed to the Holocene, because we humans have become the dominant geologic agent, and that is the point of the geologic Anthropocene. So you can see much more clearly now the record of plutonium that we have, which is very, very faithful. It maps, it tracks the amount of plutonium that we know was detonated in atomic and H bombs. And so this is the impact of Crawford Lake in terms of society. It's currently, there is an exhibit at the Royal Ontario Museum that is receiving a lot of attention. And there has been the exhibit at the Crawford Lake Conservation Authority of a lot of the materials, including the artistic outputs that have been inspired by the work of the Anthropocene Working Group. So the idea, the wampum belt that you see on the left, the idea that we have had an impact on the sediments and on the environment has been woven literally into the art of an Indigenous artist. And at the bottom of that lucite box, where it is suspended in Crawford Lake water, you can see crystals of calcite that crystallized, that precipitated over the 6-month period in the summer that it was exhibited, which is in fact what happens in Crawford Lake naturally. It is that summer precipitation of calcite that caps every summer that allows us to use the record-like tree rings. So it caused a huge kerfuffle when we announced that this site was chosen as the proposed GSSP, and it caused it led to a number of opinions published around the world, including in The Guardian, and I don't need to tell you how GSSPs are erected, but we really feel strongly that precise nomenclature matters and precise time zones matter. And one of the things that I used to illustrate this is that last year at this time, I was in Lisbon, and there was an online presence there as well. And some people joined an hour off because nobody seemed to realize that Portugal is on Greenwich Mean, whereas the rest of Europe is not, other than, of course, Britain. So when you tell people Anthropocene, it should ideally mean the same thing for everyone and not depend on how they view it. So that is certainly the our perspective from the Anthropocene Working Group. Of course, you know that the proposal was rejected, but people whose job it is to just look at the data, like Hannah Fry, can't imagine how this could have happened. Like, if you just look at the data are perfectly clear, and the popular sentiment seems to be that we are definitely in an interval of time that is unprecedented, that it is unlike the preceding Holocene. And of course, from a scientific point of view, we have reached tipping points. We know that there are aspects of the Earth system that are overwhelmed, that are no longer able to keep taking on the chin what we've been dishing out. And this has enormous implications for the near future, given that our children, our grandchildren are going to experience a very different world than the one we live in. And increasingly, the closest modern analogs are not earlier in the Quaternary or even in the Pliocene. We're looking to the Miocene and potentially even the Eocene for modern analogs. And there were no humans living in those intervals. So we don't know the human impact of the kinds of conditions that are being forecast, that are being modeled for 100 years from now. So there are all sorts of these rather scary tipping points that I don't have time to get into, but I just wanted to leave you with this. Just this past week, I was at a film studio in Toronto, and I've become a life-size hologram who is going to be answering questions to visitors at the Crawford Lake Visitor Center. So I just never expected that to happen. So I thought I'd leave you with that. Thank you. And sorry for all the confusion. I'm not used to these multimedia things.
Okay, thank you very much, Francine, for that. Yes, as we have you as a, not quite a life-size hologram, but almost the next best thing in contact here. So, without further ado, we move on to the next talk. Francine, if you'll stay with us for the questions and discussion afterwards, that would be great. And now, Alasdair, I have to introduce as somebody who, to put the Anthropocene into a bigger context.
Thank you very much. Thank you. Oh. Just waiting for my slides. I'm sure they're about to arrive. I couldn't possibly say a word without slides. It'd be too terrifying. They're on this screen, so I think they're going to show up there in just a moment. So I'm a geologist. I've already admitted to that. And in a room where I'm almost a bit nervous to be a geologist, because we're not necessarily all that enormously popular when it comes to the Anthropocene. So I'm going to share a little a reflection on the Anthropocene, which, having read this article, I got really confused. Why was it rejected? I mean, it just seems so completely obvious that humans are geological actors. It was like in your face obvious, but then very, very wise and clever geologists had obviously thought otherwise. So I set up, together with my good friend and colleague, Kevin, we set out to answer a question. We thought, I've heard in this room this morning something that actually worries me. I've heard people refer to the stable climate of the Holocene. Now, I'm a geologist. We live in an ice age that's been going on for 2.6 million years. The temperature goes like this. It's not even vaguely stable. The Holocene is 11,700 years. That's like a fart in the ocean of time. It's absolutely minute. But I thought I'd have a look at this stable Holocene and compare it with the Anthropocene. So just for those of you, this is a map of geological time for the Kenozoic era. Geologists divide up time into eons, eras, periods, and epochs, which are successively shorter. We only divide up the last part into epochs because we're not clever enough to do the older bits. So that's 66 million years from the extinction of the dinosaurs up until right now, and the Holocene's right up at the top. The Holocene is too thin to even fit in that timescale. The definition of the Holocene is the start of the warm episode that began with the end of the last glacial period. We call those warm episodes interglacials. Now, we asked ourselves, first question Kevin and I asked ourselves is the Holocene actually all that different than the previous interglacials? There's been somewhere between 40 and 50 interglacials during the past 2.6 million years. So, I mean, the temperatures goes. So what we looked at is the ones that there's data for, which is the last 5. And what we look at is a temperature anomaly. And we compared the Holocene, which matches which basically crosses all of the past 5 interglacials. The one thing one perhaps can argue is it is a fairly flat one. But when we look at that data, I would think, well, why would I choose this one interglacial and call it an epoch? Why didn't I take all the other 40 or 50 and also call them epochs? And then, of course, there's an obvious reason, and that's because we're here. And then we're getting kind of anthropocentric. But it's defined on the basis of climate. And the climate's fairly similar for all the other ones. So really, in terms of the Holocene, we should have at least 50 epochs during the last, just during the Ice Age. Next question we asked is the Anthropocene, of course it doesn't exist, but if it existed, is it different than the Holocene? So what we've got here is the standard deviation of the temperature anomaly for the Holocene. All the data stuff is at the bottom. I don't have time to go through it. And we'll just superimpose temperature data. And what's interesting there is we left, from 2013 onwards, we're no longer in the climate of the Holocene statistically. So yeah, the Anthropocene does appear to be different than the Holocene. Okay, well, that's not the Holocene's not the only epoch. What about all the other ones? How does the Anthropocene compare with the other ones? Well, let's go back in time a bit. So let's head to the beginning of the Pleistocene. So that's more commonly sort of known as the Ice Age. So how's that actually defined? Well, it's 2.58 million years ago that it started, and it marks the midpoint of a 300,000 interval during which Northern Hemisphere glaciation intensified. Okay. Well, what about the Anthropocene? How does that compare? The climate signature of the Anthropocene, we'd argue, is clearer than the midpoint of a 300,000 year interval during which Northern Hemisphere glaciation intensified. If we go a bit further back to the beginning of the Pliocene, by the way, for those of you who don't know, if you were here in the Pliocene times, you could walk to Finland. You'd have to cross the Eridanos River, which would be a problem because it's quite big. But you would be able to, it's a completely different world. So we go back to the Pliocene and see how that was defined. The base of the Pliocene is at 5.33 million years ago, and it's marked by the return of open marine conditions in the Mediterranean Sea after its desiccation during the Messinian salinity crisis. So that's a regional event. Something happened in the Mediterranean. What about the Anthropocene? So in contrast, we would argue that the base of the Pliocene, the wide array of stratigraphic proxy signals, that's all these technofossils and so on, associated with the Great Acceleration, it's a global event, which is one of the, maybe a slightly stronger case than the Pliocene has as a regional event. We go back to the beginning of the Miocene, so now we're 23 million years ago, and here we're seeing a transient 400,000 year long global cooling event. And it's global cooling by about 2 degrees. It's coupled with a near doubling of the size of the Antarctic ice sheet and a 150 part per million fall of atmospheric CO2 levels. So temperature's changing, atmospheric CO2 is changing. And how did that one compare with the Anthropocene? Well, it's also associated with a hundreds of thousand year time scale global climate events. That's because CO2 stays in the atmosphere for once you increase CO2 levels in the atmosphere, it takes a very long time for it to drop again. So we can, current thinking is we're looking at hundreds of thousands of years for recovery. And currently, at least when we wrote this paper, we were at 150, we'd already changed the CO2 levels by 150 parts per million, which is the same as for the Miocene. We could go back to the Eocene-Oligocene transition. Now, this is 34 million years ago, and it was preceded by a major climate shift from greenhouse to icehouse conditions. So Earth has a greenhouse state, it has an icehouse state, and during icehouse states we can have ice ages, which we're living in one at the moment. So it's associated with global cooling of 2.5 degrees over 500,000 years, and that's coupled with the start of glaciation on Antarctica. And it was also preceded by a big drop, 250 parts per million, of atmospheric CO2 levels. How does that compare with the Anthropocene? Well, the Anthropocene is associated with warming that's 4,000 times faster than cooling during the Eocene-Oligocene transition. The rise in atmospheric CO2 levels is 50,000 times faster than its fall during the Eocene-Oligocene transition. So arguably, there may be a bit of a case for the Anthropocene. If we move back to the start of the Eocene, that is associated with the beginning of a hyperthermal. These are not very nice. This one's called the Paleocene-Eocene thermal maximum. Temperatures shot up by 6 degrees in just 20,000 years, and it lasted for about a couple 100,000 years, and it was associated with a one or two doublings of CO2. Compare that with the Anthropocene. Here we're associated with warming, massive rise of CO2 levels. It's also, as I said, forecast to last for hundreds of thousands of years, and warming is something between 50 and 80 times faster than at the onset of that hyperthermal. Okay, we only got one more, the Paleocene. And this is a special one because it's also the beginning of an era. That's the Cenozoic era. And the base of the Paleocene, at 66 million years, it marks when an asteroid struck the Earth and caused the 5th mass extinction. So that wasn't a good moment in Earth's history. So if we compare it with the Anthropocene, we're looking at species extinctions among mammals, birds, reptiles, amphibians, fish, gastropods, bivalves, and plants, calculating extinction risks at 2 to 3% of all living things at 1.5 to 2 degrees, 5% at 2.7 degrees, 30% for business as usual. Which brings me to my concluding slide. Is hold on, it was my old presentation was there, so never mind. My concluding slide is I was referring back to the original definition by Walsh, which was not the Anthropocene at all. It was the Anthropozoic era. And maybe what we actually need to be thinking about is this an era? Is this the Anthropozoic era rather than the Anthropocene? Thank you very much.
Great, thanks very much, Alasdair, for that quick sprint through time. So we carry on with geology, and I'm very pleased to introduce Kim Cohen, who also a member of the Anthropocene Working Group, also a geologist, but one with a hugely relevant experience of the last 2.5 million years, in particular the Quaternary, where we really have to make the comparisons work.
Yeah, and I'm going to zoom in more to the Holocene only, so that's the 11,700 years, than the full Quaternary. Because the Holocene may be what you could call the geological present, or maybe the geological present is shorter than the Holocene. It's only the late Holocene, or it's only the last century. It's only the last year. It's only the last second. And if you think like the present is the last second, it's the event horizon from the keynote opening. It's just a front that moves. Yeah, then the past is very long and it ended 1 second ago. But maybe if you are a geologist and you, in your undergraduate years, you were taught about the present is the key to the past and those kind of phrasings, then actually maybe the present has a little bit of duration. Maybe the last year is a good one, because when we mean the present is the key to the past, we don't mean what happens in 1 second with the Earth, but we mean the environment as it is now, the processes in rivers and deltas as they operate now, thinking away humans, maybe thinking the last remaining semi-naturally operating systems. That's our training ground, that's one of our references, and a very important one. And also a very important one because it's the only time period where not solely geological methods can be used, and where the discipline that does, that uses geological methods, geology, maybe archaeology a bit, maybe environmental sciences that likes to use cores also to study pollution. So when I say geology, I don't mean solely the geology of the previous talk, but also environmentalists and biologists by training. So that look at what the present is, then you get on a timeline without any ticks on it. So think of it as starting. If you think of time, it starts on the left with the beginning of the Earth or something. And then very quickly we change scales from billion years to million years to 1,000 years to the last years if you are in the Anthropocene. So that timeline, either you use the momentous present, the event horizon present, or you say, well, let's be a little bit more liberal. Let's say there is some time period we call the geological present that has a duration. And I want to develop that. So then you can say, well, what we call quaternary, is that the same as the geological present? I would say no, it's longer. And the previous talk with all the climatic changes, and we have Pleistocene and Holocene for a reason, two different names. Not only because we are humans, but also because it's the most recent period where there is so much very recent stuff that we want a different word for than stuff from times that there were not yet humans witnessing its deposition. So, and this is basically the status quo now. So on geological charts that I sometimes draw, it's drawn like this, usually made vertical instead of horizontal, and it ends with a horizon called present, and it ends always with a youngest period. There's always a youngest period, no matter what you define. And this is also then used, so I want to show an example. So there is Crawford Lake from two presentations back. It's the geological way of studying it, also the environmental way of studying it if you seek that kind of evidence. But there is, from that same period, that this uppermost part of this frozen core, I think, covers, parallel to it, there's a lot of other instrumental record collected by physicists and by all kinds of background people, by engineers even. And that is a time series style record, also satellite imagery you can put there. Also census data on the amount of people or economic use of resources data. Basically all the graphs in this Anthropocene dashboard, or the planetary boundaries graphs and the trends in that we saw in the opening sessions. Most of them are recorded as it happened. What's the difference with the geological way? Why is it complementary? Because it's more independent. You can go back in time using geological data. The only problem is you have to wait until after it happened, and then you can start collect a core, and then you can retrodict or do forensic exercises to puzzle out what happened. And if you do that for the last 100 years, that's what I also will come at, is you're actually playing a different game than if you do that for 100,000 years ago, with a similar length of core, also from a annually wharfed lake, but just not one happening to be in the presence of humans, of recording humans. So the things that you can look at are availability. So in the last 100 years, yes, there is geological data available. You have to do work. There are 12 sites studied with the scope of inventorying those markers that are of global importance and ranking them. Plutonium is even better than radiocarbon, that kind of ranking. But you can also collect it with a local environmental scope and so on. And you will use the overlap with the other things that you know about that region and that time. And you will use a datum, usually calendar years. And then you can see how you get there. In the case of Crawford Lake, there's also the Dust Bowl spike from 1935, and then you count the number of annual layers upward, and that's how you get 1952. And that's even better than counting from the top of the core, because the top mud is so difficult, you never know sure if you have the last year or the second last year at your start. That kind of use. Now I zoom out to 1,000 years and 10,000 years, and I deliberately show a map. It's a map of a part of the Rhine Delta. Utrecht is my university is on top of this map. And we use rainbow colors. Red is the very youngest river, orange is a little bit older. Yellow is Bronze Age almost, or Roman times and Iron Age and Bronze Age. If you make such a map for the very youngest rivers, I use historical maps drawn 100 years ago, 200 years ago, and then I know what part of my map I should give the youngest color. If I go to the medieval systems, I use the archaeology, maybe one odd classical mention. I also know when there was a dike created or a dam, so I know at what point things stop functioning. I then start using all kinds of data from historical sciences. So here is river generations. Next to it is very Eurocentric royalty generations from Charlemagne until Carl Gustav. We are in a Royal Academy of Sciences. How is it all connected? That's also why I use orange, so halfway in this color scale. But the way we do use it is also our calendar and how we actually know this dam in the Rhine was built in 1122. It's because it's recorded as in the 5th year of the rule of such and such emperor. And we make use of what humanities, maybe not the part of humanities that analyzes the reasons why all these things went on, but also in humanities there's a calendar developed. So that overlaps. If you go 10,000 years ago, no longer. So if I go back to cores, and again look at availability overlap, I have no problem getting nice cores of the middle Holocene of my delta. There's plenty. And they look very similar to cores, say, from the last couple of centuries. But if I look at the things that I do with those cores, it's very different things with the last couple of years than with these earlier ones. And it boils down to the questions that we ask ourselves while looking at those records. Usually it's in the young stuff, it's, I know 1809 it was the biggest flood in that century. Can you point me to the layer of 1809? It's a question you get in the geological present because it overlaps with historical data, instrumental data, even if you, at some point there is a horizon where you miss it. If you go beyond that horizon, then you are in the geological past, in my understanding of it. And then it's radiocarbon dating still, which has a calibration story. So you can actually tease out what is about the calendar date also with radiocarbon. But yeah, there I would say it's really geological past already in the Holocene. So to round up, I think there are two types of record, the as it happened record, recorded by humans, and then there is geological reconstruction and archaeological and blah, 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 where the Earth did the recording and it is scientists that then afterwards tease it out. And if you look at the availability of such record, close to now, close to present, the majority of that record in our current world will be the as it happened. It's far superior in accuracy, in quality, in control, etc. The geological record, there is some. You have to work hard and fast to publish data that is up to 2024 in 2025. It's almost impossible. But if you go a little bit further back and more relaxed, then at some point, the geological reconstructed data, that's in the majority. And then you can point all kinds of boundaries. Where does this start? 23 or so. Where is this? Somewhere in the Holocene, I guess. Where is this point, this crossover point? May differ from region to region. Eurocentric, it's maybe a little bit older. Parts of Asia, parts of Egypt, it's a little bit further back than in Amazonia or something. And the questions are difficult, are different. So I feel that all this GSSP rule book and how to define it is developed to work in the geological past. It's a jump to say that's also the method to use in the geological present. That is only 100 years ago, where there are so many other records also. Why should it be solely geology that defines? Yes, for comparison with the rest of geology maybe, but for utility from all the other disciplines, maybe less so. So if I'm to ask where is Anthropocene as proposed by AWG, you can also see that defines basically the start of the present, or maybe it's better, it's the second half of the geological present is the Anthropocene, but there is a little bit of geological present also before 1952 or 1950, where it's similar coverage of this non-geological data, so yeah. So what happens, what about the present geologically, and what happens when you introduce Anthropocene? That was my talk. It points down to the interdisciplinarity, also from the data usage perspective. In the definition should be interdisciplinary, in my opinion, because it is in the present and not the geological past as traditionally understood. So conclusions: geological present has a duration shorter than the Holocene, a bit longer than the proposed Anthropocene. It's a time period where, well, we widely use calendar ages and the datum associated with the 1950 is BP of calibrating radiocarbon dates and so on. Where other data trumps geological data, I would say, especially in availability, also in quality generally. GSSP data not per se needed. I do think that the definition of the geological present would be good, and of an Anthropocene within the geological present would also be good. That's my lens on this topic.
Great, thanks very much, Ken, for stretching out geology into other disciplines, as of course we should be doing. Finally, we manage the Anthropocene now with Kevin Noon to wrap up the discussion finally. Thanks very much.
Thank you for the opportunity to be here. I'm going to take a little bit of a different tack than my science colleagues and my colleague Alasdair, and fasten and hook onto the Anthropocene as a paradigm shift, since that was the title of maybe our session. And I'll be concentrating on that. So my work is not really coming from the science me that worked at the Department of Environmental Science, but the management me that does executive trainings and stuff like that, and that's the green stuff on the right side of the screen here. And also be going from the point of departure that there might be a small group of recalcitrant geologists who are standing on platform 9 3/4, wondering what the heck happened to the Hogwarts Express, and the rest of us are on the train. So I'm going to be speaking to the folks on the train today. Okay, so in my mind, one of the paradigm shifts, one of the transitions that the Anthropocene involves is a transition between the Holocene period, where we had the opportunity and the pleasure of dealing with tame problems, and the Anthropocene, where we have the duty to deal with wicked problems. So what's the difference between a tame problem and a wicked problem? And this slide sort of shows a summary of some of those differences. And one of them has to do with the problem itself, is that a tame problem has a very clear definition, whereas a wicked problem depends on who you ask. The role of stakeholders is quite clear in a tame problem. You go and ask an expert, right? Sometimes that expert's a scientist. But for a wicked problem, different stakeholders have different perspectives on the problem. For a tame problem, you know when it's done. You've increased efficiency for your solar cell by 15%, check the box, it's done. Whereas a wicked problem, you don't know when you've solved it because it changes all the time. And the nature of the problem as well. For a tame problem, we have analogs. We have handbooks for how to solve a tame problem. We've done that before, been there, done that. But for wicked problems, they're all new, they're all different. So we don't have the opportunity to have been there and done that for a wicked problem. So now I'm going to show you how nerdy I am, because this is one of my favorite images ever. And it looks like a bowl of spaghetti bolognese to most people, but I love it. And one of the reasons I love it is because it illustrates what wicked problems look like. So it comes from the World Economic Global Risk Report from 2020. And what you see here, this is a perception of global risks from the people that respond to a survey sent out by the World Economic Forum. You can see that in the middle there is climate action failure, right? And the size of the diamond in this figure is proportional to the degree of connectivity of that particular risk to other risks. So the first thing you see is that you a whole bunch of different kinds of risks: green or environmental, blue or economic, purple or whatever color that is, or technological. Blue have to do with economics. But you can see that these risks are connected, right? And for wicked problems, this is a wonderful picture for me because it's complex. Wicked problems are conceptually complex. Wicked problems are dynamic. They do not stand still. The goalposts are constantly moving back and forth. They're tightly coupled to other problems, right? So climate action failure is directly coupled to involuntary migration. It's directly coupled to national governance failures and so on. Many of these are problematized or characterized by incomplete or conflicting information. They contain normative characteristics like what should we do about this particular issue? And that different stakeholders have different formulations about not only the solutions, but the problem itself, right? They also inherently involve dealing with trade-offs. So just as one example that I got DALL-E AI to make this image for me, and I threw at it, I said, so make me an image of what happens when we clean up the air, because one of the reasons we want to clean up particulate matter in the air is because it's nasty for us, right? It causes human health effects. But if we clean up the air, that means we accelerate global warming. It makes it even faster, right? So this guy is looking for his breakfast bagel in downtown Los Angeles on Saturday morning, and he's breathing wonderfully clean air, but he's wading through sea level rise at that particular point, because it's a trade-off, right? So how do we handle those trade-offs? It's part of the management technique. So I do management executive trainings for the private sector, bunches for the military and civil security, a whole bunch of different sectors, right? And this is just some of the stuff that have come out from those training exercises. Is that handling wicked problems, a multi-stakeholder process is absolutely necessary. It's not just a good thing, it's absolutely necessary. That we have to start off in dealing with wicked problems from a point of mutual respect. And I've got complications here over on this side with each one of these particular points of departure. And dealing with big egos can be challenging. We all know that. We need to build a network image of the problem. That's why I love that World Economic Forum thing, because it's got this network image about it, but that might look different to different people. Here's a difficult one. And I think it's one of the other things that causes a paradigm shift is I think we need to concentrate more on the feedbacks between all of those nodes than on the nodes themselves. And that's tough because I might be an expert on one of those nodes and you might be an expert on one of the other nodes. And it's not that's needed, it's the feedbacks between the nodes. I'm going to come back to this one, avoid linear prioritization. So I'm going to hop over that. Make those trade-offs, like I tried to illustrate in that previous slide, very clear. But who gets to make the final call about those trade-offs, right? Who's in charge of the ship? Obviously, we would like to base decisions on evidence and not ideology. But all of us have cognitive biases that are oftentimes very difficult to identify and deal with. And here's another tough one. Be humble. Be humble enough to know that you've made a mistake, to admit that you've made a mistake and say, okay, we'll go back, we'll do something differently. But the challenge there is humility is not a trait that we try to value. Oftentimes we want a decision maker that way, right? Being humble is not really valued. But I want to come back to this linear prioritization thing, because I think that's one of the, a very interesting one. Now, you might have seen this article that Bill Gates published end of October this year. Donald Trump loved this particular article, because Bill Gates basically wrote that, hey, look, climate's a thing. Climate change is a thing, but don't get all hooked up about climate change because there's other stuff going on like people's health and other important issues. And so let's tone down the climate change thing a little bit. Okay. But coming back to this exercise, right? So let's go back to that picture. Climate action failures directly related to water crises, involuntary migration, governance failures. And so if Bill Gates took one of my trainings, I would say, Bill, it's yes and when we're prioritizing in the Anthropocene. It's not either or. You don't get to pick one of the nodes. You have to prioritize the network, and that's how we do it. So this is happening. This is part of the paradigm shift, and I was really glad to see a number of different new educational programs going on at different universities around the world and whatnot. That's very cool. I'd like to see this turn into a great acceleration because I think we need it. But I'm hoping that we could come up with a new educational paradigm where we talk about networks and feedback loops. In that educational paradigm, we talk about ethics, we talk about empathy. We come up with ways to manage those trade-offs because that's one thing we're really bad at this point, right? Decision-making under uncertainty. I've had the opportunity to work with the military domain and civil security agencies, and they know this stuff. They've been doing it for a long time, and they're good at it, so we need to learn from them. Active listening, working in and managing teams, and the last one is, a medical sort of analogy is that we need to educate general practitioners, not just specialists, right? We need to look at the Anthropocene geophysiology and say, okay, we need some GPs for Anthropocene geophysiology. And I'll stop there and thank you for your attention. And leave you with a couple
Thanks very much, Kevin, for rounding us up, taking us full circle to so how we can make sense practically of the Anthropocene. How are we doing for time?
We've got 5 minutes, so we could
Let's
bring
have
our
some
speakers down here
Let's
for
finish off the questions.
a couple of very quick questions. And if Francine is available. Sorry, Kevin, should have told you that before. Did you climb in over there? So who's going to be brave? Open the floor for questions.
Coffee. Everybody wants coffee.
Another question. Perhaps a very naive one, but if the geologists don't want the Anthropocene, is there another sort of professional group that could be appealed to take this on? I don't know, like the International Union of Earth Scientists, or the... You're looking at me with blank faces.
It's a really good question, I think, because I think the main, I think there are probably two reasons for geologically, chronostratigraphically defining the Anthropocene, and one of them is because it is an epoch. You know, it does work. I mean, Paul Crutzen suggested it. We tested it out, and it is.
Yeah.
But as you know, the idea was resisted. You know, for a number of, because too short. And all of that kind of thing. And the other thing is because it stabilizes. It's the best way to stabilize a term. Not so much because it should be used by all geologists, but because it's a really good way of fixing the meaning in pretty much the original thing. But you're quite right. We're all here because the term is found useful and the idea is found useful by so many other disciplines. So to start discussions amongst other large, equivalent, scientific institutes, organizations, who have an interest in this, I think would be very useful to not maybe to find alternative ways, because I think it still would be useful, to fix it like this. The work has been done; it clearly works, despite its controversy. But to extend its meaning, its range of meanings across other things, and going through those other institutes, I think would be a terrifically good idea.
I agree with that. I think there should be more stakeholders than just geologists in defining the very youngest time period.
And just within the geology community, the International Commission on Stratigraphy, is there a process then, a sort of follow-on process to I don't know, to counter the decision, or is there like how do these things normally happen? I mean, the Holocene took like a century to get established anyway.
Yes, it did, and a number of the big definitions were accompanied by a good deal of raised blood pressures and fur and feather flying and all that kind of thing. And as you said, took years or generations to do. So I think it's the decisions, the rejection was made by a very small number of people within the entire thing, who were representative of part of the community, but not the whole by any means. My impression is, certainly amongst the younger generation, most are accepting of the Anthropocene as a valid geological unit. So I think partly it's time to let scars heal and blood pressure settle, I think, is one, and to allow discussions to start again, with the new ICS, the new IUGS.
But was there a particular issue which tipped the balance against?
I think there were several, but I think two main ones. Go on.
I personally feel the decision was made in 2014 before we'd even put forward a proposal. So it was already decided by those with power within ICS and IUGS where the debate was going, because the actual data behind the submission wasn't the reason for rejection. At least as far as we've received any feedback, it's never dealt with the data. So part of the issue is when we actually try and resubmit, you almost have to know the mood music is positive, because there's no point doing it if there's not a general support amongst people like ICS in the first place. So it's probably a continuum of a working group discussing this and making sure that those who are involved in decision making are aware of the background behind this, and too much of it becomes reportage from media, where we've talked to media, that gets passed back to the geoscientists who think that we're saying one thing when we've said something completely different when you look at the data and the publications that are produced. So it's convincing people to go back to the evidence base and make your own mind on that basis, and not what someone tells you to think, which unfortunately is part of the decision making at present. And I just put a point at, I think, one of your presentation about GSSPs, and should we use them in the present day? I would say yes, we should, because in 2015 we said let's use the start of the atomic age, 1915, 1945, as the start of the Anthropocene. That was just let's use a specific time interval and say let's call it this. But then the whole process of using this analysis of GSSPs that we went through over the next 15 years has proved a different boundary, because we were looking at all these levels of data to try and support the GSSP, and it moved it to 1952, and I think it's a much more robust boundary than the 1945 we had originally suggested. So I think that there's a value in going through the traditional process, and the great thing about what we've done is it's backed up by the monitored data, so that we know that the signal that we're talking at 1952 to do with plutonium relates to detonation of thermonuclear devices in the same year, whereas geologists generally are only seeing the outcome. We're seeing the markers, but not the cause. In many cases, we don't even know what caused some of the signals we're looking at. So there's never that certainty about how the driver and the event, the effects actually link together. We can see this and demonstrate it very precisely using modern data. So I think it strengthens the whole argument of why GSSPs work, is because we can demonstrate where there's synchronicity and where there isn't.
Yeah, I don't fully agree with that. I agree with the signal, but it also gives a bit of a wrong message to call it geologically in isolation, whereas from newspaper archives that somebody pushed a button to detonate Trinity at this moment, and radiocarbon dating people are for 50 years now, or even more, 70 years now, using BP, which is 1950, nice round number. There are all kinds of maybe more pragmatic aspects also that the fundamental solely geologist view on looking at the last 100 years could be considered a little bit tunneled. Although the outcome is super clear, and although when I was in SQS, supported the proposal, or GSSP, GSSA, whatever you call it, I don't care so much about that. I find it important that it is defined. But the way you can define, also now that the previous round was halted, maybe we can reconsider, and maybe that is also needed to get more, get engineers on board, get atmospheric sciences on board, get climate science on board in whatever units they are united, and make it not primary. It comes across as primarily geological, because that should be the definition of such a period in young time. And if you are more inclusive, maybe that helps. So that's,
Fine. I think we are now at the stage where we all need a nice cup of tea, in classic geological fashion. And I'd like to thank all of the speakers, Francine in Bloom, for another terrific session.
Cool. Welcome back, everyone. If you can take your seats. Okay, if you can take your seats. Great. Good to see you back. We've saved the best for last. We have an amazing final session for you. If that's and it's been an amazing day. This session is on the Anthropocene as a paradigm shift for governance and stewardship. So a lot of the questions that have come up throughout the day, actually, I hope relate to this. And certainly we won't have all the answers, but we'll be having more provocative ideas here. So just as a very short framing on this, I think if I look back at 2015, 10 years ago, the sense of euphoria with the Sustainable Development Goals in September that year, and then the Paris Agreement in December, there was a real sense that something really huge is changing, and that we're moving on in the right direction. This is, the beginning of planetary stewardship in some shape or form. And now here, 10 years later, we're looking back at those times and going, how did we get it so wrong? There's so much change happening in the world. There is a change happening. There is a transformation, a big geopolitical reordering. We don't know where it's going to land, but right now it's not looking so positive for many of the things that we need to move on to positive trajectories. Technology won't save us. That's the other thing we realize when we talk about AI, that's been mentioned earlier. The last time there was a technology revolution with social media, that turned out to be the biggest mass experiment on humankind in history. And that hasn't been good for bringing societies together, to bring communities together, even though that was the promise. And it's already having an effect on democracies, etc. So, we need massive guardrails up when we talk about, disruption from technology. But the good news is, I think, is that all the data shows that many people want planetary stewardship across the world. People want planetary stewardship across the world. The majority of people in G20 countries, acknowledge that the world is approaching tipping points and want their leaders to do more. So there is something really, there is an undercurrent, there is a paradigm shift happening, I think, culturally, but it may be not translating then into governance and into, the political regimes.
Yeah, no, it's this big questions, right, that we have. I think we all sit with. How do we change things, right? And we talked about it today, and it's about, like what you said about shifting pathways, and we're on a trajectory now that is not take us in the right direction, etc. But so we know that transformations is needed, large scale, rapid, deep transformations are needed. But we also know that when you start pushing systems, you will get a resistance. And right now, we talk about a transformation backlash in the research. And how do we deal with this backlash that we see, which includes polarization, democratic backsliding, violent conflict, etc. How do we deal with that? And how do we keep momentum of the transformations that we started? And it shows that also that transformations comes with sort of deep emotional and psychological challenges. And we talk about in the research also about transition pain and transition risk, and which we need to acknowledge, and especially with the process of phasing out. So how do we phase out what's not working? We talk a lot about the innovation and how we create new solutions, etc. How we scale, how does that have an impact? But the phasing out is really a challenge, and we need maybe collapse. So how do we collapse things? That's a big question. That's why we have Luke here to help us learn about that. And also we have some of course some challenges then of stewardship and governance. So we have people going to talk about that. And then we have also, which I like, is, but what about China? So we have Dilian here, Chen here to talk about that also. So yeah, should we start?
Indeed.
Do you have anything else?
No, that's it. No, we're going to start. So we have Luke Kemp here, who is from Cambridge University, the Centre of Existential Risk at Cambridge, and he's just published a book called Goliath recently, looking at the history of civilization, humanity, and collapse and growth and regrowth and transformation, and these issues. And we're very, very much looking forward to hearing you talk.
I also want to say that in the notes here, it says, I love this, I just have to say this line. He studies the end of the world and how we got there, here. Yes. So it is yours.
Ooh, do we happen to have a
clicker?
Should be.
You did. I think it's that one.
Yeah. Blended in. Thank you for the very grandiloquent introduction. Today, I want to talk to you about radical approaches to governing the Anthropocene. And by radical, I want to harken back to the original Latin meaning of the term, which means to go to the root of. I believe that navigating the Anthropocene in the coming decades and centuries will mean addressing, identifying the root causes of why we're in the Anthropocene in the first place. Now, most of us, obviously, when we think of the Anthropocene, we think of it as being quite a recent thing. Obviously, starting the mid-20th century, here's my obligatory Great Acceleration visual. Unfortunately, far less good than other hills, but regardless. And even when you stretch out the timeline, you still see the Anthropocene in things like the global GDP, energy consumption, temperature. In every single case, there's that big exponential curve. But there's some nuance here. When we look at something like land use change, it's quite clear there wasn't just one great acceleration. If I zoomed in on, say, for instance, the 16th century, during the time of colonization, or the mid-18th century, during the Industrial Revolution, those two would have looked like great accelerations in terms of land use change. And the same is also true of agricultural intensification, roughly 10,000, 8,000 years ago. And this is echoed in the different dates people have proposed for the beginning of the Anthropocene. And what I want to highlight here is that even if we choose the golden spike of 1952 as the beginning of the geological epoch or era of the Anthropocene, causally, we can think of this as a long-term process, going all the way from a thin and slow Anthropocene to a thick and fast one, but one that happens over thousands of years. And it's worth noting that despite the anthro prefix, this is not all of humanity doing it. Carbon Major Database talks about how since 2016, with the adoption of the Paris Agreement, only roughly 57 companies were responsible for 80% of emissions. The richest 1% globally emit more than the bottom 66%. And the top 10% of consumers are responsible for roughly 31 to 67% of degradation of 5 different planetary boundaries. This has led some people to claim that we're not living in the Anthropocene, but rather the Capitalocene. I mean, there's two problems here. One is that the golden spike was just as much caused by Russia, the Soviet Union, in other words, a socialist country, and additionally, all the different bits and pieces of capitalism are actually seen in the Bronze Age. Roughly 4,000 years ago, we had wage labor, we had multinational corporations in the Near East, and we also had a growth imperative. Importantly, this is not just about the Earth system per se. It's also about our growing capacity for destruction and for self-destruction. If one looks at the destructive potential weapons over history, you see a very similar spike, very similar exponential curve, as we've seen over and over again today. This one is looking at the amount of energy in terms of joules released by the most powerful weapons of their age across human history. All the way from the bow and arrow through to the nuclear bomb, which was 2 trillion times more powerful. And I study existential risk, thinking about things that could cause either global societal collapse or even in the very worst case, human extinction. And of course, we often talk about climate change, but there are, of course, nuclear weapons. We live under the threat of 12,000 of them today. And increasingly, there's new ones on the horizon, such as the prospect of engineered pandemics, imagine smallpox but worse, or even advanced artificial intelligence. And it's worth noting, even this is not a kind of far gone prospect. We already see lethal autonomous weapons being used in Libya and in Ukraine. Now, how do we get here? How do we get into this point of accelerating Earth system impacts, but also general destruction? I think to tell that story, we have to go 300,000 years back into the past, to our very beginnings as a species, as Homo sapiens sapiens. And while there's some debate about how exactly we existed during the Paleolithic, there's some convergence around 2 key facets. One is that we have no signs of enduring inequality. And that's not just because we lacked a surplus of wealth. It's also because, as far as we can see from modern-day nomadic egalitarians, such as the Hadza in Tanzania or the Khoisan here in the Kalahari, there's an active social choice towards egalitarianism. So it's based upon the work of Christopher Böhm and others, where they find that when one individual in these groups tries to dominate, they tend to be cut down, either figuratively or literally, usually for ridicule, ostracism, or in the most extreme cases, in-group execution. Apart from that, it's also notable that all these groups don't leave much of an archaeological trace. They engage in very little conspicuous consumption. Some have called it the principle of least effort. They tend to be very frugal with their use of energy and often try to maximize their leisure time. Some call it optimal foraging theory, that the way they forage, once again, is very frugal and conservative when it comes to energy use. What's interesting is that both these things dramatically change once we get to the Holocene. While the exact timing varies across the Holocene, whether it's in Mesoamerica, South America, China, the Near East, or even North America and Africa, you see exactly the same progression. People start to settle down, they engage in sedativism. Eventually you see a progression from interpersonal violence towards in-group skirmishes and eventually organized warfare. And then, after several thousand years, you see the emergence of the very first kingdoms and empires. What all of this really means is we're slowly moving from a social blueprint of egalitarianism towards one based upon dominance hierarchies, where you have a king, a commander, an emperor sitting above the rest of society. Essentially, one individual starts to dominate the rest, impose rules, and extract resources. Some call it civilization, I prefer to call it Goliath. And why does this happen? How do we have such a huge shift in human social relations? One of the big reasons is status competition. There's strong agreement across social psychology that status competition in humans is universal. All of us like to be admired, respected, and loved. But some of us want it much more than others. Who here would actually want to be a politician? Yeah, it sucks, right? You have to spend your entire life trying to pursue power. It takes up most of your time. You probably have to, compromise your morals a little bit. Most people aren't willing to take that effort to achieve power. But of course, some people are. And why are they willing to do it? For status. This is Harold Huntington, a millionaire from the 1920s, an oil baron, who once said, for practical purposes, someone who has $200,000 a year is just as well off as I am. Money's just a way of keeping score. I suspect the same is true of people like Trump and Musk today as well. Now, status competition, as mentioned, is not equally distributed, and importantly, there's different ways of achieving it. Very few people are willing to go for status through the use of violence, force, intimidation, and bullying, what we call dominance. But some people are, notably in the work of Christopher Böhm every single individual trying to dominate a group of hunter-gatherers was a man. And we also know today that they tend to be overrepresented in terms of the dark triad, a set of 3 antisocial personality traits: psychopathy, narcissism, and Machiavellianism. The numbers here are highly disputed and very uncertain, but in general, at least for men, there's rough agreement that amongst the general population, 1% of people would pass the clinical threshold for psychopathy. In boardrooms and parliaments, it's somewhere between 3 to 21%. Now, again, numbers are very disputed, but what's not disputed is that you're much more likely to find a psychopath, not in the grocery store, but in the parliament. And just on a superficial level, we can probably see that today as well. And this helps to explain why, historically, if you look at a history textbook, it's essentially a roll call of mass murderers. Genghis Khan, Napoleon, Alexander the Great, not known for their virtue, but instead they achieved status through domination, force. Another thing changes. Apart from a change from egalitarianism, we also see a change away from the principle of least effort. Suddenly, when you look across the archaeological record, for the first signs of inequality, we look for things like grand monuments, grand burials, whether that be gold jewelry or entire armies of terracotta soldiers, or human sacrifice. This is the very first city of the United States 1,000 years ago, Cahokia, where hundreds of people were sacrificed. But Cahokia is not exactly exemplary. The same happened in Uruk in the Near East, the Shah dynasty or the Shang dynasty in China, and Monte Albano in Mesoamerica. What's common across all of these is their conspicuous consumption. It's what my favorite archaeologist Bruce Trigger calls a thermodynamic explanation of symbolic behavior. In short, if we have a natural impulse to conserve energy, then the ultimate way of saying I'm more important than you is to wastefully, excessively use energy. And that's exactly what happens in all these cases. The Great Pyramid of Giza, really just built for one individual, took 400,000 years of work hours. Of course, killing large groups of people, who often at the prime of their working age, means suddenly you're losing often decades or centuries of working hours as well. In every single case, it's a wasteful use of energy, conspicuous consumption, or as a way of saying, I'm more important than you, I have higher status than you do. And we see it today, of course, with skyscrapers emblazoned in one man's name, yachts worth $500 million, and arguably even states do this when it comes to nuclear weapons. And you see this reflected genetically. Roughly 8,000 to 4,000 years ago, there's a big compression in the Y chromosome because a small group of men were starting to monopolize reproduction. Now, what does this mean for governance? In terms of policies, not much. We all know what we need to do. We need to put a price on carbon. If you want to get rid of nuclear weapons, there's the 2017 Treaty on the Prohibition of Nuclear Weapons. Instead, what this means, I think, is we have to start reconceptualizing what status is and how to achieve it. For instance, the Athenians had the idea of the triarchy, which was essentially if you were rich in ancient Athens, you had a public duty to maintain a trireme, one of their big warships. What this meant was that basically the rich of Athens spent most of their money competing in terms of who could make the cooler, bigger ship. Suddenly, they were actually benefiting the public, but also capping their own wealth. We could do a similar thing today as well. Imagine if Bezos, rather than spending $500 million on a private yacht, instead put that towards global sanitation or global education. But I don't think that will be enough. When we think about the rise of the very first kings and emperors, what they're doing is essentially melding together different forms of power. Power over resources, power over decision-making, power over information, all of them were divine figures usually, and power over violence. They were usually also the commanders of armies. How do we do that? I think the big one here is democracy. As mentioned, we're at the 80th anniversary of the Trinity test. So 80 years ago, the very first atomic weapon was exploded in the sands of New Mexico. Beforehand, the scientist Enrico Fermi was taking bets as to whether this would destroy the entire Earth. That's because Edward Teller, another physicist, had made a calculation that there was a non-zero chance that detonating the bomb would ignite the entire atmosphere of Earth, killing not just all humans, but every single shred of life. By that time, the US also knew that the Nazis were no longer capable of making the bomb, nor even pursuing their own project anymore. They still went ahead and took the risk. I want to ask you a quick little thought experiment. Imagine that you had a random selection of US citizens, nurses, teachers, farmers. You gave them this information, you said, should we detonate the bomb? What do you think they would say? Obviously. And I presume the same would be said actually during the 1970s when ExxonMobil and other fossil fuel companies were bearing information they had about climate change, which, by the way, threw and DuPont did exactly the same thing when it came to novel entities. If you had a citizens' jury there, would they say, yes, please bury the evidence and run misinformation campaigns? Probably not. I think that's a very important intuition that democracy can basically help save the world, that the use of things like citizen assemblies and citizens' juries would lead to far better governance outcomes. But it'll be difficult to have in the long term. If you have billionaires, they'll find a way to rig the system. So I also suggest we have to find a way to cap wealth, to level economic power. So in the book I put forward, cap wealth $10 million. As Hunton said, anything beyond that isn't necessary. If you really like, you can get a trophy saying, congratulations, you won capitalism. Good job. And we also need to find new ways of encouraging transparency and leveling information power. It's worth noting that, of course, fossil fuel companies and chemical manufacturers tried to find ways to hide information about the damages they were doing, which once again is indication that they didn't want people to know. And that'll be very difficult to address the Anthropocene if we live in a world where information is dominated by a couple of key players, such as the surveillance capitals and firms like Amazon, Meta, and Google. These are some very big, audacious arguments. If you want to find more details or 1,000+ endnotes, you can read my book, Goliath's Curse, The History and Future of Societal Collapse. To cap, I think that addressing and navigating the Anthropocene is not going to be a simple matter of just having a few more taxes and international treaties. Instead, it will require a radical re-envisioning of how we achieve status, what is status, and a radical balancing of power, a reconfiguration of power. Under there.
Wow, thank you, Luke, very much for that. And just, I mean, on one, this dark triad you mentioned, the psychopathy, the narcissism, the Machiavellian instincts, etc. And, you know, well, how do psychopaths and narcissists convince people to follow their orders, to do, you know, if what they're saying is so sort of morally reprehensible, how can we see time and time again that large numbers of people will follow those orders? And our next speaker, Professor Emily Kasper, is going to be addressing this question. Now, with a talk called Just Following Orders, the Neuroscience of Obedience, which is also more or less the title of your book in Cambridge University Press. Emily, who's Associate Professor at the Department of Experimental Psychology at Ghent University and the Director of the Moral and Social Brain Lab. And the main mission of the lab is to uncover the neural basis of moral and immoral behaviors and exploring questions around, you know, can we develop efficient tools to reduce radicalized behaviors and prejudiced attitudes? And much of your work actually focuses on the absolute extremes of, you know, genocide, when the people Luke is talking about drive people to very, very extreme behaviors. So Emily Kasper, please, the floor is yours.
Thank you. Okay, so basically my talk today is about, you know, how can we explain that some people obey harmful systems while others risk everything to save others? I'm a neuroscientist, so I'm going to be a bit more into the details of the mechanism while keeping it large, but just to show you what we're doing to try and understand why we keep on going, having atrocities, mass murders, genocide, and so on and so forth. I'd like to start my presentation by a quote from Horace, who stated that historically the most terrible things, war, genocide, and slavery, have resulted not from disobedience, but from obedience. And
when you look at the history of mankind, I mean, in the Western world, the most famous example that we have are the Nuremberg trials, where senior Nazi officers claimed that they were just following orders. Of course, this has been seen with skepticism because they had a clear motive of avoiding punishments. But I've been interviewing myself former genocide perpetrators in Rwanda and in Cambodia and so on. And actually what is interesting is that despite the fact that they come from very different cultures, very different historical events, periods in history, they would have brought the same reason to explain their participation. When I asked them, why did you commit a genocide? While they were just civilians, so not even trained military members, 70% of former perpetrators in Rwanda said, I just followed orders. And in Cambodia, they report exactly the same reason. And what is very interesting is that in Cambodia, I don't know if you know a bit the history there, but none of them will ever fear prosecution because they only consider that the top leaders should be held accountable for what happened. So it means that all the more low-level executioners that I met, they will never fear to go to prison, so why they would find a justification, and yet they report just following orders. So for me, that's an interesting question. Why do so many human beings on different continents, in different eras, use the exact same justification to explain the atrocities they commit? And into this, why do some people resist? So I'm going to make it short, but of course, here I'm talking about genocides because that's my main topic of research, and I do not mean that obedience to authority is the only factors that can explain such mass atrocities. Here I'm talking about that today for the sake of time, but most of the time, and we see that today, and I'm just back from Israel when I just interviewed soldiers who just returned from Gaza, and they said exactly the same. But most of the time, we see that similar social events or systems are at place before an extermination phase. Most of the time, categorization process, discrimination process, dehumanization processes, which I will talk a little bit more tomorrow for the shared humanity or common humanity talk. But so here when I mention just following orders, that doesn't mean that if I give the order to my neighbor, just go to kill another human being, she will do it, of course. But that means that obedience to authority, as we will see, has lots of effects on how the brain works and process information, and that can explain that why so many people can be convinced to continue participate in these mass atrocities. So in neuroscience, most of the time, we need an experimental paradigm to draw conclusions that respect and control lots of factors and variables. And here, that's a paradigm I developed at University College London, where we have participants, real people, coming for a study, and one of them is assigned to be the agent, and the other one is assigned to be the victim. And the agent has a decision to make, either to press a shock button or a no-shock button. And they have to make a moral decision because they are told that if they press the shock button, they send a real painful electric shock to the victim in front of them, but they earn 5 cents. And if they press the no shock button, they don't send the shock, but they do not earn extra money. And how do we investigate the effect of obedience on the brain here? We contrast two experimental conditions, one in which they have to make this decision entirely freely. We tell them, okay, look, for 60 trials, you have to make the decision to send the shock or not to the other person. And in the other experimental condition, they receive orders from an experimenter to give shocks or not to the other person. I must say, at the just human level, this is a very interesting study to, just get a bit of information on human behavior. And when I designed this task, perhaps I was too optimistic at that moment. I really believe that no one would ever administer a real shock to someone in front of them for 5 cents. That has been weeks of discussions with my colleagues. They said, yeah, you will see, they will do it. I'm like, well. In practice, we started, and I was pretty wrong, because in average, people sent about 34 shocks out of 60 trials freely to the other participants to earn £1.70 for no reasons, just earning £1.70. Something also that surprised me is that, I was testing university students. Most of them, they know about the famous studies of Stanley Milgram, who is very infamous because he showed the extreme of obedience in a laboratory context. And I thought, there are students, they have heard of it, why they would obey my orders? I was sure everyone would disobey. None of them disobeyed. This has been actually a huge problem over my scientific career because I tested this paradigm on more than 2,000 people so far, and only 21 something sometimes disobeyed orders to send the shock to the other person. But so what is more interesting for me beyond their behavioral results is what is happening in their brain. So does obedience change something? That explains that we're more likely to hurt others when we follow orders. And so I've used lots of different techniques over the years with fMRI, electroencephalography, so to really look at the mechanism of the brain. And what I've been observed is that there are many processes that are impacted when we follow orders. For instance, our sense of agency, so the feeling that we are the author of our own action is reduced. Empathy for the victim's pain, I'm going to show you more details about that soon. The feeling of guilt, the feeling of responsibility, and moral conflict. So all these processes are involved when we have to make moral or pro-social decisions. But here what we can see is that it's not only what they report, it's really an attenuation in their brain that we observe. So just to show you, talking about empathy. We may all have a definition of what it is, but in neuroscience, it's the fact that so when we experience pain, we have different brain regions that are activated to help us process, the physical sensation of receiving pain, but also the emotional, component of I know I'm receiving pain. So what has been observed is that when we experience pain or when we see someone else in pain, our brain activates similar brain regions. And that's how we refer to empathy, the fact that we understand the pain of others because we have these shared brain activations. And that's something that in theory we all have. That's also something that is shared across species. So it's very, it exists for a very long time regarding the evolutionary perspective because we also find the same system and brain regions in rodents, for instance. And so here, what has been done was the study. So whenever they send a shock to the victim, they see the pain, and we can, evaluate how the brain reacts. And we have observed that whenever they see the pain, when they follow orders, the activation of those brain regions is reduced compared to when they are making free decisions. And what is striking here is that the shocks are exactly the same intensity, people know that, and yet their brain processes the pain as less painful just because they follow orders. And we have seen that is correlate with how frequently they make harmful behaviors towards the victim. We have also observed exactly the same kinds of results for the feeling of guilt. We also have different brain regions that are involved in this interpersonal feeling of guilt, and we have observed that their activity is reduced when we follow orders compared to when we act freely. So altogether, these findings explain, why it's so easy to change humans' behavior just by giving orders, because our brain reacts in a totally different way when it's the case. Of course, I did lots of work on classic university students because in neuroscience that's the easiest. But I also have a full line of research where I do exactly the same, but on people actually officially recognized as former genocide perpetrators or rescuers. So I'm trying to also understand by studying these people who did conduct a genocide or who did refuse, does their brain reaction differs? What distinguishes them? How can we explain that in a given society, some people accept to participate and some people refuse? I'm doing most of this work in Rwanda because that's a country where it's relatively easy to access these populations. They are still alive at the moment. And so we have done lots of studies, and one of the key perhaps I can start with that. Perhaps that's interesting. Normally I play a little game, but for the sake of time, I don't have the time here, where I ask people, like from the audience, to think in a society with political insecurity or else, if they would participate as perpetrators or rescuers. And of course, many people say, oh, of course I will be a rescuer, I will never hurt anyone. When you look at the real statistics, that's totally different. Because what you see here from the genocide against the Tutsi or the Holocaust is that you see in yellow the number of actual perpetrators, and the tiny little red line is the actual number of real people who risk their life to save others. So most of the time there is a huge discrepancy between what we think we would do and what is happening going on. But in one of the study, we also used the paradigm with obedience to authority. We wanted to see, for instance, perpetrators of genocide are more sensitive to obedience to authority, if their brain reacts in a very different way. I mean, when I talk about my research to other people, most of the time people say, oh, you just work with psychopathic monsters, because that's the easy explanation. We have to explain something that is beyond imagination by personality traits most of the time. But you cannot explain that. We have seen that psychopathic traits, for instance, they represent something like 1% of the population. You cannot explain that so many people participate in genocides just because of personality traits. And so we did a study with electroencephalography where we recruited genocide rescuers, genocide perpetrators, and bystanders. And two results emerge. The first one, interesting, is that rescuers, their brain has a higher empathic reaction to the distress of the victim. And it correlates with the fact that they resist orders more frequently. So it may suggest that indeed they are more sensitive to the distress of others, and that's what helped them to risk their own life to save others. But something very intriguing from these results is that I looked at various processes across their different brains, and I never, ever observed a single difference between genocide perpetrators and bystanders, for instance. Not at all. And I think that really reflects the fact that we cannot just explain, massive participation to atrocities by personality trait. They don't have a specific brain dysfunction. They don't have specifically a dark trait. Some of them, of course, can have it, but that's not the majority. And we really have to understand the complexity of these behaviors at other levels. So, that's to resume a bit what I have said. Something I would like to stress out is the fact that I like to prepare this talk by mentioning obedience to authority, because that's what I hear most of the time when I interview genocide perpetrators. But as I said, I was in Israel recently to interview soldiers who just returned from Gaza. And I was surprised because there, none of them reported obedience to authority. What they mentioned mostly is the brotherhood feeling, the fact that even if they don't agree with what is happening in Gaza, the fact that their brothers in arms are there means that they have to go and they have to help. They cannot just stay behind. And so this obedience to authority argument still have to define if it's a reconstruction process, because most of the time you have access to these populations only years after these events occur, or if it's also a cultural or a societal thing depending on the culture. But more to come soon. Thank you.
Well, thank you, Emily Kasper. That was fantastic. And I think clearly over the next few years, more research is going to be needed on that links sort of Anthropocene and psychology and neuroscience and these issues on as we try to figure out, decision-making processes at this huge global scale. Our next speaker is Michelle Lee Moore, who is the Deputy Science Director and Director of Transdisciplinary Education at Stockholm Resilience Centre. And the title of your talk is very much related to this, and I think follows on nicely from Emily Kasper's. It's Mind and Matter in the Anthropocene. Michelle Lee.
Thank you. Thank you very much, everybody. I just want to thank all of the previous speakers as well. It's been a very broad spanning, very interesting and rich day. I'm conscious of the fact that many of you have been sharing your life's work in a number of different books. And I'm about to share a report that we just finished on Friday. So not quite the same thing, but I'm going to do my best to share some of our latest thinking. Manjana Melkerite was the lead author on this report. Unfortunately, she couldn't be here with us today, but the rest of the co-authorship team are in the room. Per Olsen, Caroline Schill, Therese Lindahl, they're all way at the back. I'm trying not to take offense. Magnus Nyström, way back there as well. So we were in this report trying to take a look at what the relationship is between the human brain and mind and the Anthropocene. So basically, what is the Anthropocene's cognitive architecture? Because that will obviously shape how we steward in the practice stewardship in the biosphere, or what kinds of decisions we make as we govern ourselves. And I'll give a little spoiler alert that what became clear by the end of this report is that when you look at the brain, mind, and Anthropocene relationship from a complex social ecological systems perspective, it becomes very clear that cognition itself is a multiscalar and systemic feature of the Earth system and the biosphere. So what we tried to do in the report was outline the contours of the scholarship in 4 different areas, 4 different relationships between the mind, brain, and the Anthropocene, which you see here. You can hear me making this distinction between brain and mind, which doesn't totally make sense. They're not separate. But what we did find in the scholarship is that they're often treated separately. So the research that's being done on the brain as a biological organ or as a neurologically functioning system, often quite separate from the research that's being done on, say, human behavior and how our norms are shaped. And so this was our effort to start to try to build a bridge between those and integrate them to outline a future research agenda. For our purposes, across these 4 different relationships, we took 3 fairly well-documented features or phenomena that are associated with the Anthropocene. So one of them was looking at global environmental changes, climate change specifically. Another was the novel entities, which we've heard about already today, the creation of these synthetic compounds that humans are adding to the environment. And the third was taking a look at technology, which of course is a booming area in terms of thinking about how technology is reshaping the human brain and mind. So let's dive into these relationships. So the first relationship was the biophysical impact. So how does the Anthropocene actually affect the brain as a biological organ? So climate stressors, like heat stress, directly impair memory, selective attention, and reaction time. And we can see from research that's done on extreme events that some of these effects last more than a year, have been measured more than a year after an event. Air pollution has been very well studied, including other toxins and how they alter brain structure, including the areas responsible in your brain for language. So it's literally reshaping how we can communicate to each other about the Anthropocene. Air pollution has also been associated with increased risks of neurodegenerative diseases such as dementia, Alzheimer's, and a number of neurodevelopmental disorders as well. Novel entities such as PFAS, nano and microplastics, different pesticides have all been found to reach neural tissue and alter neurotransmission and accumulate, of course, across generations as well. And finally, digital technologies, which I'm sure many of us are already aware of because we're experiencing, reshape our attention, our reward circuitry in our brain, and developmental processes. And I just want to add a little disclaimer that what you're hearing today in my talk and what we also focus on in the report is a lot about the human mind and brain, but there are many parallels in the research that are taking a look at non-human cognition as well. So if you look at trees, for instance, we're all familiar with the fact that tree rings tell us how old a tree is. But what these rings also show us is so much more, and including when a tree is exposed to certain environmental stressors, such as an extreme drought condition or a pest outbreak, it actually alters the DNA methylation processes, which in turn affects whether certain gene expression is on or off, or it dials up or down certain responses of that tree, and will shape how it grows over time, how it adapts, and how it might defend itself. And these trees show these DNA methylation processes have memory. So they vary by season. So if it is exposed to drought conditions in a number of different summers, by the time the next summer rolls around, it already begins the process to proactively adapt to that. So I just want to say from a social ecological systems perspective, humans are not the only species, obviously, to think about, react, or to feel the Anthropocene. So the second relationship is the psychological one, and looking at how the Anthropocene alters the mind's affective landscape. So in previous work, we've been documenting a number of different categories of psychological effects associated with changes in the Anthropocene, and we've been referring to these as Anthropocene harms. People experience very real trauma and grief, which has been well documented from lived environmental losses. And of course, a lot of the work around climate change, losses and damages has been advancing a lot of the scholarship in that area. This can also occur due to displacement, whether that's because of resource extraction industries or whether that's due, again, to disaster or extreme events. And these impacts are also long-lasting and cross generations. But recently, what researchers have been finding is that there's not just the actual losses in anticipation of what is to come, it is also the anticipation of what is to come. So you've been hearing more and more, perhaps in the news, about climate anxiety, eco-anxiety. So this actual anticipation of what's going to happen, and this is being documented increasingly worldwide and especially among young people. So we know that actual losses and grief are happening in ways that expose people disproportionately in the global south, as well as marginalized communities in the north. But what a number of youth leaders around the world have been showing and collecting data on through various surveys is that the anticipation of future losses is actually quite a global shared experience, even if it's shaped by positionality and geography. These emotional responses in turn influence motivation, trust, and decision-making, obviously. The third relationship was related to our social, cultural, ecological entanglements, because of course the Anthropocene is mediated by culture, by spiritual realities, and narratives, norms, metaphors, our worldviews, our governing institutions, which I'm hoping Frank will speak about more in a minute, and which have been referenced several times today. These all shape how we perceive the Anthropocene. They're also going to shape what decisions we make about the Anthropocene, what is politically possible, and what we imagine for alternative futures. So these cultural constructs have been found to both increase fear, polarization, denial, but these same cultural constructs can also actually cultivate resilience, build solidarity, and mobilize agency. So it's not an either-or situation. These are quite messy dynamics, and we see evidence of both. The fourth relationship really gets into what do our minds then do with this Anthropocene. It really challenges our ability to understand and recognize global change. So human minds have mostly evolved for fairly linear problems, fairly local scale level problems, not planetary level feedbacks and the long time horizons that the Anthropocene requires, which is actually quite energetically costly in the brain. Attention, we know, again, we probably all feel this, attention is a scarce commodity, but it's competing with our already preconceived confirmation biases that we hold, and then that's increasingly being accentuated by the echo chambers that are created through technologies and social media. So this is a cognitive challenge of actually knowing the Anthropocene and what it is for different people, because I think although we're using this word Anthropocene like it's a singular thing, the reality is, and what many people have been referencing is, it is occurring in very different ways around the world and exists in different ways. There's many Anthropocenes. And so what can humans actually do about that? So I've now outlined a little bit about how the Anthropocene is changing the human brain and mind and how we even can perceive it and make sense of it. But it's not clear actually in the research yet what this means for our capacities to navigate the Anthropocene. And it's really not clear what that implies in turn for these transformations that many of us in this room might be interested in moving towards in terms of moving towards something more sustainable and more just. While we know that imagination and creativity and cognition of certain groups of people have given rise to the innovations and the technologies that we've been talking about in the many decisions that have created the conditions of the Anthropocene, what is not clear is what that feedback loop is and how that will now be reshaped by the Anthropocene itself. So we have proposed two different lenses, which you see in blue, the mind as maker and the mind as resource, as useful for shaping future research directions. So we are not clear, for instance, what the micro and nanoplastics that we now know are crossing the blood-brain barrier, what does that actually do to how our imagination functions and what we're going to be able to imagine as possible for the future. We are not clear if we are exposed to extreme heat or increasingly frequent extreme weather events, which do cause trauma and stress, which do show up as altering our brain structures and having effects. What does that actually mean for our capacities in the system for collective decision-making, for how we move forward? We do not fully understand yet the complex causal mechanisms between how something happens in one person's mind, moves through neural networks, then moves through social ecological networks, and actually may create change in an entire sector or give rise to systems. That's not clear at all yet in the research. So causality, scale, and this recursive feedback relationship between brain, mind, and Anthropocene form the basis of the research agenda that we outline, and which you can check out in this using this shiny new QR code. So we suggest that there's a lot more that remains to be a frontier to explore and understanding the brain as nested in the very biosphere that the brain is simultaneously contributing to changing. And since we finished the report on Friday, we obviously have lots of time left on our hands now. So if anyone is interested in talking with us about the next steps, we're all here and we'd love to chat with you after this session. Thank you.
It's David. We're going to have the next speaker, Julia, soon, but we need to set up the link, right?
We do. It's going to take a minute or two, I think.
Yeah, so we probably have a couple of minutes or so. But thanks a lot. And I can say, like, what a fantastic work you're doing, like that. But I'm part of the report, so I'll take it a bit easy with that. But just to say that it's a really, what I like about it is that it brings a focus to the human nature relationship that we need to be a fundamental part of the transformative change that we talk about. It's about changing that relationship as well as the relationship to ourselves and others. So thanks for bringing that out. Do we have Owen? Okay. Since you're in charge of the whole thing, I'll give the word. Else. No, but go ahead.
Well, because it just occurred to me as well as you're talking, like when you're doing this research for it. So there's going to be some big research areas already doing a lot of work on this, on heat stress and air pollution. But then clearly in other areas, like what's the research? Is there coherent research communities around? Things like psychology and the Anthropocene, or some of these things Boom Soon Park was talking about earlier, like this compressed modernity, this like speeding up, and how we're coping with that. How are these research areas evolving?
Yeah, that's a great question. And anyone else in the report jump in and save me here. But I think, yes, all of the four relationships that we were looking at, they are very well established. Not all of them are necessarily framing it as a relationship to the Anthropocene, though. And so I think that does still shape how coherent it is and how much we can kind of build on it. A lot of, and I think especially we were talking about the harms, and again, and I was mentioning that the kind of push to document a lot of this has been due to negotiations around reparations, around losses and damages. But the psychologists, with regards to the anxiety, they're still debating about whether this is something you can actually diagnose and treat, or whether this is actually a reasonable response to what we're bearing witness to. And so there's like real differences depending on which piece of it you're looking at. And I think, in terms of the temporality and the compression, I would say I don't think that we came across that, although I'll turn to others. Yeah, I'm getting nods. So I don't think that is a piece that we're seeing a lot around. And so I think that's what we were really calling for. I think that would require a much more interdisciplinary approach. And so I think that's what we were trying to say, is we need to start bringing these things together to try to take it. And we think that would actually be really exciting to kind of take it from that perspective.
Yeah, and I'll like links then. Thank you very much.
Can I sit down?
Yeah,
okay.
I think we have Julia with us online, and I'm just going to introduce you, Julia, and then I'm going to give the floor to you. And Julia Steinberger, she is a professor of societal challenges of climate change at the University of Lausanne in Switzerland. And here, Anders, I know that you're going to like this, because this is what you asked for. She's going to talk about a new economic paradigm beyond growth. And I think that, Julia has been working on this extensively, as you understand. And she has also then, a part of focusing on this topic, also been doing a lot of thinking about how do we live well within limits. or within the planetary boundaries. And she also have done an extensive work around the world, including being the lead author for the IPCC, the 6th assessment report. So with that, Julia, the floor is yours.
Hi, everybody. Thanks so much. Thanks, everybody. Thanks so much. And I've been able to follow the 3 previous talks, and I'm absolutely blown away. So it's a real privilege to be in the room with you all. Luke, I've been reading your book, so I decided to just start with that because I absolutely love it. So I'm just going to start with some quotes. It's nice not to be the one saying these things myself. I can just quote you now. So economic growth is one of the few factors that pushes against each of the planetary boundaries. Economically, every country is now capitalist, and we live in this sort of very coercive, rule-based system that is run by international institutions. So this is true. And so basically, one of the things that we're finding out is that our economy is certainly a manifestation of the current system and our Anthropocene problems, let's put it that way. So just to add to some of those aspects, so one of the things that we can say about our current growthist economy is that it's extremely unequal. It is an inequality generating machine, both in terms of wealth and power, because wealth does something for people. It actually gives them a lot of power. We know that within countries, we know that between countries in terms of things like unequal exchange between the global north and the global south. One of the things that maybe hasn't been mentioned yet is that this economy creates coercive dependence. So one of the things that we can see is we have an overproductive economic system that in fact imposes overconsumption. So the choice whether or not to overconsume is really taken away from most people, and this is done via lobbying, regulation, advertising. Examples like car dependence come to mind, so the creation of car dependence via infrastructure choices and regulation. Or, for instance, now we see it with AI as well, right? Where AI is sort of being forced upon us whether or not we want to use it or not. It's just sort of being imposed via integration in different programs, etc. So one of the things to understand here is that the creation of resource-intensive dependence is, I would argue, the main industrial product of our time. We really see this deployed across lots and lots of different sectors. And the other thing I would say about the growth economy is that it's fundamentally anti-democratic. Now, of course, this goes against the grain because there's been decades and decades of this rhetoric around market freedom. But lots of scholarship is coming out, including quite recent scholarship. For instance, Naomi Oreskes and Eric Conway's latest book, that it really explains how this market freedom rhetoric has been used and deployed to protect capital and, in fact, prevent democratic, social, and environmental oversight. And I think that this is something that we really need to come to grips with, is how coercive and anti-democratic our current economic system is as well. And what that means is that the most important decision-making, which is economic, is removed from the political realm for a lot of us who live in democracies, including in these kinds of cases. Okay, and I have to make the obligatory point that green growth is not happening, even in the cases where a few rich, over-consuming countries are doing things like absolute decoupling. It's not happening fast enough. This is a paper by colleagues Yefim Fogel and Jason Hickel, which is just sort of a recent version of this. But one of the things where they sort of go through the numbers and explain what would be necessary for Paris and what is in fact happening instead within these countries that are in fact reducing their emissions while growing GDP. It's just not happening fast enough at all. And then the question becomes, what should we do? What can we do? And they say that we should, not a surprise since they're colleagues, pursue post-growth demand reduction strategies, reorienting the economy towards sufficiency, equity, and human well-being, while also accelerating technological changes and efficiency improvements. Okay, but that begs the question, what do post-growth strategies reorienting the economy towards sufficiency, equity, and human well-being mean? And in order to try to figure this out, we have been developing this research program around post-growth with this concept of provisioning, which is both, it's actually a concept from heterodox economics, not mainstream economics, that considers economic processes to be both social and technical and political and economic together. Okay, so the whole thing. And we argue that provisioning is the linchpin between planetary boundaries and well-being. So when we're talking about rethinking the economy, we're talking about understanding and rethinking provisioning. What does this mean? So a lot of my research has been on provisioning of a certain specific kind and well-being, which is the provisioning and use of energy. So I'm just going to give you rapid fire some research results on that topic. And hopefully I included references if anybody wants them. Obviously, we don't have time to go into detail. So you're just going to have to trust me on some of these, even if they sound counterintuitive, but the references are there. Okay, so when we look at the links between energy and well-being, the first thing to understand is that there's saturation. A little energy goes a long way. Past a certain amount, it just does not matter anymore. And this is a result that's been known quite a long amount of time. The second point is slightly harder to grasp. And I don't think that we've really grasped it yet, even though I did publish this paper, 15 years ago. Okay, which is decline, which is that the energy associated with high well-being has been dropping massively over time. So we're seeing massive efficiency in terms of the amount of energy it takes to reach high human well-being, pretty much no matter how you measure it, either the energy or the well-being. This is just sort of a general trend. And you can think of it happening for a multiplicity of reasons, technical efficiency, social organization, healthcare improvements, a whole bunch of things. The other thing we see is inefficiency. So we have growth in energy use on the one hand, we have improvements, say, in life expectancy on the other, but one cannot explain the other, even just statistically. So the growth in primary energy can only account for a quarter, so statistically explain a quarter of improvements in life expectancy over the past decades. And that's quite a counterintuitive result because we tend to think of growth in resource use as progress, and here we see that that's absolutely not the case. We can do a lot better with less, and apparently we're not using this stuff particularly in a focused way in terms of well-being. And the fourth one is something that we were able to really show, thanks to the pioneering work of Narasimha Rao, among others, is that universal human need satisfaction is possible, technically possible. We can think of what is required to satisfy human needs, to achieve well-being, and it really doesn't take that much energy to satisfy decent living standards, given highly efficient technologies and infrastructures that are available to us now or in the near future, for, let's say, so the energy for everybody to reach decent living standards in 2050 is less than half of what we use now in terms of final energy. So that's a huge, huge shift in the way we try to think about things. It means that we can actually understand what it would take, where we are now, and how we're misusing things. But degrowth is technically possible, so that's a big result. Okay, so I hope you believe me on those four things, otherwise please look up the papers. So now I'm going to go back to Luc and his amazing book to talk about well-being, and I really love this because it just explains it so succinctly. So, the question of improvements of well-being over time, in a lot of respects, it seems that most societies have regressed since egalitarian hunter-gatherers. The selection pressure for our societies was never for the societies that were the best at maximizing the welfare of their citizens. We've maximized for brutality, for military might, for economic might. We have not maximized for welfare. That is not the selection pressure. And when we see welfare improving, we have to understand that it's not business as usual. We have to understand it as the result of organized social and political effort. And the quote from Luc is, "What eventually caused industrialization to translate into shared prosperity was shared struggle." And I think this is an absolutely crucial point to take forward. So what does shared struggle look like? Because that's something that we sometimes have a hard time visualizing. Shared struggle looks like what Luc was talking about. So going back to Christopher Broom's work in Hierarchy in the Forest, shared struggle against inequality is possibly the most important part of human heritage, intelligence, and history. That's my interpretation of it. The technical terms are things like counterpower or reverse dominance hierarchy. And, Luc already explained it, the community acts as a coercive apparatus to prevent dominance from emerging. So what does shared struggle look like? Well, shared struggle looks like a lot of things. It looks like egalitarian societies. It looks like past struggles that we might be familiar with or idealize a bit, but they were struggles, okay? Like people fought, got jailed, got killed, from women's rights, suffragettes to the civil rights. So this is the Black Panther free breakfast in the upper right-hand corner. We have trade unions and strikes. I'm actually wearing my trade union button because we're striking right now these days. Not today, I wouldn't be talking, but in general, we're facing a difficult situation here. We're talking about civil resistance. We're talking about things like slavery abolition and decolonization. So this is part of the human story. It's part of our story. And the question is, are we able to activate that part of our story now at a whole different scale in terms of turning this time of the Anthropocene around? So I would argue that post-growth and degrowth economies are part of this shared struggle for well-being within planetary boundaries. We're starting to decline these quite well in terms of agendas, emancipatory agendas for both low and middle income countries and for high income countries, talking about what kind of development, talking about reprioritizing economic sovereignty and getting away from unequal exchange and towards sufficiency and fairness on the other side. We're able to sort of decline whole aspects of different policy proposals, including, maybe I'll just point to the democratic system change, so number 3, which really calls on economic democracy to be deployed. So I completely agree, democracy is the solution, and it's democracy at every single granular level within firms. That's really important. But there's a whole bunch of different policy packages that apply in different ways to global North and global South countries, and this is a recent sort of drawn from a recent contribution that the Real Project made to Olivier de Schuiter's UN Roadmap for Eradicating Poverty Beyond Growth. And so I would just end with this, the basic goals of what post-growth economies look like is we're talking about going towards equality both in wealth and power. We're talking about policies that guarantee basic minimums, so universal basic services or universal basic income or some combination, job guarantees, wealth caps, etc. We're talking about convergence between North and South, delinking, which means escaping coercive international debt and structural adjustment programs, etc., policies and reparations. We're talking about well-being within planetary limits, which means talking about repurposing the economy, talking ecological generation, investment in efficient and protective infrastructure and technology development as well, and especially democratic at all levels. So there are various proposals around democratic planning, there are proposals around anti-fascist economics, and also about mainstreaming democratic decision-making within the economy at every single level. So I will leave it there, and thank you so much for this amazing event that you've organized.
Wow, thanks so much, Julia Steinberger. That's fantastic. Now we're hoping to bring you back for questions at the end, but you need to switch, I think, to your YouTube now, so then we can move to the slide deck for the next presentation. It's all good, but thank you so much. So our next speaker is Professor Deliang Chen. And Deliang Chen, who spent many, many years in Sweden at Gothenburg University, is now currently Tsinghua Distinguished Chair Professor at Tsinghua University. I'm hoping I'm pronouncing these correctly, specializing in Earth system science, climate change, and its impacts. Deliang Chen is a fellow of 7 academies of sciences worldwide, including the Chinese Academy and the Swedish Academy. And he led the Earth System Vision exercise that led to Future Earth between 2009 and 2021. And you're going to be speaking today about the ecological civilization from an Earth System perspective.
Thank you, Owen, for the nice introduction. Also, thanks to the organization committee for inviting me. And basically, they give me the topic, and I have to say that ecological civilization is not something I'm studying, but I have learned so much, so I should have put actually in acknowledgement the World Economic Forum, because they brought Johan Rockström and Professor Zhang from China, who is an expert in this area, and me together in a dialogue, try to talk about this and also other things like planetary boundary. And I think they have a nice title of this event that was recently, which is called Delivering Ecological Civilization Within the Planetary Boundary. I thought it was a beautiful title. Also something I want to study in the coming months, and we'll do this together. And so I have to say also that I will do this from a biased point of view. I put my former job here because I'm very much influenced by my job as director of the International Science Council, and which basically coordinated the global research programs like IGPP. And so I also put this as a background because you can see that if you look at the history of this Earth system science thinking, and personally I grew up through the whole process, and especially during the last few years, I was lucky enough to be in the process to look at all the 4 programs and try to create something new. To me, what's amazing is that actually we started looking at this issue of basically the Anthropocene from the scientific point of view, and also individually. We started from the World Climate Research Program, which is very much focused on the atmosphere. Then we started with IGBP, which in the beginning was very much on the geosphere, biosphere, but of course I think IGBP has become really Earth system program very soon. And then finally we saw that, wow, we forgot the human dimension. It's amazing to me. It's, the human dimension was really came out very late. That's also a reflection of how scientific community has been reacting to the problem we are facing. We do this one by one and discipline by discipline, basically. And finally, of course, 2001, we realized that we have to put everything into a system. Then ESSP was created, but then there was some issue with that. And so finally, I think during that period of time between 2009 and 2010, there was a visioning exercises, which created the future Earth, basically. And with this paper, which I look at actually the main point of this paper again, I still feel like it's still valid because the ground challenges that has been outlined is still valid. And also more importantly, I think this is the first time explicitly we talk about Earth system science, not for science, but for global sustainability. This is a very strong statement. And that statement actually brought whole science to the Rio Plus 20. And I was lucky enough to be the coordinator of global scientific community for the Rio Plus 20 process. So I put together a report and then to the Rio Plus 20. And also we wrote this paper, very short paper, but I think it's still very powerful because the 5 ground challenges we outlined here, I think it's very much has been taken up by Future Earth to look at you can see the forecasting, observatory, confining, which is very much about tipping points, and also responding, which is very much about the governance that we are talking about now. So I'm very happy. And also innovation also is very important aspect. At that time, Rockström talked to me very often because when we talk about innovation, people usually think about the technological innovation. But what she means is that actually we have a lot of innovation to do with how we organize society. I think that is fantastic. And so what is ecological civilization? So I try to summarize, and I read in the last 2 weeks after I got this job, but also talk to the experts, of course. I think to me it's 3 things. Number one is it's a philosophy actually, very much oriented from the Oriental, not only Chinese, but also Indian, Japanese, Korean, and so on. That is about relationship between human and nature. That is something really, because in Asia, I think we struggled with that relationship for much more years, I would say, than people in Europe. So that is there's a belief, there's a philosophy, we have to live in harmony with nature. That is the origin, I would say. And quite interesting, this concept entered the Chinese policy discourse in the mid-2000s. And actually, after an academic paper published in Russia, actually, which is also interesting. Mm-hmm. And so in a few years later on, the Chinese took the leaders took up this idea. And not from Chinese researchers, from Chinese leaders, political leaders. That's also something unique because we know the system is such that many Chinese leaders are scientists and engineers compared to other political systems. So many of them are very knowledgeable. And so they took up idea. And then the whole thing was institutionalized, was written in the constitution of the party. Can you imagine? Communist Party, of course, that we have to follow the kind of concept. So that is a little bit the history of the evolution of the concept. I show you this nice photo because you are in memory of the Potsdam, who was my supervisor. And I remember in 2012 when I gave a talk in KIT in Karlsruhe in Germany, and he came from Mainz, took a train, because he wanted to discuss with me the innovation part. He's an engineer, and he's very much like to solve the problem. And so he was also somebody who proposed the first idea of geoengineering, if you know that. So the core principles of ecological civilization, as I understood it, the first one is that it has a very focus on ecological priority. So nature has to be put in more priority than just human economic development. And also, second part is that we need to have a transformation of the system, to have green development. I will show you this is really what's happening in China over the last decades. And the harmony between nature and human is this kind of philosophy has been also tried to achieve that. And also long-term stewardship, because of the leadership, because of the management, the kind of power of the political system. And finally, I think this is also something I think is very useful. They have a kind of whole of society transformation, not just one sector, including actually value. I will also say a few words about that. By the way, that is not my summary. It was summarized by somebody who was published. Sorry, I have to go back for that. This is to this gentleman, Scott, who summarized this nicely, I would say. Also, it's quite consistent with what all the literatures I have read. It is, if you look at carefully, I think this concept is really a response to the Anthropocene, because it started with recognition of the humanity's planetary impacts. And China has suffered a lot from air pollution, for example, as you know. And also emphasize on system solution. That is also very much, China is kind of led by engineers, if you want. And also, in my view, it aligns pretty well with Stockholm thinking because like planetary boundaries, the property space. That's why we had a very good discussion with Johan about this, that the two concepts could be combined, or at least we can discuss with this combined framework. But there is a difference. The difference is that the first part, the Earth system thinking, is very much focusing on the diagnosis of individual environmental issues. We look at different indicators and so on, in a scientific way, I would say. While the Chinese concept is very much from a normative vision. It has values, it has a governance dimension. It basically is management of the environment. But maybe putting them together, I think, can be a powerful way of moving forward. This is why the World Economic Forum is so interested in bringing people from two worlds together. And we want to also create an agenda for the next World Economic Forum discussion. So this is the slide from the Professor Zhang, who was an expert in that. I asked him to summarize what's the difference. So he said that basically it's about from industrial civilization to ecological civilization. So they see kind of our time as with different civilizations. We start with agricultural civilization, then we have industrialization, and then we realize the need to actually to think about ecological civilization. So if you look at the economic model, which I'm not very good at, basically you have nature and the economy separated. We take resources from nature and then we produce something, etc. But very much that the economy should be embedded into the nature. That picture reminds me a lot what the car folk usually talk about when we talk about sustainability. You know, you not just have three pillars overlapping each other, but they have environment as the biggest one. So I think it's quite similar to me. And actually, that brings some results. That is the work we did some years ago. We took the SDG indicators. We look at how China has been doing. I can tell you most of the indicators showing China is really moving towards sustainability, except the one, that is the difference, the income difference between the poor and the rich. That is not doing well. But other things like education, countryside versus urban areas, like women, difference between women and men, etc. All these are improving dramatically. I'll just show you one example here that is showing basically the coupling between the economic development and environmental degradation. Already around 2010, there is a sign that the two started to decouple. I would say this is very interesting phenomenon that we typically think that the economic development, especially in the beginning of a developing country, is already associated with the degradation of environment, which was the case in China, but then around 2010. I really want to repeat this study again if I have more data later on. But I think it's clear that there is already some decoupling. So this is kind of summarizing the concept. With the old model, you are basically, for example, for climate change issue, you try with the old economic model, you try to get a balance or trade-off between the emission cost, cutting mitigation cost, and also the benefit for the environment. And Northern Horse model shows that you can get up to 2.5 degrees something to get the maximum. But in this new model, you have to look at new ways for the economic development, the green one. So I think that is basically the idea of this ecological civilization. And this is my last slide, I was not economist, I'm a climate researcher, but to me it's a very interesting plot because it shows the energy use and the well-being. You see that in the beginning it's really a steep curve, as my previous speaker said, but then it's kind of get saturated. And that brings me to my point, last point, which is when we look for more economic development, we have to think about the cost for the environment. Is that really worth of having more energy or use more energy or become more rich? But at the same time, we see that there's not really big effect, actually, of some level. So with that, I stop here. Thank you for your attention.
Thank you so much, Dillian. I've been told to hurry up because we need to round off. So, but there will be time for conversations afterwards and also tonight. I'm going to introduce Frank Bierman and come over here, and who is the last but not least speaker for the day. I just want to say something about, we're in a hurry, but I just want to say something about, I've known you for a while. And so you're a professor at the Global Sustainability Governance at the Copernicus Institute of Sustainable Development at Utrecht University. And as we know Frank, of course, from his work, and he's the founder and first chair of the Earth System Governance Project that I'm sure that most of you are familiar with. So focused now, which I think is a good, going from constitutions and things at the national level, we're going to address the international institutions. And I know you want to start. And but I just want to read the last one in your bio. It's like, in early 2026, he is launching a new international panel on Earth system governance.
We'll talk about that.
Dot.
Oh, you cut it out.
I did
Okay,
that.
thank you. Good. Thank you so much. I mean,
Thank
so
you.
it's a pleasure being here. And being the last speaker before color is kind of really sending us over the bar. It's also my honor to say a fantastic workshop so far. I really learned a lot from all the presentations. It was very interesting here in the room and online. So it was really fantastic. And I might say so because I'm the last speaker before we ending. What I want to do is I want to lead back. Okay, which is this one? This one? The big one. Oh.
Yeah.
I want to lead back to the main point. What we started today, this morning, is the Anthropocene. And the Anthropocene turned 25 years ago. That means it is no longer a baby, it's no longer a toddler, it's no longer a teenager, it's a mature adult in a sense. And I learned also this morning from Gordon that it has also a child because the Stockholm Resilience Center was claimed to be a child of the Anthropocene, so it is already a parent. So my task is a bit to, I'm a political scientist, to take the Anthropocene a little bit in a conversation with political science. And the question for me is, what did we learn in political science from the Anthropocene? How has political science been introduced, and how maybe also, what's the view of political science of the Anthropocene? Sometimes I also have some critical comments to make in the last presentation. Starting with, there has been, of course, an influence. I mean, political science has been debating these things for quite a long time. And you see it from all these terms that are popping out our conferences, such as Earth system governance, Earth system law, planetary politics, Anthropocene politics, planetary governance, etc., etc., etc. So many different concepts. I must honestly say that many of them are pretty much the same. Different people from different communities, different books, different research communities, trying to address all the same issues. How can we refigure law, politics, governance, policies in the Anthropocene? What does it mean? What do we really have to change? And this is a huge debate that, and Per's mentioned this, we try to understand also in the Earth System Governance Project, which is a large community where we bring together all the social scientists, or many of the social scientists, discussing these issues and trying to move forward. And what are actually the lessons we can learn? What are the contributions we can do? What are the transformative changes that we can influence with political science and with legal research in this field? But I also want to add a little bit a point of criticism, in a sense, from the political sciences. It's not criticism, because this is a birthday party, so these are challenges, I would say. Challenges which are a little bit like the Scylla and Charybdis, which are like the monsters that are threatening the boat of the Anthropocene scholars, which is, Colin, here you are. These are the Anthropocene scholars, the Earth system scientists, those who are working on these issues. And left and right, there are monsters coming up and kind of things that one has to take into account when one engages in these debates. And I have 3 points to make. And the first point is that the Anthropocene actually is not the same as humankind. I think that is a very, very important point that we have to make. And that is a point that the humans, I mean, it was a bit also mentioned in some presentations, if you take one of the typical Anthropocene framings, the narrative of the Anthropocene, that humans could trigger severe consequence of the Earth's environment, and that this can lead to negative, to harm to humans. And these are 2 times mentioning the term humans in the standard Anthropocene narrative that are not all humans. There are some humans only that are causing the problems, and there are some humans that are predominantly suffering and will be affected, and they're not the same humans. And the main point is the Anthropocene, the we, is a fallacy. I mean, it is not there. There is not one humankind that are causing all these issues. And we have seen all these kind of graphs. This big graph of Oxfam of climate change, for example, that shows that only 10% of humanity, the richest 10%, are causing 50% of the emissions in climate. It's a bit different for some of the other planetary boundaries, but this is a very, very important point. The Anthropocene is actually a problem caused by the red ones, by the 10% or the richest 20% of humankind, and most of the others are not really involved in causing the Anthropocene. So that means it is essentially an issue of justice, of planetary justice, and that, I think, is one of the key conditions when we think and talk about the Anthropocene, I must say, as a challenge, I missed it a bit today. I mean, I think quite a few presentations were on humans, and again humans, and the big we, and not many have talked and tried to conceptualize the justice part, the exploitation part, the oppression part, the violence part into the presentation. So I think for the future, I think that is one of the little monsters waiting for Anthropocene science to really bring these two together. Number two is the role of science. I think that's a very difficult one. We had a little bit impromptu discussion this morning with Johan here. What is the role of science in this entire matter? And my proposition is that scientists have become much more powerful in the Anthropocene. And this is because of the uncertainties, because of the complexities that scientists, and I have put here some photos of the IPCC and IPBES, but it's also individual. It's not necessarily the big assessments. It's also individual scientists, individual groups, individual institutions also that have become very powerful by framing, by analyzing, by understanding, but how to conceptualize these kind of issues. And that gives a new source of power, political power to the scientists. And I think that's a big challenge that needs a reflective process within the scientific community. And also for the Anthropocene Earth System science communities. What are the responsibilities for scientists? What are their accountability mechanisms? Exactly this word was mentioned this morning by Johan Rockström also. What are the self-limitations? And there are a couple of different extremes. There's the extreme of self-restraint, that you just don't say anything anymore as long as it's scientific. But there's also the risk of scientocracy. And that means the scientists becoming too powerful and trying to take away or trying to take over power in decision-making processes. The same way in which Supreme Courts or federal banks are taking decisions outside the democratic process in a way. And I'm sometimes afraid the scientists get into this direction. This idea about we can fix all the problems because politicians are all kind of corrupt and stupid and whatever it is. So therefore, we need to have more power because we understand and we can run it. And the other is, of course, scholar activism. That's another debate. Also was discussed this morning. Do we need to have an understanding of science out of the ivory tower, being more active in political debates? And that's also a debate about how do we understand the role of science in these debates. And one important boundary condition for that is also the global disbalances and injustice in the scientific community. And this is some research we have done at Utrecht, where we looked at data, we looked at citations, we looked at memberships in international commissions, we looked at conference participation in the field of Earth system science, however you want to define it. For example, we looked at the Global Sustainable Development Report, quite an old one, which is the main UN publication in this field. It can't be more diverse in a sense. But if you look at the citations, only 1% of the citations refer to an institution in the global south, in least developed countries. 87% of all the cited work has been produced in an OECD country. And the same as when you look at science networks, we looked at all kind of conferences, which we looked at 10 to 20% of the participants are from the global south. The same as if you look at academic journals, where the editorial board or publishers, whatever, is largely these are OECD journals. And I put this also to me. I run a journal, the Earth System Governance Journal, and we suffer from the same problems. We always say we are better than the others, but we still have a lot of work to do to become a really global community. And that is, I think, very important when we consider the role of science in the Anthropocene and Earth system science and all these kind of debates. And my third point is the technocratic fallacy, I call it. And that is, I mean, you've seen this graph, of course. It's a very famous one from the 1980s, which is kind of the, so if you start thinking about the Earth as a machinery, nobody would use the word machinery here in a sense, but I mean, the thinking about the Earth as a machine, the thinking about the Earth as a machinery might lead also to reflex, not necessarily by the scientists, but by politicians, by others in the sense that if there's a machinery, we need an engineer. If it's a planetary machinery, we need a planetary cockpit. If this is a spaceship, we need a cockpit. We need Captain Kirk. And we need Mr. Spock. I mean, Captain Kirk, this kind of strong male Canadian who's steering the ship, and Mr. Spock, who has the full understanding and tells him what to do. So this is kind of a threat in a sense that these ideas about an Earth system as such can lead in some communities to reflexes of the the Captain Kirk fallacy. And it has two elements. Number one is that's called, was sometimes called the Captain Kirk delusion, Captain Kirk disappointment. These are those who are criticizing the cops, for example. These are people, sometimes journalists, who believe the cops are Captain Kirk. This is a cockpit, and they're totally disappointed, coming back and say nothing has happened. But the other problem is what has already been mentioned by Deljang, is geoengineering. And that's one area where I spend quite a bit of time opposing it, because I believe that geoengineering, especially solar engineering, is one of the biggest risks in a sense, and it is related to the idea that the Earth system is a machine that has a cockpit and that can be fixed by smart people. Instead, I believe that geoengineering in the real world, in the real United Nations of our time, can never be managed, never be governed in a just and effective manner. I believe also that talking and researching geoengineering essentially leads only to a delay and a derail, and it harms the Paris Agreement. It destroys the current climate policies because it will give new incentives of not doing anything to oil, gas, coal, those kind of countries, those kind of industries. And also those scientists who are investing their time in geoengineering, who say, I don't want to have any harm, I'm vegetarian, I have a bicycle, I like environment in a sense, they will not control it. Those who are producing engineering technology right now, it will be taken over by Elon Musk, who has just tweeted about it 2 weeks ago, by Putin, Trump, and all these folks at some point. So therefore, I argue that we need urgently an international non-use agreement on solar engineering, which is kind of a treaty that bans the development of these kind of technologies, which is a proposal supported by all African countries, together by Kiribati, Fiji, and some other countries. And if you want to know more, you can go on this website. We called for an open non-use agreement on solar engineering. There's also a take action button for those who are really interested. And I think that's an important part, also related for the Earth system science Anthropocene community, because essentially this is a debate that needs to be had. It's a very important part of the Anthropocene discourse. Is this make sense, or am I wrong maybe, and some other solutions have to be taken. So I think in short, to cut it short, I have 1 or 2 more slides afterwards, if I may. I believe that the Anthropocene has also its problems. It tends to make all humans equal by pretending that there is a humankind which doesn't exist. It might, I'm very careful in my framing here, so it might, not necessarily, downplay or hide issues such as capitalism, gender, oppression, colonialism. It might support planetary techno-managerialism in the wrong hands, and might even lead to geoengineering. So I think the politics of the Anthropocene and also the politics of earth sciences are very, very important to bring in, like an idea about planetary politics. I think are very, very important to be part of this discussion, and not necessarily only in the last presentation, but also in more presentations, I think. So good. And that means also we need to have a new politics, and this is what we try to do in this Earth System Governance project, where we try to invent new ideas of politics that kind of help us forward and try to create a world that is more just and more democratic. I'm fully agreeing also with what Julia has said about it, the need, and also Luke, about the need to have democracy in the economic system at the planetary scale also. There's lots to be said about it. It's not getting easier. That's one of my own challenges. So I try now to understand how can we understand planetary politics in the age of Donald Trump and all the other people who are now running our countries in many ways and kind of systematically destroying everything that some of us have argued for 20, 30 years. I mean, that's kind of, so what do you do with these kind of things? Not only Trump, of course, it's a larger right-wing movement in many ways. This is what we're doing in the Earth System Governance Project. And the last slide will be, so it's a network, you're very much invited to join us. The next conference is held in September next year in Bath. And the new activities that has been mentioned already, which I think but I'm really very, very enthusiastic about, is a new idea to set up an international assessment program, in a way, on Earth system governance, because we do not have that many cumulative assessments in the political science in Earth system governance. We have lots of researchers. They all do fantastic work, but they do it alone. They do it here, they do it there, they write a book, they write a paper, they develop a new concept, sometimes a special issue, an edited volume, a little workshop, but there is not accumulation of all the knowledge we have. It's not like what has been done in a sense in IPCC or IPBES, these more specific ones, where people really assess the entire knowledge peer-reviewed by hundreds of scholars, thousands of scholars, these kind of sentences like an IPCC, high likelihood or so. This is not really done in political science, where 200 people are saying with a high likelihood this is the case, or not the case. And that's what we want to do. So we're putting this forward. We want to bring together the entire network of 700 Earth System Governance scholars. We are very generous also for the Global Challenges Foundation that is supporting this. They're no longer here, I believe. Anyway, that's kind of what we want to do, and this is also my personal story for the next 2 years when I'm going home after this conference. Thank you so much.
Thank you. There's only one Frank Bierman. That was absolutely fantastic, Frank. My favourite Swedish phrase is "tid optimist," and I'm very much a time optimist, and which means we've run out of time, and so we're not going to go to questions in this session. I apologise to Julia online for this particularly, but I'm going to invite Carl Folke up for some closing remarks. Carl Folke is the Director of the Bayer Institute for Ecological Economics and the co-founder of Stockholm Resilience Centre, and currently the chair of the board of Stockholm Resilience Centre, and one of the most cited academics on the planet, and the leading expert on social ecological systems thinking. Now, so you're going to, and then I shall just say that then Wendy Broadgate will say a few words to close the symposium. Over to you.
Thanks a lot. I'm just going to do it very short because we're a little bit late. But if you can imagine that Paul Crutzen and Will have been here, they must have been super happy about this. Can you imagine moving from concept to what we heard today? The enormous diversity and spectrum of really good scientific work, from understanding really the natural sciences dimension of the Anthropocene, all the way to the governance challenges and everything in between, basically, from mental health to challenges for our own species and so on and so forth. I think that's quite fantastic. And I think what becomes really clear is, first of all, if for the young people here, I think this is a really exciting time to try to understand what really goes on in the world. It's a unique time for new discoveries that because of the turbulence, because of the complexity and things like that. So it's very exciting, and especially if we can combine disciplines more actively than we do and focus on the real major problems, which I think we have really shown today, all the interfaces that are interacting here. So I think that's really cool. But what becomes really clear is, of course, that the Anthropocene is different. It's not just a changing game, actually. It's a changing playing field for the whole game. And I think that's really important. And I think there's a lot of disciplines, a lot of actors also in our fields in science that don't get that really yet, that it's a changing playing field. It's different from what we had before, which also challenges the methods we used, the tools and techniques we have developed. We also have to figure out how to capture these new dynamics. So I think that's really important. The other point I want to make, which we sort of have in this meeting, but not all the time, I think, and that's what Johan mentioned of the intertwined systems of people and nature. In my view, we can't think of people as coming to the planet outside, landing on it. It will be an external driver to it. We obviously have evolved on the planet with other organisms. We have them in our bodies. We even have a bacteria that has the origin before the oxygenation, great oxygenation in our intestines, things like that. We're really embedded in with life on the planet, whether we think so or not. And I think we created mental models to say that we are not so, that we are sort of unique and not dependent on the rest of it, but we are really embedded in the biosphere. We're not just living on the planet, we are beings in the biosphere. With the biosphere, I mean more than plants and animals, I mean us in it as well, and what we do. And our technologies, Johan and I talked about that, are also part of the biosphere, but has expanded enormously into it and shaped it enormously. So I think that's another really important ontological dimension, which I don't hear fully 100% yet today, actually. But I think it's absolutely fundamental if you're going to have a chance to ask the right questions. So I think that's really cool. And the last part is that there is hope, and more than hope, actually. And I think that I started in the early 80s with this type of stuff, and at that time, there were an enormous gap between social sciences, natural sciences how people thought about the economy, how people thought about nature. Now it's completely different. I think many people and many sectors that I never thought would interact with this. Can you imagine? You have over 100 central banks in the world that are thinking about macroeconomic risks because of climate and biodiversity loss. Happened in the last 5-6 years, in the last decade. You have finance and a lot of actors in the economy that are addressing these type of topics. Didn't exist if you go back 5 to 10 years ago. I think we are in a revolution right now, in a cultural revolution, or evolution, some people would like to call it, rather than revolution. But I think it's a big shift that is happening, and we're in the midst of it. And I think our work is becoming much more important than ever because of that. Because now the future of our species, we in the different dimensions that Frank talked about, or right now determining the future of our civilizations on the planet, actually. And of course it could go really bad, but it can go also really well. So right now is the time to really mobilize and act on the insights we have and try to steer this ship in the face of these dragons or whatever in the future in the right way. So I think we have a small place also here called the Anthropocene Laboratory, where we're experimenting with the hoop. And actually there is some interesting work, if you look back at several decades, of really big positive change that has happened in relation to both in relation to governance and law, both in relation to economy and finance, in relation to health, and so on and so forth, that actually have completely changed the trajectory from degrading the situation to improving the situation and becoming more and more of stewardship style behaviors on the planet. So there is positive change going on, and we have to nurture it and support it and act on it and create excitement for people who anywhere in the world, I think, actually, to operate with the planet that we're living on and for a prosperous future. Okay, some few reflections. Thanks.
Thank you, Kalle, and thank you all. I would just like to wrap up. This has been such a fantastic day. My brain is buzzing with all these talks and all these potential new collaborations. I think quite a lot of new collaborations have been sparked out of today's discussions. So I'd just like to say thank you to all the speakers. If we could have the next slide, I would also like to thank all of the sponsors of this event, so the institutions that have been behind this event, including the funding that we've received from Bröderna Jakob och Marcus Wallenbergs minne. Thank you to all those. Thanks to the Science Committee that were a great sounding board for bringing together the ideas. Thanks to Owen, who actually took the initiative to come to these institutions and suggest this, and has been quite an engine of ideas behind the setup of today. But my big thanks go to the organizing committee, and I would like you to stand up. Many of you are in the room, some of you are not in the room because we have another activity this evening, but Jakob, Marie, Frank up at the back, Astrid, Fredrik, Per, Veronica up there, Camilla. It's really been a lot of work to organize this, and I'd like to say thank you.